If your SAP ECC to SAP S/4HANA migration survives this phase, it might actually go live.
Part 2. Build data and conversion failures.
In Part 2 of this series, we move from blueprint and design into the technical execution layer of SAP S/4HANA migration. This is where architecture decisions made during Explore are translated into code, data, and system behavior. At this stage, failures are no longer theoretical. They begin to break systems and create instability during testing and cutover.
Part 1 Recap, where failures begin.
In Part 1, we analyzed 82 SAP SD incidents across the Discover and Explore stages. We saw how incorrect scope, poor architecture decisions, and data model simplifications create hidden risks. These risks become embedded in the design and surface only when we begin the technical build and execution.
What Part 2 covers?
This part focuses on the technical execution stages of the migration, covering 3 major sections. Section 3, Build and Remediation Incidents, Fixing Custom Code and Extensibility. Section 4, Data Migration Strategy Failures, Managing Data Cleansing and Synchronization. Section 5, Conversion Window Execution Risks, Surviving the Technical Cutover and SUM Process. Together, these represent the most critical technical failure points in the program.
Mapping to SAP Activate.
These technical sections align directly with the standard project phases. Section 3 aligns with the Realize phase for custom code and extensibility build. Section 4 spans the Explore and Realize phases, focusing on data strategy and cleansing. Section 5 aligns with the Deploy phase, covering system conversion and the technical cutover. This mapping ensures the technical team stays aligned with the overall project timeline.
Section 3. Realize, Build, and Remediation Incidents.
Section 3 focuses on the Realize phase, where legacy ECC systems are adapted to the S/4HANA architecture. This includes code remediation and alignment with clean core principles. This is a technically intensive stage where even small code assumptions can cause major functional and performance failures.
Section 3 Categories.
This section is divided into 2 major technical categories. Category 1, Custom Code Remediation. Category 2, Extensibility and Clean Core. These categories represent the shift from legacy ECC custom logic to S/4HANA compliant architecture.
Category 1, Custom Code Remediation.
Custom code remediation is a massive risk. Many organizations carry years of custom developments that directly read database tables or bypass standard APIs. In S/4HANA, these assumptions break due to data model changes and HANA performance behavior. If not remediated correctly, custom code becomes the primary source of system dumps.
Category 1 Incident List. Custom Code Remediation.
The following incidents represent the most common custom code failures during the Realize phase. 83. ATC findings incorrectly classified. Reference SAP Note 21986447. 84. SDZ reports using KONV direct reads. Reference SAP Note 2267308. 85. Hard-coded customer numbers fail after BP conversion. Reference SAP Note 22650993. 86. Select star performance regressions on HANA. Reference SAP Note 19124445. 87. BDC logic incompatible with S/4HANA APIs. Reference SAP Note 21986447. 88. User exits replaced by baddies not migrated. Reference SAP Note 22277014. 89. IDOC enhancements obsolete. Reference SAP Note 22277014. 90. Enhancement spots replaced. Reference SAP Note 22277014. 91. Batch programs reading obsolete tables. Reference SAP Note 22277014. 92. Custom pricing routines incompatible. Reference SAP Note 28862223. 93. VOFM routines incompatible. Reference SAP Note 2886223. 94. Revenue interface custom code incompatible. Reference SAP Note 2267319 and SAP Note 2225170. 95. Advanced variant configuration enhancements incompatible. Reference SAP Note 2711932. 96. Side panel apps deactivation impact on SDGUI. Reference, not applicable extensibility gap. These incidents highlight how legacy custom code assumptions break under the S/4HANA architecture.
Scenario 83. ATC findings incorrectly classified.
During the realize phase of an ECC to S/4HANA migration, organizations rely on the ABAP test cockpit to assess custom code readiness. However, development teams often incorrectly classify critical ATC findings as low priority or suppress them as false positives. Because ABAP developers frequently lack functional SD context, critical code adaptations for the new S/4HANA data model are bypassed. This leads to severe runtime dumps, massive performance regressions, and broken interfaces during integration testing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high system stability and data integrity risk. 2. Phase, realize. 3. Frequency, very common in large ECC systems with heavy custom code footprint. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SAP technical architect. 6. Business ownership, IT transformation director. 7. Relevant SAP note. SAP note 2, 198647. Custom code adaptation for S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How incorrect ATC classification appears during remediation and testing. 1. Symptom. Custom sales reports pass initial ATC syntax checks, but trigger DBIF_RSQL_invalid_RSQL dumps during execution. 2. Red flag. Hundreds of ATC findings are suppressed using pseudo comments or pragmas without any functional approval. 3. Business impact. Order-to-cash billing interfaces fail silently or timeout during integration testing. 4. Detection. Running the S/4HANA_readiness check variant reveals massive technical debt masked by developer exemptions. 5. Technical proof. Code contains direct select statements on obsolete tables like VBUK or KONV that were exempted by developers. Insight. An ATC check is only as good as the consultant interpreting the results. Automation does not replace architectural judgment.
Why this happens, scenario analysis and root cause.
1. Developers treat ATC as a syntax checklist to pass transports rather than a data model redesign guide. 2. ABAP teams lack the functional SD context to know if a custom program is still business critical or should be retired. 3. Heavy reliance on S/4HANA compatibility views creates a false sense of security during early sandbox testing. 4. Project management pressures developers to clear ATC queues quickly to meet build phase deadlines. ATC is only effective when findings are properly analyzed, not blindly classified or suppressed.
Why this is a migration, exclusive failure.
1. ECC allowed direct database reads across all SD tables without performance or syntax penalties. 2. S/4HANA physically deletes tables and replaces them with CDS views or new structures like PRCD_elements. 3. ATC specifically flags these architectural shifts, which do not exist in standard ECC enhancement pack upgrades. 4. If findings are misclassified, the legacy code survives the migration, but instantly fails against the new HANA database schema. This failure only occurs when transitioning from legacy ECC assumptions to the S/4HANA architecture.
Financial and customer impact.
1. Critical revenue interfaces fail during cutover, delaying invoice generation and cash collection. 2. Extensive rework during the testing phase drives up consulting burn rates and delays go live. 3. System performance degrades significantly if unoptimized legacy code is allowed to run against compatibility views. 4. Data corruption occurs if custom code attempts to write to obsolete tables that lack standard SAP validations. Incorrect ATC classification directly impacts project timelines and system stability.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, ABAP custom code remediation lead the person who owns ATC classification and gets fired if critical findings are bypassed. 2. Responsible, ABAP development team reviews and remediates findings based on correct priority and architectural guidelines. 3. Consulted, SD functional lead validates whether the custom object is still required in S4 HANA. 4. Informed, IT transformation director ensures governance compliance across all development teams. Proper governance ensures ATC findings are treated as technical risks, not checklist items.
Ownership, who actually fixes it.
Resolving this issue requires proper analysis and validation of ATC findings. 1. ABAP custom code remediation lead defines exact exemption rules and baseline check variants for the project. 2. ABAP development team replaces direct reads with standard S4 HANA APIs and CDS views. 3. SAP technical architect uses usage procedure logging to identify unused code to delete rather than remediate. 4. IT transformation director enforces a zero exemption policy for critical pricing and billing objects.
Who gets blamed versus who owns it.
1. Blamed, ABAP developers' code failures appear as careless development mistakes. 2. Blamed, testing teams issues surface during test cycles, making QA look slow. 3. Actual owner, ABAP custom code remediation lead responsible for allowing exemptions and poor prioritization. 4. Root cause, treating the ATC tool as a hurdle rather than an architectural gatekeeper. Misclassification shifts, blame to execution teams, instead of exposing the governance failure.
How this is actually fixed, the right way by a role.
1. ABAP custom code remediation lead establishes a mandatory exemption workflow where no critical ATC finding can be bypassed without functional sign-off. 2. ABAP development team utilizes SQL Monitor to prioritize refactoring for code that actually runs in production. 3. Developers refactor obsolete logic using standard API classes like CL_PRC_result_factory instead of bypassing the warning. 4. SAP technical architect executes rigorous technical unit testing on the HANA database before releasing transports to quality assurance.
What not to do, common wrong fixes.
1. Suppressing ATC warnings using pragmas or pseudo comments just to release a transport request. 2. Assuming compatibility views will permanently solve missing table errors without checking performance impact. 3. Remediating dead code that has not been executed in the production system for years. 4. Letting offshore development teams classify functional risks without onshore business context. Ignoring ATC findings creates hidden failures that surface during cutover.
Follow-up 1. Why are ATC findings often misclassified by developers?
Answer: many developers lack a deep understanding of how S4 HANA changes the underlying data model. When they see an error about a missing table like VBUK, they often apply a pragma to suppress the warning because the code compiles. Pressure to clear transport queues quickly drives teams to downgrade findings without proper validation.
Follow-up 2. How do experienced architects handle ATC findings?
Answer: experienced architects cross-reference ATC findings with usage procedure logging or SQL monitor data. If a custom program has not been used in production in 13 months, they delete it rather than remediate it. High-risk findings on active code are strictly governed and cannot be exempted without functional approval.
Follow-up 3. Curveball. What happens if ATC findings are ignored completely?
Answer: the custom code will migrate successfully, but it will immediately trigger short dumps during day one operations. Fixing these issues post-go-live requires emergency hotfixes, which bypass standard testing protocols and introduce massive risk to the live production system.
Exclusive pro tip.
Do not treat the ABAP test cockpit as a one-time event. Integrate ATC checks into your daily transport release process during the realize phase. By enforcing strict S4 HANA code standards before a transport can even be released, you prevent technical debt from accumulating and save weeks of rework during integration testing.
Scenario 84. SDZ reports using KONV direct reads.
In the realize phase of an ECC to S4 HANA migration, many custom Z reports developed for SD continue to use direct select statements on the KONV table. Because the physical table KONV has been deleted and replaced by the new pricing data model PRCD_elements, These reports either return incorrect values, time out due to poor compatibility view performance, or trigger short dumps if the code attempts an update or modify statement.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high reporting and data integrity impact. 2. Phase realize. 3. Frequency, extremely common in systems with heavy custom SD reporting. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SD functional lead. 6. Business ownership, global order to cash process owner. 7. Relevant SAP note, SAP note 2267308, pricing data model simplification.
Diagnostic dashboard, symptoms and evidence.
How KONV direct reads appear during testing and production. 1. Symptom, custom daily sales margin reports execute for 40 minutes and then trigger a time_OUT dump. 2. Red flag, ATC or code inspector shows priority 1 errors for direct database access on table KONV. 3. Business impact, month-end margin reports and pricing analytics become completely unreliable for the sales controllers. 4. Detection, ABAP SQL trace, ST05, reveals massive sequential read time scanning the V_KONV compatibility view. 5. Technical proof, pricing data now resides in PRCD_elements, and the document condition key, KNUMV field length has been extended, breaking legacy variable declarations. Insight, if Z reports work fine in ECC but timeout in S4 HANA. Direct KONV access through the compatibility view is the root cause.
Why this happens, scenario analysis and root cause.
1. For 15 years, ECC ABAP developers bypass standard pricing function modules because direct select on KONV were faster to code. 2. S4 HANA physically deletes KONV to optimize the database for massive parallel pricing calculations. 3. Developers mistakenly assume the SAP-provided V_KONV compatibility view will fully replicate ECC performance behavior. 4. Legacy code often uses nested select loops linking VBA-K, VBA-P, and KONV, which completely destroys HANA columnar database performance. Legacy reporting patterns frequently expose the most severe pricing simplification risks.
Why this is a migration, exclusive failure.
1. ECC allowed direct table reads on KONV without any architectural restriction or performance penalty. 2. S4 HANA introduces a completely new pricing persistence model centered on PRCD_elements. 3. Compatibility views temporarily simulate legacy structures to prevent syntax errors, but they do not guarantee runtime performance. 4. Migration exposes decades of custom code technical debt that was built on an obsolete relational data model. Pricing simplification is arguably the most impactful S4 HANA data model change for the SD module.
Financial and customer impact.
1. Incorrect historical pricing calculations make it impossible to audit past revenue accuracy. 2. Custom billing printouts that fetch discount conditions directly from KONV will print blank or incorrect values on the customer invoice. 3. Sales reporting becomes inconsistent across regional business units if some reports are updated to the new API while others are not. 4. Customer trust is damaged when invoice totals or visible discount calculations appear inconsistent. Pricing data model failures do not just break code, they directly affect revenue integrity.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, ABAP custom code remediation lead the person who owns code remediation and gets fired if critical margin reports fail after go live. 2. Responsible, ABAP development team performs the actual code refactoring and API integration. 3. Consulted, SD functional lead provides business context to ensure the correct condition types are still being fetched. 4. Informed, global order to cash process owner monitors reporting accuracy during user acceptance testing. Custom code remediation must be owned jointly by technical and functional teams to ensure financial accuracy.
Ownership, who actually fixes it.
Resolving this requires redesigning how pricing data is accessed at the database level. 1. ABAP Custom Code Remediation lead runs the code inspector to isolate every single Z program, enhancement, and form reading KONV. 2. ABAP Development Team replaces direct KONV reads with standard pricing API classes or reads directly from PRCD_elements using optimized HANA joins. 3. SD Functional Lead runs a dual system check, comparing the exact decimal output of the ECC report against the S4 HANA refactored report. 4. Global Order-to-Cash Process Owner approves the revised reporting standards before they are transported to production.
Who gets blamed versus who owns it?
1. Blamed. SD Functional Lead. The business assumes pricing configuration was corrupted during the migration. 2. Blamed. SAP users claim the new system is simply slower than ECC. 3. Actual owner, ABAP Custom Code Remediation Lead, and SD Functional Lead responsible for identifying and rewriting the technical debt. 4. Root cause, decades of custom code bypassing standard SAP pricing access logic. Z report failures typically originate from missed simplification analysis, not broken configuration.
How this is actually fixed, the right way by a role.
1. ABAP Custom Code Remediation Lead runs targeted code scans, using the S4 HANA_readiness variant to find all KONV references. 2. ABAP Development Team replaces Legacy Select with the new standard class CL_PRC_result_factory. 3. ABAP Development Team updates all variable declarations for KNUMV to account for the new S4 HANA field length extensions. 4. SD Functional Lead executes mass regression tests comparing thousands of ECC and S4 HANA document outputs to ensure exact decimal precision.
What not to do, common wrong fixes.
1. Relying permanently on the V_KONV compatibility view without testing it under production volume loads. 2. Attempting to write direct SQL update statements against PRCD_elements to bypass standard pricing logic. 3. Applying quick fixes to individual reports without establishing a project-wide coding standard for pricing access. 4. Treating the issue as a minor performance bug instead of a fundamental architectural data model change. Superficial fixes in pricing architecture create long-term financial instability.
Follow-up 1. Why do Z reports using KONV still fail even with SAP's provided compatibility views?
Answer: compatibility views only simulate the old table structure to prevent syntax errors during code compilation. They do not support write operations, and because they are views, they cannot utilize database indexes the same way a physical table does. Under high-volume reporting, they cause massive sequential scans and system timeouts.
Follow-up 2. How do senior ABAP leads prioritize which KONV reads to remediate first?
Answer: senior ABAP leads combine ATC scan results with usage procedure, logging UPL data from the production system. They prioritize the refactoring of high-impact Z reports that are executed daily for billing or margin analysis. Code that has not been run in a year is retired rather than rewritten.
Follow-up 3. Curveball. What if we suppress all KONV ATC findings just to meet the go-live deadline?
Answer: suppressing the findings allows the transports to move to production, but it guarantees that month-end financial reporting will fail. The cost of performing emergency ABAP hotfixes during the post-go-live hypercare phase is exponentially higher and riskier than addressing them properly during the realize phase.
Exclusive pro tip.
During the explore phase, run automated code scans focused specifically on KONV and pricing tables. Treat every direct read as a mandatory redesign item, because pricing simplification must be treated as a strict revenue protection control.
Scenario 85. Hard-coded customer numbers fail after BP conversion.
In the realize phase of an ECC to S4 HANA migration, custom interfaces, pricing routines, and workflow determination logic often rely on hard-coded customer numbers, KUNNR. Because S4 HANA mandates the business partner, BP approach, if the CV synchronization forced a change in the customer number range, or if the code relies on specific leading zero formatting, these hard-coded values will fail. This results in misrouted workflows, failed interface postings, and order blocks during execution.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium code remediation and master data impact. 2. Phase, realize. 3. Frequency, extremely common in legacy ECC systems with intercompany or EDI flows. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting master data management MDM lead. 6. Business ownership, global order to cash process owner. 7. Relevant SAP note. SAP note 2265093. Business partner approach.
Diagnostic dashboard, symptoms and evidence.
How hard-coded customer numbers manifest during testing. 1. Symptom, EDI inbound orders. Orders 05 fail in status 51 with the error customer not found or sales area not maintained. 2. Red flag custom code uses if KUNNR equals 00001000000 to trigger specific intercompany pricing or output logic. 3. Business impact. Specific key account customer workflows or intercompany billing automation simply stop working. 4. Detection. Global code search via transaction code _ scanner looking for constants defined as customer numbers. 5. Technical proof. The legacy customer number 100000 was converted to business partner BP 100,000 due to number range overlaps during CVI. Insight. If logic executes perfectly for 99% of customers, but fails for one specific intercompany customer, look for hard-coded values.
Why this happens, scenario analysis and root cause.
1. Developers in ECC often hard-coded internal intercompany customer numbers to bypass standard partner determination logic. 2. During the CVI customer-vendor integration process, overlapping number ranges between vendors and customers force the business to assign new numbers to existing customers. 3. S/4HANA strict data typing and leading zero logic alpha conversion sometimes behave differently when validating against the new BUT000 table. 4. The ABAP remediation team focused heavily on ATC syntax errors, but ignored hard-coded business logic. Legacy custom code often contains hidden, undocumented dependencies on specific master data IDs.
Why this is a migration, exclusive failure.
1. In ECC, customer numbers were static and never changed once created. 2. S/4HANA requires the creation of a business partner BP, which is then linked to the customer KNA1 via the CVI_cust_link table. 3. If a brownfield migration forces a customer number change to achieve BP numbering harmonization, all hard-coded historical logic instantly breaks. 4. Standard SAP ATC checks look for obsolete tables, but they cannot detect if a hard-coded string like 10045 is actually a customer number. This failure occurs because master data harmonization during CVI destroys historical code assumptions.
Financial and customer impact.
1. Intercompany billing automation fails, leaving massive intercompany stock in transit imbalances at month end. 2. Key account EDI orders fail to post, delaying shipments to the company's largest strategic customers. 3. Custom pricing discounts hard-coded to specific customer IDs fail to apply, resulting in overcharging and customer disputes. 4. Manual IT intervention is required daily to reprocess stuck IDocs. Hard-coded master data failures directly disrupt order automation and intercompany financials.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated. 1. Accountable, SD functional lead owns the overall functional behavior of pricing and partner determination. 2. Responsible, ABAP custom code remediation lead responsible for executing the code scans and refactoring hard-coded logic. 3. Consulted, master data management, MDM. Lead provides the final mapping of ECC customer numbers to S/4HANA business partners. 4. Informed, integration lead monitors EDI failures resulting from unrecognized customer numbers. Functional teams must dictate the business rule. Technical teams must implement the dynamic logic.
Ownership, who actually fixes it.
Resolving this requires systematically replacing hard-coded values with dynamic rule tables. 1. ABAP Custom Code Remediation Lead runs global string searches for known intercompany or key account customer numbers. 2. SD Functional Lead creates a custom configuration table, T via RVC, or standard condition table to store these values dynamically. 3. ABAP Development Team refactors the code to select the customer number from the new configuration table rather than relying on a hard-coded if statement. 4. MDM Lead ensures the new configuration table is populated with the correct post-CVI business partner numbers.
Who gets blamed versus who owns it?
1. Blamed, master data team, the business assumes the customer was migrated incorrectly. 2. Blamed, integration team, EDI failures make it look like the middleware is broken. 3. Actual owner, ABAP Custom Code Remediation Lead responsible for finding and removing hard-coded values. 4. Root cause, lazy legacy development practices combined with a change in the S4 HANA number range. Master data harmonization will always expose bad coding practices.
How this is actually fixed, the right way by a role.
1. ABAP Custom Code Remediation Lead uses the ABAP Code Scanner to search for literal strings matching known strategic customer numbers. 2. SD Functional Lead moves the hard-coded business rule into a BRF plus decision table or a standard T via RVC parameter. 3. ABAP Development Team replaces the hard-coding with a dynamic lookup against the T via RVC table. 4. If a legacy number must be mapped to a new BP, developers use the CVI_cust_link table, or standard BAPI, to translate the ID dynamically at runtime.
What not to do, common wrong fixes.
1. Simply replacing the old hard-coded customer number with the new hard-coded S4HANA business partner number. 2. Ignoring the alpha conversion, leading zeros, when writing custom queries against the new BUT000 table. 3. Assuming that just because the ATC check passed, the business logic inside the user exit is correct. 4. Delaying the review of EDI mapping tables until the integration testing phase. Replacing old hard-coding with new hard-coding just kicks the technical debt down the road.
Follow-up 1. Why did the customer number change in the first place?
Answer: in S4 HANA, a business partner must be created first, which then assigns the customer role. If the legacy ECC system had overlapping number ranges between vendors and customers, the CVI process requires one of them to take a new number to ensure the business partner ID remains unique across the system.
Follow-up 2. Why does not the ABAP test cockpit, ATC, catch hard-coded numbers?
Answer: ATC is designed to catch syntax errors, obsolete table reads, and performance issues. It cannot determine business context. To the ATC tool, 100000 is just a text string. It has no way of knowing that the string represents a customer number that was changed during the CVI migration.
Follow-up 3. Curveball. What if the business insists on keeping the legacy customer number?
Answer: you can retain the legacy customer number in the KNA1 table, but the overarching business partner number might still differ. If custom code is querying the BP tables, BUT000, using the legacy KNA1 number without passing through the mapping table, CVI_cust_link, the code will fail to find the record.
Exclusive pro tip.
Before the realize phase begins, ask the business for a list of their top 10 intercompany and strategic EDI customer numbers. Run a global string search for these specific numbers across all Z programs and user exits. You will almost certainly find hidden hard-coded logic that would have broken during Go Live.
Scenario 86. Select star performance regressions on HANA.
In the realize phase of an ECC to S4 HANA migration, organizations often discover that custom Z reports which ran perfectly fine in ECC suddenly time out or run incredibly slow in S4 HANA. Because HANA is a columnar database, legacy ABAP code that uses select star or performs heavy data aggregation in the application layer rather than the database layer will suffer massive performance regressions, crippling month-end SD reporting and mass billing runs.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high performance and runtime impact. 2. Phase realize. 3. Frequency, extremely common in systems with heavy custom reporting. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting basis lead. 6. Business ownership global order to cash process owner. 7. Relevant SAP note, SAP note 1912445, ABAP custom code migration for SAP HANA.
Diagnostic dashboard, symptoms and evidence.
How select star performance regressions appear during testing and production. 1. Symptom, custom Z reports for open sales orders or invoice registers that ran in 10 seconds in ECC now trigger a time_OUT dump in S4 HANA. 2. Red flag, developers copy-pasted legacy ECC code containing nested select loops and select star against massive tables like VBAK and VBAP. 3. Business impact, order fulfillment reporting is delayed, and background jobs for mass billing, VF04, spill over into business hours. 4. Detection, the ABAP SQL monitor, SQLM, and SQL performance tuning worklist, SWLT, highlights severe database fetch times. 5. Technical proof, the HANA database is forced to reconstruct entire rows of data from its columnar storage, saturating the network layer between the database and the application server. Insight, if you buy a Ferrari, HANA, but drive it in first gear select star, it will perform worse than your old car.
Why this happens, scenario analysis and root cause.
1. For decades, ABAP developers were taught to bring all data into internal tables and process the logic in the application layer data to code. 2. Because legacy ECC databases were row-based, fetching an entire row select star was mathematically just as fast as fetching 2 specific columns. 3. Project managers often limit the ABAP remediation scope to syntax errors only to save money, ignoring HANA performance tuning. 4. Developers assume that the HANA database is so fast that it will automatically compensate for poorly written ABAP code. Bad ABAP code will actually run slower on HANA than it did on Oracle or SQL Server.
Why this is a migration, exclusive failure.
1. Legacy ECC databases stored data in rows. Reading a full row of VBAK was the default, native behavior of the database. 2. HANA stores data in columns. To execute a select star, HANA must dynamically stitch together 150+ individual columns just to recreate the row. 3. If the ABAP program only actually uses 3 of those 150 columns to generate the report, the system just wasted 98% of its memory and CPU resources. 4. This failure only materializes when the physical database architecture changes during the S4 HANA migration. This is not a functional configuration issue. It is a fundamental shift in database physics.
Financial and customer impact.
1. Month-end financial close is delayed because custom revenue recognition or margin reports timeout. 2. Warehouse operations halt because custom picking reports take too long to generate. 3. The business is forced to upgrade their HANA appliance hardware, costing hundreds of thousands of dollars, simply to mask bad ABAP code. 4. Customer service reps experience frozen GUI screens while searching for historical order statuses. Performance regressions directly erode the ROI promised by the S4 HANA business case.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, ABAP custom code remediation lead owns the code performance optimization strategy and gets fired if the system crashes under load. 2. Responsible, ABAP development team executes the code pushdown and rewrites queries for HANA optimization. 3. Consulted, basis lead monitors memory consumption and network layer saturation during volume testing. 4. Informed, global order to cash process owner signs off that the refactored reports still produce the correct business data. Code performance accountability prevents day 1 operational paralysis.
Ownership, who actually fixes it.
Resolving this requires systematically identifying and rewriting expensive database queries. 1. ABAP custom code remediation lead enforces the code-to-data paradigm across all development teams. 2. ABAP development team replaces select star with explicit column selections and replaces nested loops with database join. 3. Basis lead provides developers with access to SQL monitor, SQLM, to prove which reports are consuming the most memory. 4. SD functional lead ensures that limiting the selected columns did not accidentally remove a field needed for a downstream business process.
Who gets blamed versus who owns it?
1. Blamed basis lead executives assume the HANA database was sized incorrectly or lacks memory. 2. Blamed SAP the business assumes the S/4HANA product is inherently slower than ECC. 3. Actual owner ABAP custom code remediation lead responsible for enforcing HANA-optimized coding standards. 4. Root cause, treating the migration as a lift and shift rather than a true technical modernization. You cannot solve an ABAP architecture failure by buying more HANA memory.
How this is actually fixed, the right way by a role.
1. ABAP custom code remediation lead runs the code inspector, SCI, with the performance checks for SAP HANA variant. 2. ABAP development team executes the code pushdown strategy, moving heavy calculations, aggregations, and sorting directly into core data services, CDS views. 3. Developers replace all select star statements with explicit select field 1 field 2 field 3 statements. 4. Basis lead validates the performance improvements using the SQL performance tuning worklist, SWLT, before transporting to production.
What not to do, common wrong fixes.
1. Limiting the ABAP remediation scope only to syntax errors that cause dumps, completely ignoring performance warnings. 2. Leaving nested select loops inside loop at ITAB statements. 3. Telling the business the report will run faster once HANA caches the data. Caching does not fix fundamentally broken SQL. 4. Adding secondary database indexes to tables instead of fixing the poorly written ABAP query. Hardware sizing cannot fix bad software engineering.
Follow-up 1. Why does select star specifically cause performance issues on HANA?
Answer: HANA stores data in columns, not rows. If a table has 200 columns, a select star forces the database to read from 200 different locations in memory, stitch them together into a row, and send massive amounts of unnecessary data across the network to the application server. If the program only needed 3 columns, 98% of that effort was entirely wasted.
Follow-up 2. How do senior ABAP leads know which reports to optimize first?
Answer: they do not guess. Senior leads turn on the SQL monitor, SQLM, in the production ECC system for 4 weeks prior to the migration. They capture exactly which Z reports execute the most expensive database queries under real business loads, and they mandate that the top 50 worst performing reports be rewritten using CDS views.
Follow-up 3. Curveball. Cannot we just use HANA's raw speed to overcome the bad code?
Answer: no. While HANA can search a single column incredibly fast, the network connection between the database server and the application server has a physical bandwidth limit. Sending millions of unoptimized rows of select star data across that network layer will bottleneck the entire system, slowing down every user logged into SAP.
Exclusive pro tip.
Do not wait until the realize phase to find out your code is slow. Turn on Usage Procedure Logging, UPL, and SQL Monitor in your legacy ECC production system months before the project starts. Target the specific programs that actually consume business resources, and mandate code pushdown to CDS views for those specific objects.
Scenario 87. BDC logic incompatible with S/4HANA APIs.
In the realize phase of an ECC to S/4HANA migration, legacy batch data communication, BDC, recordings for master data and sales transactions frequently fail. Because S/4HANA changes the underlying screen sequences and mandatory fields for transactions like XD01, VD01, and VA01, the session recordings, SM35, fail to find the required DIME pros, leading to aborted background jobs and failed data interfaces.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high integration and automation impact. 2. Phase realize. 3. Frequency, common in systems with legacy middleware or Z upload tools. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, SAP note 2198647, custom code adaptation for S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How BDC failures manifest during testing and production. 1. Symptom: inbound customer master interfaces fail with the error no batch input data for screen SAP MF02D0101. 2. Red flag: developers attempt to fix BDC errors by simply re-recording the transaction in S/4HANA, ignoring the business partner mandate. 3. Business impact: automated sales order creation from external e-commerce platforms stops functioning, leading to manual order entry backlogs. 4. Detection: transaction SM35 shows sessions in error status with missing field or screen sequence errors. 5. Technical proof: transaction XD01 and VD01 is technically redirected to the BP transaction, which uses a completely different screen framework, FDT_workbench. Insight: BDC is a fragile screen scraping technology that cannot survive a fundamental UI and data model redesign.
Why this happens, scenario analysis and root cause.
1. BDC recordings are hard-coded to the specific GUI screen numbers, DIME pros, and field technical names of the legacy ECC version. 2. S/4HANA consolidates customer and vendor master data into the business partner BP transaction, which uses a different windowing logic. 3. Many fields that were optional in ECC become mandatory in S/4HANA due to new architectural requirements for credit management or tax. 4. Legacy developers used BDC as a quick and dirty way to automate transactions because they did not want to find the appropriate BAPI or IDOC. BDC failures occur because the recording no longer matches the reality of the S/4HANA user interface.
Why this is a migration, exclusive failure.
1. ECC transaction screens remain stable for decades, allowing BDC recordings to function across multiple support pack upgrades. 2. S/4HANA is not just an upgrade, it is a replatforming that simplifies and redirects core transactions like master data maintenance. 3. Because BDC relies on the SAP GUI layer and S/4HANA moves toward a Fiori-first architecture, the legacy GUI paths are deprecated. 4. The failure only surfaces when the BDC attempts to execute against the newly redirected S/4HANA transaction codes. This is a technical debt failure triggered by the S/4HANA architectural shift.
Financial and customer impact.
1. Automated billing or order upload interfaces fail, leading to significant revenue recognition delays at go-live. 2. Customer master data creation is blocked, preventing new customers from placing orders or receiving shipments. 3. Operational costs skyrocket as the business is forced to hire temporary staff to manually enter thousands of failed records. 4. Integrity of sales data is compromised if manual workarounds are used to bypass the failed automated interfaces. BDC failures directly threaten the order-to-cash automation that modern enterprises rely on.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable: ABAP custom code remediation lead owns the retirement and replacement of fragile BDC logic with robust APIs. 2. Responsible: ABAP development team refactors legacy recordings into BAPI-based or OData-based integrations. 3. Consulted: SD functional lead provides the mapping for new mandatory fields like BP grouping and credit segments. 4. Informed: IT transformation director monitors the risk of integration failures during the cutover simulation. Proper governance mandates that re-recording a BDC is not a valid remediation strategy in S/4HANA.
Ownership: who actually fixes it.
Resolving this requires modernizing the integration architecture. 1. ABAP custom code remediation lead identifies every Z program that utilizes the BDC_insert or BDC_open_group function modules. 2. SD functional lead defines the required field mappings for the new business partner and sales order structures. 3. ABAP development team replaces the legacy call transaction statements with standard BAPI, like BAPI_salesorder_creatorfromdet 2. 4. Integration lead validates that the external middleware can handle the new XML or JSON response structures from the S/4HANA APIs.
Who gets blamed versus who owns it?
1. Blamed. ABAP developers. The business assumes the developers broke a program that worked for 10 years. 2. Blamed. SAP. The users claim S/4HANA is too complex because it does not support the old upload tool. 3. Actual owner. ABAP custom code remediation lead responsible for allowing fragile BDC technology to survive in the project scope. 4. Root cause. Treating the migration as a screen-for-screen upgrade instead of an API-first modernization. The failure is not the code itself, but the architectural choice to rely on BDC.
How this is actually fixed, the right way by a role.
1. ABAP custom code remediation lead mandates the decommissioning of all master data BDCs in favor of the S/4HANA migration cockpit, LTMC. 2. ABAP development team identifies the correct BAPI or OData service to replace the legacy screen recording. 3. SD functional lead ensures that all BP-specific fields, like roles and segments, are correctly passed into the new API parameters. 4. Developers implement proper error handling and logging via the application log, SLG1, instead of the old SM35 batch logs.
What not to do, common wrong fixes.
1. Wasting hundreds of hours trying to re-record the BDC in S/4HANA to account for the new screen sequences. 2. Using BDC for the BP transaction. This is technically unsupported and notoriously unstable due to the Fiori-based UI logic. 3. Ignoring BDC failures in the sandbox, assuming they will magically work in the converted quality assurance system. 4. Trying to force a screen sequence by disabling mandatory fields in configuration to accommodate an old recording. BDC is a dead-end technology in S/4HANA. Do not invest time in fixing it.
Follow-up 1. Why is BDC specifically dangerous for S/4HANA master data?
Answer. In S/4HANA, transactions like XD01 are redirected to the business partner transaction. The BP transaction uses a modern UI framework that can change dynamically based on the BP role or grouping. A BDC recording is static. If the UI adds or moves a field based on logic, the BDC will crash because it cannot see the screen.
Follow-up 2. What is the recommended alternative to BDC for mass data uploads?
Answer. For one-time migrations, the S/4HANA Migration Cockpit, LTMC, or Migrate Your Data, is the standard. For ongoing interfaces, SAP recommends using OData services via SAP API Business Hub or standard BAPI. These are architectural interfaces that do not depend on screen numbers or GUI layouts.
Follow-up 3. Curveball. What if there is no BAPI or API for specific custom transaction?
Answer. In the rare case where no API exists, you must use a clean core approach by developing an OData wrapper around the functional logic. If you must use BDC as a last resort, it must be encapsulated in a way that it can be easily replaced later. But this should be avoided for 99% of SD02C scenarios.
Exclusive pro tip.
During the Explore phase, run a global search in transaction SC16 against table TSDCP to find any Z reports calling XD01 or VA01. Treat these as immediate architecture debt and mandate their replacement with BAPI before the realize phase even begins.
Scenario 88. User exits replaced by baddies not migrated.
In the realize phase of an ECC to S/4HANA migration, legacy SD logic embedded in classical user exits frequently fails to execute or causes data inconsistency. While S/4HANA still supports many include-based exits like MV45FZZ for sales and RV60FZZ for billing, SAP increasingly deprecates these in favor of business add-ins baddies and the new enhancement framework. If legacy logic is left in old exits without being refactored into the S/4HANA compliant baddie framework, critical validations for pricing, partner determination, and ATP checks are bypassed.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process integrity, and clean core compliance. 2. Phase, realize. 3. Frequency, extremely common in highly customized SD environments. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SD functional lead. 6. Business ownership, global order to cash process owner. 7. Relevant SAP Note. SAP Note 2227-014. SD Simplifications in S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How legacy user exit failures appear during integration testing. 1. Symptom: custom order blocks or margin validations that worked in ECC are no longer triggered during VA01 in S/4HANA. 2. Red flag: ATC check flags usage of deprecated include programs like MV45AFZZ or MV50AFZ1 as priority warnings. 3. Business impact: orders are saved with incorrect tax data or unapproved discount levels because the legacy validation logic was skipped. 4. Detection: breakpoints in MV45AFZZ are not hit during specific Fiori-based order processing or OData API calls. 5. Technical proof: S/4HANA sales order APIs, API_sales_order, bypass classical GUI-based user exits entirely, requiring logic in the BADI layer. Insight: classical user exits are often tied to the SAP GUI layer. S/4HANA requires logic in the BADI layer for omnichannel consistency.
Why this happens, scenario analysis and root cause.
1. ECC SD architecture relied on global internal tables like XVBAK and XVBAP, which are highly accessible in classical include-based exits. 2. S/4HANA introduces a stricter clean core strategy where business logic must be encapsulated in BADIs to ensure cloud readiness. 3. Many new S/4HANA transactions and OData-based Fiori apps do not trigger the old PI or PBO modules where legacy exits reside. 4. Remediation teams often take the path of least resistance by leaving code in old includes, assuming they are still globally compatible. The failure is an architectural mismatch between legacy GUI-based logic and the new S/4HANA API-first logic.
Why this is a migration, exclusive failure.
1. In ECC upgrades, include-based exits remain the standard for 25 years with perfect backward compatibility. 2. S/4HANA migration introduces the SAP Fiori UI and OData APIs, which fundamentally bypass the legacy SAP GUI screen call stack. 3. The shift from traditional SD tables to compatibility views can cause legacy exits to fail if they perform direct database updates. 4. This failure only surfaces when the business moves away from SAP GUI and starts utilizing the modern S/4HANA digital core. This is a technical debt failure triggered by the move to a modern, service-oriented architecture.
Financial and customer impact.
1. Financial leakage occurs when custom margin check exits fail to prevent unauthorized discounts on high-value orders. 2. Compliance risks arise if export control exits, embedded in includes, are bypassed during the migration to international trade. 3. Customer service delays increase as users encounter unhandled short dumps during PGI, post-goods issue, because of legacy MV50AFZ1 logic. 4. Internal audit failures occur when mandatory partner determination rules, custom-coded in exits, are not enforced. User exit failures directly compromise the internal controls of the order-to-cash cycle.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership of enhancement remediation must be clearly defined. 1. Accountable: ABAP custom code remediation lead owns the transition of legacy logic into the modern BADI framework. 2. Responsible: ABAP development team refactors code from classical includes into class-based BADI implementations. 3. Consulted: SD functional lead provides the business rules and ensures that global variables in old exits are correctly mapped to BADI parameters. 4. Informed: IT Transformation Director monitors the clean core compliance score of the S/4HANA landscape. Refactoring exits into BADIs is a mandatory step for any project claiming to be S/4HANA ready.
Ownership: who actually fixes it.
Resolving this requires moving logic from the include layer to the object-oriented layer. 1. ABAP custom code remediation lead performs a where-used analysis on all classical SD includes to identify active logic. 2. SD functional lead categorizes which exits are still required for the S/4HANA target state. 3. ABAP development team implements baddies like baddie underscore SD underscore sales underscore order underscore check or baddie underscore SD underscore billing underscore item. 4. SAP Technical Architect validates that the new logic uses the code push-down approach via CDS views where possible.
Who gets blamed versus who owns it?
1. Blamed. SD functional lead. The business assumes the configuration for validations is missing. 2. Blamed. SAP users claim the new Fiori apps do not work compared to the old SAP GUI transactions. 3. Actual owner, ABAP custom code remediation lead responsible for the failure to modernize legacy code during the build phase. 4. Root cause, maintaining a lift and shift mindset for custom code instead of adopting the enhancement framework. Failing to migrate exits to baddies is a failure of technical foresight, not a system bug.
How this is actually fixed, the right way by a role.
1. ABAP custom code remediation lead identifies all logic and include MV45FZZ and maps it to the equivalent methods in baddie underscore SD underscore sales. 2. ABAP development team refactors the code to avoid using global variables, instead using the provided baddie interface parameters. 3. SD functional lead ensures that the logic is tested across all channels, SAP GUI Fiori, and external OData interfaces. 4. Developers utilize the enhancement spot technology to ensure that the new logic is properly encapsulated and does not modify standard SAP objects.
What not to do, common wrong fixes.
1. Leaving all legacy code in MV45FZZ and hoping it will be triggered by Fiori apps. It usually will not. 2. Attempting to call GUI-based function modules, like pop-up underscore to underscore confirm, inside a baddie that is called by a background process or API. 3. Ignoring the ATC warnings about include-based exits during the realize phase. 4. Hard-coding S4 HANA-specific table names, like ACDOCA, directly into old ECC user exits. Applying a band-aid to an old user exit is a guaranteed way to create a post-go-live ghost incident.
Follow-up 1. Why cannot I just keep using MV45FZZ in S4 HANA?
Answer: while it is technically possible for on-premise systems, it is architecturally dangerous. Fiori apps and S4 HANA APIs frequently bypass the GUI call stack. If your business logic is stuck in a GUI-based include, that logic will never execute for orders coming in via the web, mobile, or external EDI interfaces.
Follow-up 2. What is the main technical challenge when moving logic to a baddie?
Answer: the main challenge is the lack of global data access. In include MV45FZZ, you had access to almost any global variable in the SAP MV45 program. In a baddie, you are restricted to the parameters passed in the interface. This forces you to write cleaner, better encapsulated code, which is the core of the S4 HANA architecture.
Follow-up 3. Curveball. What if my legacy exit performs a direct database update, insert, or update?
Answer: this is a priority 1 failure. S4 HANA uses a strict LUW logical unit of work model. Direct database updates in an exit can cause data corruption or bypass the new event-based revenue recognition. All database changes must be moved to the save underscore document underscore prepare baddie or handled via standard BAPI.
Exclusive pro tip.
During the explore phase, use transaction SE84 to find all active implementations of SD user exits. Create a legacy exit inventory and mandate that any exit with more than 50 lines of code must be refactored into a baddie before the realize phase ends.
Scenario 89. IDOC enhancements obsolete.
In the realize phase of an ECC to S4 HANA migration, custom IDOC segments and enhancement logic for SD messages like order S05 and INVOIC02 frequently break. Because S4 HANA changes the underlying data model for pricing and business partners, the legacy ABAP logic in IDOC exits like exit underscore SAPLEBND underscore 001 often fails to map data correctly to the new PRCD underscore elements table or the BUT000 business partner table, resulting in status 51 errors and failed inbound sales orders.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high integration and master data impact. 2. Phase, realize. 3. Frequency, very common in systems with high EDI or e-commerce traffic. 4. Primary ownership, integration architect. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note 2265093, BP approach for IDOCs.
Diagnostic dashboard, symptoms and evidence.
How IDOC enhancement failures appear in the integration layer. 1. Symptom, inbound EDI orders fail in transaction BD87 with status 51, and the error condition record could not be found or customer number is not assigned. 2. Red flag, legacy Z segments and IDOC extensions, WE30, refer to obsolete ECC fields like KNA1KUNNR that have changed behavior in the BP model. 3. Business impact, order fulfillment from external marketplaces or global customers is completely halted, leading to massive order backlogs. 4. Detection, breakpoints in IDOC processing function modules show the custom exit logic is trying to write to compatibility views rather than transparent tables. 5. Technical proof. IDOC status records show that the inbound mapping logic cannot find the business partner ID because it is searching only the legacy KNA1 table. Insight, IDOC enhancements are the invisible glue of SD. If they are not modernized, the system becomes an isolated island.
Why this happens, scenario analysis and root cause.
1. ECC IDOC mappings often utilized custom Z segments to bypass standard partner determination and pricing logic. 2. The shift from KNA1, customer, to BUT000, business partner, requires IDOC processing exits to handle CVI, customer vendor integration, mapping in real time. 3. S4 HANA pricing, PRCD_elements, is significantly more sensitive to data types than the old KONV table, causing legacy mapping logic to fail. 4. Remediation teams often overlook the IDOC processing layer, focusing only on the core sales order transactions. Legacy IDOC exits are often hard-coded to ECC table structures that no longer exist or have been redirected.
Why this is a migration, exclusive failure.
1. ECC IDOC types like Order S05 were stable for 20 years, allowing custom enhancements to accumulate without risk. 2. S4 HANA introduces mandatory master data changes, BP, that are not natively handled by old custom segment exits. 3. The deprecation of foreign trade, EIKP or EIPO, in favor of international trade makes all custom IDOC segments related to export data obsolete. 4. Standard SAP IDOCs in S4 HANA are redesigned to be BP-aware, but custom Z extensions remain customer-aware, creating a logic conflict. This is an integration debt failure triggered by the S4 HANA data model simplification.
Financial and customer impact.
1. Revenue collection is delayed as thousands of invoices, INVOIC02, fail to reach the customer's portal due to IDOC segment errors. 2. Supply chain disruptions occur when advanced shipping notifications, DESADV, fail to transmit due to legacy packaging exit logic. 3. High operational costs are incurred as IT support teams must manually reprocess IDOCs in transaction BD87 for weeks post-go live. 4. Inaccurate customer master data in external systems. If outbound, IDOCs fail to transmit the new BP roles. IDOC failures directly break the digital threads connecting the business to its customers and vendors.
Governance and accountability, RACI model.
IDOC remediation requires a bridge between integration and functional teams. 1. Accountable, integration architect owns the end-to-end reliability of the S4 HANA integration landscape. 2. Responsible ABAP custom code remediation lead refactors the logic inside IDOC function module exits. 3. Consulted, SD functional lead provides the mapping rules for the new business partner and international trade structures. 4. Informed, IT transformation director monitors the status 51 error rates during the cutover simulation. Integration accountability prevents the post-go-live IDOC tsunami in the support queue.
Ownership, who actually fixes it.
Resolving this requires modernizing both the IDOC structure and the processing logic. 1. Integration Architect identifies all Z segments and Z message types in transaction WE30 and WE82. 2. ABAP Development Team refactors the enhancement exits, for example, exit underscore SAPLEBND underscore 001, to utilize business partner BAPI. 3. SD Functional Lead validates the inbound pricing and tax logic against the new PRCD underscore elements data model. 4. Middleware Team SAP PO or CPI updates the external mappings to accommodate any changes in the S4 HANA IDOC structure.
Who gets blamed versus who owns it.
1. Blamed Middleware Team. The business assumes the interface is broken because IDOCs aren't moving. 2. Blamed Master Data Team. Users assume the customers were migrated incorrectly into BPs. 3. Actual Owner Integration Architect responsible for ensuring the S4 HANA IDOC layer is compatible with legacy enhancements. 4. Root Cause Failure to test end-to-end EDI flows with real S4 HANA business partner data during the realize phase. Middleware is rarely the root cause. The failure is almost always in the S4 HANA IDOC processing exit.
How this is actually fixed, the right way by a role.
1. Integration Architect mandates a remapping workshop to align ECC IDOC segments with the S4 HANA business partner and pricing model. 2. ABAP Development Team replaces direct KNA1 and KONV database queries in the IDOC exits with standard S4 HANA API calls. 3. Developers implement the CVI underscore mapper class inside IDOC exits to ensure the correct BP to customer mapping is performed in real time. 4. The team executes a full unit test of the IDOC processing logic using transaction WE19 before moving to integration testing.
What not to do, common wrong fixes.
1. Attempting to force ECC customer numbers into S4 HANA IDOCs by bypassing the business partner synchronization logic. 2. Ignoring failed IDOCs in the sandbox, assuming they are just test data issues that will go away in prod. 3. Using legacy user exits for international trade data when the fields, EIKP, have been physically removed from the system. 4. Failing to update the partner profile, WE20, to reflect the new business partner number ranges. Shortcuts in IDOC remediation will always result in a manual data entry nightmare post-go-live.
Follow-up 1. Why is the business partner BP transition so disruptive for SD IDOCs?
Answer: legacy ECC IDOCs were KNA1-centric. Many custom exits use the customer number, KUNNR, to perform lookups. In S4 HANA, the IDOC must often work with the BP ID partner number and then determine the customer ID via the CVI mapping. If your custom exit is not BP aware, it will fail to find the customer master.
Follow-up 2. What is the risk of using legacy custom segments for pricing data?
Answer: in S4 HANA, pricing is transparent but complex. If a custom IDOC segment attempts to pass a condition record ID, KNUMV, that was generated in ECC but not properly converted in the S4 HANA PRCD underscore elements table, the sales order will fail to price, resulting in incorrect billing or invoice blocks.
Follow-up 3. Curveball. Should we replace IDOCs with OData APIs during the migration?
Answer: while OData is the modern standard for S4 HANA, replacing thousands of IDOC interfaces during a single migration is often too much scope creep. The best approach is to remediate the existing IDOCs to be S4 HANA compliant first, and then plan an API-first modernization roadmap for the run phase.
Exclusive pro tip.
Before starting the realize phase, run transaction WE05 to extract a list of the top 20 most frequent IDOC errors from the production ECC system. If any of those errors are related to custom segments or partner logic, prioritize those specific integration points for early S4 HANA architectural review.
Scenario 90. Enhancement spots replaced.
In the realize phase of an ECC to S4 HANA migration, legacy logic embedded in implicit and explicit enhancement spots often becomes redundant or non-functional. Because S/4HANA introduces new framework-driven architectures for output management, BRF+, pricing, PRC, and logistics execution. Many enhancement spots in standard SAP programs like SAP MV45 or SAP MV50 are bypassed or replaced by new baddies. If custom logic is left in these obsolete spots without being refactored into the new enhancement spots or baddie definitions, critical business validations and data enrichments are ignored.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high framework and architectural impact. 2. Phase, realize. 3. Frequency, common in systems with heavy object-oriented enhancements. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, SAP note 2227014, SD simplifications in S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How enhancement spot failures appear during technical unit testing. 1. Symptom, custom field updates in the sales order header, VBAK, that were handled via an implicit enhancement in SAP MV45 no longer trigger. 2. Red flag, ATC check highlights enhancements in non-modifiable or bypass sections of the S/4HANA source code. 3. Business impact, downstream processes like credit management or international trade fail because the expected custom data was never populated. 4. Detection, debugging reveals that the program flow has shifted to a new class method structure, skipping the legacy enhancement spot entirely. 5. Technical proof, transaction SBAU_ENH shows enhancements in a conflict status because the underlying standard SAP code has been restructured or deleted. Insight, enhancement spots are tied to the line-by-line structure of standard code. If SAP rewrites the method, the enhancement often dies.
Why this happens, scenario analysis and root cause.
1. S/4HANA modernization involves moving legacy procedural code into modern class-based frameworks, like the sales document object model. 2. Implicit enhancements are often anchored to specific line numbers or code blocks that no longer exist in the S/4HANA version of the program. 3. SAP has introduced specific baddies to replace common enhancement scenarios to ensure clean core compliance and cloud readiness. 4. Project teams often perform a technical upgrade only, failing to realize that an enhancement spot can be technically active but logically dead. The failure is a result of structural code changes in the S/4HANA digital core, bypassing legacy hooks.
Why this is a migration, exclusive failure.
1. In ECC, enhancement spots were highly stable across decades of support pack updates. 2. S/4HANA is a full rewrite of many core SD and LE subroutines, meaning the anchor points for enhancements have fundamentally shifted. 3. The shift to SAP Fiori and O database processing often uses a different call stack than the traditional SAP GUI transactions where the spots were placed. 4. This failure only surfaces when the system is converted, and the standard SAP source code is physically replaced by the S/4HANA version. This is a technical debt failure triggered by the massive source code refactoring in S/4HANA.
Financial and customer impact.
1. Billing blocks that should be applied via custom enhancements fail to trigger, leading to unauthorized revenue leakage. 2. Inaccurate tax calculation if the enhancement spot responsible for passing data to external tax engines, like Vertex or Avalara, is bypassed. 3. Shipment delays occur when custom logic for shipping point determination in delivery enhancements is lost. 4. Financial audit failures if the custom logic for revenue recognition triggers is no longer active. Enhancement spot failures create silent logic gaps that can result in significant financial reporting errors.
Governance and accountability, RACI model.
Managing enhancement spot migration requires strict coordination between ABAP and architects. 1. Accountable, ABAP custom code remediation lead owns the identification and refactoring of all legacy enhancement spots. 2. Responsible, ABAP development team performs the technical migration and SBAU_ENH conflict resolution. 3. Consulted, SD functional lead validates that the custom logic inside the enhancement is still required for S/4HANA. 4. Informed, IT Transformation Director monitors the enhancement conflict count during the build phase. Legacy enhancements must be validated line by line. They cannot be auto-migrated with 100% certainty.
Ownership, who actually fixes it.
Resolving this requires modernizing the enhancement approach. 1. ABAP Custom Code Remediation Lead uses transaction SBAU_ENH to identify all custom enhancements that have technical conflicts. 2. SD Functional Lead provides the business context for each enhancement to determine if it should be retired or refactored. 3. ABAP Development Team refactors legacy enhancements into modern baddies or new S/4HANA compliant enhancement spots. 4. SAP Technical Architect ensures that any new enhancement follows clean core principles by using stable SAP APIs.
Who gets blamed versus who owns it.
1. Blamed. ABAP developers. The business assumes the developers forgot to include a piece of code. 2. Blamed. Basis team users claim the upgrade broke the standard system functions. 3. Actual owner. ABAP Custom Code Remediation Lead responsible for the failure to perform a deep dive SBAU_ENH analysis. 4. Root cause. Assuming that if an enhancement is technically active in the system, it is logically executing in the transaction. Blame is often misplaced on the upgrade tools when the real failure is the lack of technical impact analysis.
How this is actually fixed, the right way by a role.
1. ABAP Custom Code Remediation Lead mandates a full review of all enhancements in the MV45A and RV60A program groups. 2. ABAP Development Team uses the Enhancement Spot tool to find new SAP-recommended anchor points in the S/4HANA source code. 3. Developers move implicit enhancement logic into official SAP baddies, like baddie_SD_sales, to ensure future-proof stability. 4. Functional leads execute negative testing to prove that the business rules are correctly blocking or allowing transactions.
What not to do, common wrong fixes.
1. Accepting the automatic conflict resolution in SBAU_ENH without manually checking the code context. 2. Reinserting implicit enhancements into a different part of the code without understanding the new S/4HANA data flow. 3. Ignoring enhancements that appear green in SBAU but have zero usage according to the SQL monitor. 4. Failing to document why a legacy enhancement was deleted or replaced during the realize phase. Shortcuts in enhancement remediation will lead to unpredictable system behavior post-go-live.
Follow-up 1. Why are implicit enhancements more dangerous than explicit ones in S/4HANA?
Answer: explicit enhancements are defined by SAP as stable hooks. Implicit enhancements are essentially code injection at the start or end of a method. Since S/4HANA involves a massive refactoring of core subroutines, those methods might be deleted or bypassed entirely, meaning your injected code is never called.
Follow-up 2. How do I find the new baddies that replace my old enhancements?
Answer: you should use transaction SE84 or refer to the S/4HANA simplification list. SAP often provides a mapping in the simplification item details that directs you to the new class-based frameworks that replace legacy subroutines in SD and LE.
Follow-up 3. Curveball. What if I have to modify standard code because there is no enhancement spot?
Answer: this should be the absolute last resort. In S/4HANA, core modifications prevent you from upgrading and can break Fiori compatibility. You must submit a request to SAP for a new enhancement spot or find a creative way to use the existing baddies or the cloud extensibility layer.
Exclusive pro tip.
During the explore phase, use transaction SC18 and SC19 to inventory all SD enhancements. Create an impact matrix that maps every enhancement to its corresponding S/4HANA Fiori app or OData service to see if the hook will still trigger under the new UI architecture.
Scenario 91. Batch programs reading obsolete tables.
In the realize phase of an ECC to S/4HANA migration, custom background jobs for mass processing and reporting frequently fail or suffer from severe performance issues. Many legacy SD batch programs rely on reading obsolete tables such as VBUK header status, VBUP item status, and VKPA sales index. In S/4HANA, these tables have been eliminated and moved into the core document tables like VBAK and VBRK. While compatibility views exist for reading, custom batch programs that attempt to update these tables or rely on them for high-speed indexing will fail or trigger database deadlocks.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high performance, and data integrity impact. 2. Phase, realize. 3. Frequency, extremely common in systems with high-volume background jobs. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note 2227014, SD simplification status tables.
Diagnostic dashboard, symptoms and evidence.
How batch program failures manifest during technical conversion and testing. 1. Symptom: a nightly batch job for mass billing release that took 2 hours in ECC now takes 8 hours or triggers a time_out dump. 2. Red flag SQL trace ST05 shows the background job is performing massive sequential scans on the VBUK compatibility view. 3. Business impact: the business cannot complete the morning shipment wave because the overnight status update jobs are still running. 4. Detection: checking transaction SM37 reveals that the job is stuck in active status for an unusually long period without processing records. 5. Technical proof: the ABAP code contains a modify VBUK or update VBUP statement, which triggers an immediate runtime error in S/4HANA. Insight: if your batch job was optimized for ECC status tables, it is fundamentally unoptimized for the S/4HANA status and header model.
Why this happens, scenario analysis and root cause.
1. In ECC, SAP maintained document status in separate tables, VBUK or VBUP, to reduce the row width of the main sales document tables. 2. S/4HANA moves status fields directly into VBAK, LIPS, and VBRK to simplify the data model and reduce database joins, HANA optimization. 3. Legacy custom batch programs often use the VAKPA, sales index, table to quickly find orders by customer, but this index is no longer maintained natively by S/4HANA. 4. The compatibility views for VBUK or VBUP are read-only and do not support the high-speed update operations that legacy batch jobs used for mass processing. The failure is a result of the architectural shift from a normalized status model to an embedded status model.
Why this is a migration, exclusive failure.
1. In ECC, VBUK and VBUP were physical tables with physical indexes. Accessing them was the standard way to check document status. 2. In S/4HANA, these tables no longer exist in the database. They are only present as DDIC views to prevent legacy code from crashing. 3. Because the views have no physical storage, they cannot have physical indexes, making large-scale select statements on these views incredibly slow. 4. This failure only occurs when the system is converted to S/4HANA and the legacy batch programs attempt to run against the new virtualized status layer. This is a technical performance failure triggered by the S/4HANA data model simplification.
Financial and customer impact.
1. Delayed billing leads to a spike in days sales outstanding, DSO, as thousands of invoices are not generated on time. 2. Warehouse operations are paralyzed if overdue delivery batch jobs fail to provide accurate status data to the picking teams. 3. Customer service reps give incorrect information to clients because the status flags in custom Z dashboards are out of sync with reality. 4. Increased IT operational costs to manually kill and restart stalled background jobs during the stabilization phase. Batch processing failures in the order-to-cash cycle directly disrupt the enterprise cash flow.
Governance and accountability, RACI model.
Remediating batch programs requires alignment between ABAP and performance teams. 1. Accountable, ABAP custom code remediation lead owns the performance of the post-migration batch window. 2. Responsible, ABAP development team refactors legacy batch jobs to read status directly from VBAK, LIPS, and VBRK. 3. Consulted, basis lead monitors background job runtime and HANA CPU spikes during the first month-end close. 4. Informed, global order to cash process owner signs off on the accuracy of the mass processing results. Performance tuning of background jobs is a mandatory task for any high-volume S/4HANA system.
Ownership, who actually fixes it.
Resolving this requires modernizing the data access logic for status and indexes. 1. ABAP Custom Code Remediation Lead identifies all background jobs that have an execution time of more than 15 minutes. 2. SD Functional Lead identifies the specific status flags, like overall delivery status, that the batch job is trying to evaluate. 3. ABAP Development Team refactors the select statements to point to the new fields in VBAK and LIPS, for example, GBSDK. 4. Basis Lead uses the SQL Monitor, SQLM, to prove that the new queries are using the physical database indexes correctly.
Who gets blamed versus who owns it.
1. Blamed basis lead. The business assumes the job scheduler is broken or the server is too slow. 2. Blamed SAP. The users claim S/4HANA is slower than ECC for mass processing tasks. 3. Actual owner, ABAP Custom Code Remediation Lead responsible for the failure to refactor the status logic during the realize phase. 4. Root cause, treating the migration as a technical conversion while ignoring the underlying data model optimization. You cannot solve a status-stable architecture failure by simply adding more background work processes.
How this is actually fixed, the right way by a role.
1. ABAP Custom Code Remediation Lead mandates a 0 VBUK policy for all custom batch developments. 2. ABAP Development Team refactors queries to join document headers with the new status fields, for example, LIPSGBSTIA for items. 3. Developers replace legacy index table via KPA lookups with optimized select statements on the primary sales tables using HANA secondary indexes. 4. Basis Lead validates that the nighttime batch window is fully simulated during the stress test phase before go live.
What not to do, common wrong fixes.
1. Relying on compatibility views for high-volume background processing. They are for one-off reporting, not mass updates. 2. Adding new custom indexes to the virtual VBUK view. This is technically impossible and logically flawed. 3. Leaving modify VBUK statements in the code. Even if they do not dump, they will not update the actual status in S/4HANA. 4. Ignoring background job performance during the first mock migration cycles. If a batch job reads VBUK, it is fundamentally an ECC program running in an S/4HANA environment.
Follow-up 1. Where did the VBUK and VBUP fields actually go in S/4HANA?
Answer: the fields were merged into the main document tables. Header status, VBUK, moved to VBUK sales, LIPS delivery, and VBRK billing. Item status, VBUP, moved into the respective item tables like VBUP and LIPS. You must now read the status directly from these tables to get native HANA performance.
Follow-up 2. What is the risk of updating VBUK via a compatibility view?
Answer: you cannot update a view. Any legacy code that performs an update VBUK or modify VBUK will fail. Even if the code compiles, the database will return an error at runtime. You must refactor the code to update the specific document header table, for example, VBUK instead.
Follow-up 3. Curveball. Why did SAP delete the sales index tables like via KPA?
Answer: in ECC, these tables were materialized views used to speed up searches by customer or material. In S/4HANA, the HANA database can search the main VBUK and VBUP tables so fast that these redundant index tables are no longer necessary. Maintaining them would actually slow the system down during document saving.
Exclusive pro tip.
Before the realize phase ends, run a global search for the string VBUK and VBUP across all background job variants and Z programs. Mandate that any program identified must be refactored to read the new status fields in VBUK and LIPS before the first integration test begins.
Scenario 92. Custom pricing routines incompatible.
In the realize phase of an ECC to S/4HANA migration, custom pricing routines, condition-based value, condition value, and requirements frequently fail to calculate correctly. Because the S/4HANA pricing engine has been redesigned to work with the PRCD_elements table. Legacy ABAP logic in routines like RV64A900 often relies on direct access to the KONV table or global memory variables that are no longer populated. This results in zero pricing values, incorrect tax calculations, and billing blocks on sales documents.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial and pricing accuracy impact. 2. Phase, realize. 3. Frequency, common in industries with complex discounting or tax logic. 4. Primary ownership, SD functional lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, sales controller. 7. Relevant SAP note 2886223 VOFM in S/4HANA pricing.
Diagnostic dashboard, symptoms and evidence.
How pricing routine failures appear during document processing. 1. Symptom, sales order condition types show a value of 0.00 even when the condition record is found. 2. Red flag, pricing routines in transaction VOFM contain hard-coded select statements against KONV or via KPA. 3. Business impact, invoices are generated with incorrect totals, leading to customer disputes and revenue leakage. 4. Detection, debugging the pricing communication structures KOMK and KOMP shows that custom fields are not being populated by the routine. 5. Technical proof, the ABAP dump ITAB_line_not_ found occurs within the pricing formula because it cannot find the document condition number, KNUMV, in legacy structures. Insight, pricing routines are the heart of O2C financials. Any logic failure here is a direct threat to the balance sheet.
Why this happens, scenario analysis and root cause.
1. Legacy routines often use dirty reads from the stack or global memory of the SAP MV45 program, which is bypassed by new S/4HANA APIs. 2. The shift to PRCD_elements means that the internal table TKONV used during document processing has been restructured. 3. Custom formulas often perform direct lookups on condition tables, A*, using logic that is incompatible with the extended field lengths in S/4HANA. 4. Remediation teams often forget to reactivate and technically validate VOFM routines after the system conversion is completed. The failure is a result of the pricing engine modernization, breaking legacy procedural code assumptions.
Why this is a migration, exclusive failure.
1. In ECC, the pricing engine remained virtually unchanged for decades, allowing custom routines to survive through many upgrades. 2. S/4HANA physically replaces the pricing persistence layer, requiring a new way of accessing and calculating condition data. 3. Standard SAP pricing routines are updated automatically, but custom Z routines, 900 to 999 range, require manual refactoring for the new data model. 4. This failure only occurs when the pricing engine attempts to call a legacy formula against the new transparent pricing tables. This is a technical logic failure triggered by the S/4HANA pricing data model simplification.
Financial and customer impact.
1. Underbilling or overbilling of customers due to failed discount or surcharge calculations. 2. Inaccurate VAT or GST postings, leading to noncompliance with regional tax authorities. 3. Delayed month-end closing as sales controllers struggle to reconcile pricing variances between ECC and S/4HANA. 4. Operational stop shipments if the system cannot calculate mandatory freight or insurance conditions. Pricing routine failures directly impact the gross-to-net revenue calculation.
Governance and accountability, RACI model.
Remediating pricing logic requires a tight loop between functional and technical leads. 1. Accountable, SD functional lead owns the accuracy of the pricing procedure and signs off on the final financial values. 2. Responsible, ABAP custom code remediation lead refactors the VOFM code to be compliant with the PRCD_elements model. 3. Consulted, sales controller provides the test cases for complex margin and rebate scenarios. 4. Informed, IT transformation director monitors the pricing variance reports during integration testing. Pricing accuracy is a functional responsibility implemented through technical code.
Ownership, who actually fixes it.
Resolving this requires rewriting the logic inside the VOFM routine includes 1. SD functional lead identifies all custom condition types and the routines assigned to them in transaction V/08. 2. ABAP custom code remediation lead identifies direct KONV reads in the RV64 A* includes 3. ABAP development team replaces legacy logic with standard S/4HANA pricing API calls, CL_PRC_result_factory. 4. SD functional lead executes a pricing comparison test, ensuring 100% value matching between ECC and S/4HANA for the same order.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead. The business assumes the pricing procedure configuration was changed. 2. Blamed. Master data team users claim the condition records were not migrated correctly. 3. Actual owner. ABAP custom code remediation lead responsible for the failure to remediate legacy formula logic. 4. Root cause. Custom formulas using direct database access instead of the communication structures KOMK and KOMP. A zero price in S/4HANA is usually a failed formula, not a missing record.
How this is actually fixed, the right way by a role.
1. ABAP custom code remediation lead mandates that all pricing formulas must only use data available in KOMK, KOMP, and the new pricing internal tables. 2. Developers remove all direct select from KONV statements from the VOFM includes, for example, RV64 AXCs. 3. The team uses SAP Note 28862223 to ensure that the VOFM routines are correctly registered in the new S/4HANA pricing framework. 4. SD functional lead reactivates the pricing procedures in transaction V/08 to ensure the new logic is triggered.
What not to do, common wrong fixes.
1. Attempting to fix a formula by hard-coding a value directly into the XKWERT field. 2. Ignoring routines that seem to work in the sandbox. They may fail in production under different currency or scale conditions. 3. Using dirty reads from the system stack to fetch data that is not passed into the pricing routine interface. 4. Failing to run the report RVVOFM01 to synchronize and activate the routines across the landscape. Manual overrides in pricing code create long-term audit and financial risk.
Follow-up 1. Why did my pricing formula stop working in S/4HANA when the code did not change?
Answer: in S/4HANA, the pricing engine is often called via APIs that do not populate the global memory of the SAP MV45 program. If your formula was relying on those global variables, the dirty read method, to determine a price, the variables will be empty in S/4HANA, resulting in a zero calculation.
Follow-up 2. What is the impact of field length extension on pricing routines?
Answer: S/4HANA extends the material number, EMA-TNR, from 18 to 40 characters. If your custom pricing formula has hard-coded offsets or legacy type definitions for EMA-TNR, the logic will fail to match condition records correctly. You must ensure the routine uses the correct S/4HANA data types.
Follow-up 3. Curveball. Can I use CDS views inside a pricing routine for better performance?
Answer: technically yes, but you must be extremely careful. Pricing routines are called thousands of times during a single document save. Performing a database call, even a CDS read, inside a loop can destroy system performance. The best practice is to pass necessary data into the routine via the KOMK or KOMP structures.
Exclusive pro tip.
Before the realize phase, run a targeted scan of all RV64 A* includes for the string select or update. Any pricing routine performing direct database access should be flagged for a mandatory architectural redesign to use the communication structures instead.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design. Most asked implementation project-related interview questions and answers. Most asked support project-related interview questions and answers. Required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 93. VOFM routines incompatible.
In the realize phase of an ECC to S/4HANA migration, legacy VOFM routines used for copy control, requirements, and data transfer frequently fail to activate or execute. Because S/4HANA introduces new data structures and extends field lengths for objects like material and business partner, the legacy ABAP code in routines like RV60C900 often contains incompatible data types or refers to fields that have been moved. This results in failed document flow, billing errors, and blocked intercompany transactions.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process flow, and data integrity impact. 2. Phase, realize. 3. Frequency, common in systems with high levels of O2C customization. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, SAP note 28862223, VOFM in S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How VOFM routine failures appear during document conversion and testing. 1. Symptom, billing documents cannot be created from deliveries, with the log showing error in data transfer, billing without a specific field error. 2. Red flag, transaction VOFM shows routines in active status but with syntax errors when checked manually in the include. 3. Business impact, intercompany billing and third-party dropship processes are halted because the custom copy control logic is failing. 4. Detection, the report RVVOFM01 reveals that many routines were not correctly generated during the system conversion process. 5. Technical proof, the ABAP code attempts to move data into fields like VBRKVBELN using legacy offsets that are no longer valid in the S/4HANA structure. Insight, VOFM routines are the glue between SD documents. If they fail, the entire document flow chain breaks.
Why this happens, scenario analysis and root cause.
1. System conversion tools, SUM, often migrate the code but fail to regenerate the VOFM execution includes the RV61A* and RV60C* groups. 2. Many custom VOFM routines use move or write statements with hard-coded character lengths that conflict with S/4HANA field length extensions. 3. Logic that relies on the NAST table for output determination requirements is now obsolete if the business has moved to the BRF plus output framework. 4. Direct database updates performed inside VOFM routines, a bad practice in ECC, now trigger database deadlocks or dirty read errors on HANA. The failure is an architectural conflict between legacy procedural routines and the new S/4HANA data structures.
Why this is a migration, exclusive failure.
1. In ECC, the VOFM framework was exceptionally stable across many versions, allowing custom logic to remain untouched for years. 2. S/4HANA migration physically changes the underlying structures, like VBAK or VBRK, that these routines are designed to manipulate. 3. The regeneration of the VOFM includes RVVOFM01, is a mandatory technical step that is often missed by basis teams during the conversion window. 4. This failure only surfaces when the system attempts to perform a document flow, like VA01 to VL01N, in the newly converted environment. This is a technical debt failure triggered by the S/4HANA master data and data model evolution.
Financial and customer impact.
1. Blocked billing prevents revenue from being recognized in the correct financial period. 2. Inaccurate data transfer between sales and billing results in incorrect tax or accounting postings. 3. High operational cost to manually correct document flow errors that should have been handled by automation. 4. Intercompany imbalances if the intercompany billing routine fails to trigger the required IDOC postings. VOFM routine failures directly disrupt the integrity of the order-to-cash financial records.
Governance and accountability, RACI model.
VOFM remediation requires strict technical and functional synchronization. 1. Accountable. ABAP custom code remediation lead owns the successful regeneration and syntax correction of all VOFM routines. 2. Responsible. ABAP development team refactors legacy code to be compatible with S/4HANA data types and field lengths. 3. Consulted. SD functional lead provides the mapping rules and validates the document flow behavior. 4. Informed. IT transformation director monitors the document flow failure rate during the stabilization phase. Accountability ensures that these hidden routines are not ignored during the build phase.
Ownership, who actually fixes it.
Resolving this requires a systematic reactivation and refactoring of the VOFM library. 1. ABAP custom code remediation lead identifies all active custom routines in transaction VOFM across all categories: pricing, billing, output. 2. ABAP development team runs the report RVVOFM01 in every environment sandbox dev QA to ensure routines are technically registered. 3. SD functional lead validates the copy control settings in transaction VTFL and VTFA to ensure the correct routines are assigned. 4. Developers refactor any code that uses legacy fields or performs direct database updates to the status tables VBUK and VBUP.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead. The business assumes the copy control configuration is missing or broken. 2. Blamed. Basis team users assume the system was not converted properly because routines are inactive. 3. Actual owner. ABAP custom code remediation lead responsible for the failure to remediate and regenerate the custom VOFM library. 4. Root cause. Assuming that VOFM routines will automatically migrate and activate without manual intervention. VOFM failures are often invisible to standard ATC checks. They require manual expert review.
How this is actually fixed, the right way by a role.
1. ABAP custom code remediation lead mandates a full inventory of all custom VOFM routines, range 900 to 999. 2. ABAP development team refactors routines to use the correct S/4HANA field lengths, for example, using long material number fields. 3. Basis team runs report RVVOFM01 immediately after every system refresh or conversion to ensure technical activation. 4. SD functional lead executes negative testing to ensure that the requirement's logic, for example, do not bill if delivery is not complete, still works.
What not to do, common wrong fixes.
1. Assuming that a green status in transaction VOFM means the logic is S/4HANA compliant. 2. Modifying standard VOFM routines 1 to 899 instead of creating new Z routines for custom logic. 3. Ignoring VOFM requirements for output and ST if the business is still partially using legacy output determination. 4. Allowing routines to perform dirty reads from the system stack instead of using the provided interface structures like FVBRP. Poorly migrated VOFM routines are a primary source of unexplained document flow failures.
Follow-up 1. Why do VOFM routines often appear active but fail at runtime?
Answer: during a migration, the VOFM pointers are often moved, but the actual execution includes the ones starting with RV61A are not regenerated. This means the system is technically trying to run the old ECC version of the code against the new S/4HANA data structure, causing a logic mismatch or a silent failure.
Follow-up 2. What is the risk of field length extension in VOFM routines?
Answer: many custom VOFM routines use offsets like EMMA-TNR plus 0, 18 to parse data. Since S/4HANA supports 40-character material numbers, these hard-coded offsets will return truncated or incorrect data, causing pricing and billing logic that depends on material attributes to fail.
Follow-up 3. Curveball. Should I move my VOFM logic into baddies during the S/4HANA migration?
Answer: while baddies are the modern standard, for copy control specifically, VOFM is still the primary framework in S/4HANA. The best approach is to remediate the existing VOFM code for data model compatibility, rather than attempting a high-risk refactoring into baddies during the migration window.
Exclusive pro tip.
Immediately after the system conversion, run the report RVVOFM01 in background mode. Then, manually open transaction VOFM and perform a syntax check on every custom routine in the 900 to 999 range. Do not wait for a testing failure to discover an inactive routine.
Scenario 94. Revenue interface custom code incompatible.
In the realize phase of an ECC to S/4HANA migration, legacy custom interfaces for revenue recognition frequently fail. S/4HANA deprecates the classical SD revenue recognition, tables VBREK and VBREV, in favor of SAP revenue accounting and reporting RER, or event-based revenue recognition, EBRR. Custom ABAP logic in interfaces and Z reports that relies on these obsolete revenue tables or specific SDF/I posting exits will result in empty revenue reports, failed financial reconciliations, and incorrect deferred revenue balances.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high revenue integrity and financial compliance impact. 2. Phase, realize. 3. Frequency, common in industries with milestone billing or service contracts. 4. Primary ownership, SD functional lead. 5. Supporting FICO lead and ABAP custom code remediation lead. 6. Business ownership, revenue manager or CFO. 7. Relevant SAP note. SAP note 2267319. SD revenue recognition deprecation.
Diagnostic dashboard, symptoms and evidence.
How revenue interface failures appear during financial unit testing. 1. Symptom: custom deferred revenue reports show zero balances despite active sales orders with billing plans. 2. Red flag: ATC checks flag direct select statements on tables VBREK, VBREV, and VBREVE as critical errors. 3. Business impact: inability to recognize revenue according to IFRS 15 or ASC 606 standards, leading to financial audit risks. 4. Detection: error logs in the RER monitor, FRR_monitor, show that custom SD fields are not being passed to the revenue contract. 5. Technical proof: custom logic in user exit SAP LV60B_001 SDF/I interface fails to find revenue-relevant data in the new S/4HANA structures. Insight: if your revenue reports relied on VBREK and ECC, they are functionally dead in S/4HANA.
Why this happens, scenario analysis and root cause.
1. S/4HANA simplifies the data model by removing dedicated SD revenue tables and moving logic to the Universal Journal, ACDOCA, or SAP RER. 2. Legacy custom interfaces were built on the deferred revenue account logic of ECC, which is fundamentally different from the contract liability or asset model of S/4HANA. 3. Custom fields in VBAK/VBAP used for revenue triggers are not correctly mapped to the new RR performance obligations, POB. 4. Remediation teams mistakenly assume that compatibility views for VBREV will allow legacy interfaces to function with the same performance and logic. The failure is a result of the architectural shift from account-based to contract-based revenue recognition.
Why this is a migration exclusive failure.
1. ECC SD revenue recognition was a stable, albeit limited framework that did not require RAR integration for standard deferred revenue. 2. S/4HANA makes the legacy SD revenue recognition functionally obsolete, requiring a total shift in how revenue data is persisted. 3. The migration requires a complex rebaseline of open revenue contracts that did not exist in standard ECC upgrades. 4. This failure only surfaces when the S/4HANA Digital Core attempts to post revenue using the new event-based logic, while legacy code still looks for old tables. This is a compliance-critical failure triggered by the S/4HANA financial simplification.
Financial and customer impact.
1. Material misstatement of financial results due to revenue being recognized in the wrong fiscal period. 2. Significant delays in the month-end close process as manual reconciliations replace failed automated interfaces. 3. Audit failures and potential regulatory penalties for non-compliance with revenue recognition standards. 4. Inaccurate commission payments to sales teams if commissions are triggered by revenue recognition rather than billing. Revenue interface failures directly threaten the legal integrity of the enterprise financial statements.
Governance and accountability, RACI model.
Revenue remediation requires a high-level synchronization between SD, FI, and RAR teams. 1. Accountable, FICO lead owns the final revenue recognition values and financial compliance sign-off. 2. Responsible, SD functional lead identifies revenue-relevant sales document types and maps them to RAR/EBRR triggers. 3. Consulted, ABAP custom code remediation lead refactors legacy revenue interfaces to read from ACDOCA or RAR tables. 4. Informed, revenue manager validates the revenue recognition results against legacy ECC history. Revenue recognition is an accounting requirement triggered by SD events.
Ownership, who actually fixes it.
Resolving this requires modernizing the revenue recognition data flow. 1. SD functional lead identifies all sales document types and item categories that used legacy SD revenue recognition. 2. FICO lead defines the revenue accounting keys and performance obligation (POB) rules in SAP RAR or EBRR. 3. ABAP development team refactors legacy interfaces to select from the new RAR contract tables FRR_D_contract or the Universal Journal ACDOCA. 4. Technical architect ensures that the revenue accounting item RAI monitor is properly configured to capture SD events.
Who gets blamed versus who owns it.
1. Blamed, SD functional lead the business assumes the sales order is not passing the right data. 2. Blamed, SAP users claim the new revenue recognition engine is broken because it does not match ECC. 3. Actual owner, FICO lead and SD functional lead responsible for the joint failure to redesign the revenue recognition strategy. 4. Root cause, treating revenue recognition as a minor SD setting instead of a major S/4HANA financial replatforming. Revenue reporting failures are usually due to missed data model mapping, not bad ABAP code.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates the move to SAP revenue accounting and reporting RAR, or event-based revenue recognition. 2. ABAP development team deletes all code referencing VBREK or VBREV and replaces it with logic that queries the RAR API. 3. FICO lead executes a reconciliation baseline to prove that the S/4HANA revenue recognition matches the audited ECC results. 4. Developers implement new baddies in the SDRAR interface to pass custom business attributes required for contract derivation.
What not to do, common wrong fixes.
1. Attempting to keep legacy SD revenue recognition active by disabling simplification checks. This is unsupported and will break the Universal Journal. 2. Relying on legacy VBREV compatibility views for high-volume revenue reporting. Performance will be unacceptable. 3. Failing to perform a dry run of the revenue contract migration for open sales orders. 4. Ignoring custom revenue recognition logic and third-party logistics, 3PL, interfaces. Shortcuts in revenue recognition remediation lead to restatements and financial audit failures.
Follow-up 1. Why did SAP remove the dedicated VBREK and VBREV tables in S/4HANA?
Answer: to eliminate data redundancy and ensure a single source of truth. In S/4HANA, revenue data is either integrated directly into the Universal Journal, ACDOCA, for real-time reporting, or managed by the SAP RAR engine. This removes the need for constant reconciliation between the SD module and the general ledger.
Follow-up 2. What is the biggest challenge when migrating open revenue contracts from ECC?
Answer: the biggest challenge is aligning the historical revenue recognized in ECC with the new performance obligation logic in S/4HANA. You must ensure that the inception-to-date revenue is correctly calculated so that the remaining revenue to be recognized in S/4HANA is mathematically accurate.
Follow-up 3. Curveball. Can I use event-based revenue recognition, EBRR, for all sales scenarios?
Answer: not necessarily. EBRR is optimized for service and project-based revenue. For complex multi-element sales arrangements with high-volume contract modifications, SAP RAR is still the recommended enterprise solution. You must choose the right architecture during the Explore phase.
Exclusive pro tip.
During the Explore phase, use transaction SC16 to check the record count of table VBREV. If it exceeds 100,000 records, you must treat the revenue recognition migration as a separate, high-priority workstream and perform a dedicated RAR proof of concept before the Realize phase ends.
Scenario 95. AVC custom enhancements incompatible.
In the Realize phase of an ECC to S/4HANA migration, legacy enhancements for variant configuration frequently fail. S/4HANA introduces the Advanced Variant Configuration (AVC) engine, which is built on HANA native logic. Legacy custom P functions, pricing functions, variant functions, and user exits in the old LOVC classic configuration framework are often incompatible with the AVC engine's high-performance syntax or its different way of handling object dependencies and constraint nets.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high configuration logic and pricing impact. 2. Phase, Realize. 3. Frequency, common in automotive machinery and high-tech industries. 4. Primary ownership, SD functional lead and VC architect. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, product management director. 7. Relevant SAP note. SAP note 2711932. Advanced variant configuration simplification.
Diagnostic dashboard, symptoms and evidence.
How AVC enhancement failures appear during configuration testing. 1. Symptom: sales order configuration screen shows errors like variant function not found or pricing does not update after characteristic selection. 2. Red flag: legacy IPC, internet pricing and configurator, Java-based user exits are still being referenced in the system. 3. Business impact: inability to configure and price complex products, leading to a complete halt in sales for customizable materials. 4. Detection: the AVC trace tool, transaction VCH_trace, shows that specific object dependencies are failing to execute on the HANA engine. 5. Technical proof: custom ABAP classes implementing the vfunc interface fail because they do not comply with the new AVC-specific BADI requirements. Insight: AVC is not an upgrade of LOVC. It is a completely new engine that requires a syntax audit.
Why this happens, scenario analysis and root cause.
1. The AVC engine uses a state-based logic optimized for HANA, whereas classic VC used a procedural sequential logic. 2. Legacy IPC user exits written in Java are no longer supported in S/4HANA and must be refactored into ABAP or the new AVC framework. 3. Custom pricing functions, P functions, that use direct table reads on legacy pricing structures like KONV cannot execute in the AVC environment. 4. Object dependencies that were hidden or relied on specific GUI-based side effects in the old VC screen no longer trigger in the new Fiori-based AVC UI. The failure is an engine mismatch where legacy procedural assumptions fail the new HANA native logic.
Why this is a migration exclusive failure.
1. In ECC, classic VC LOVC was the only native engine, and its logic remained unchanged for over 20 years. 2. S4 HANA migration introduces the option or requirement to move to the AVC engine to gain performance and Fiori compatibility. 3. The transition from Java-based IPC to ABAP-based AVC is a migration-exclusive task that involves total code refactoring. 4. This failure only occurs when the material master is switched to the new advanced configuration profile in S4 HANA. This is a configuration debt failure triggered by the S4 HANA engine modernization.
Financial and customer impact.
1. Revenue loss as customizable products cannot be quoted or ordered via the web or internal sales teams. 2. Inaccurate production orders are generated because the configuration drift leads to wrong BOM or routing selection. 3. Massive quoting errors where high-value options are selected, but the custom pricing logic fails to add the surcharge. 4. Customer frustration and order cancellations due to the configurator being unstable or slow. AVC failures directly impact the configured order supply chain and profit margins.
Governance and accountability, RACI model.
Managing AVC migration requires deep expertise in configuration logic and ABAP. 1. Accountable. SD functional lead and VC architect owns the configuration model integrity and pricing accuracy. 2. Responsible, ABAP custom code remediation lead refactors legacy Java IPC or ABAP V functions into the new AVC baddies. 3. Consulted, product management director validates that the product rules and constraints still reflect current engineering standards. 4. Informed, IT transformation director monitors the migration status of the IPC to AVC workstream. VC logic is a mix of business rules and technical code that requires dual sign-off.
Ownership, who actually fixes it.
Resolving this requires a syntax and engine audit of the VC models. 1. VC architect identifies all materials using advanced variant configuration profiles in S4 HANA. 2. ABAP development team refactors legacy variant functions into classes implementing the new AVC interface. baddie_vch_runtime_var_function. 3. SD functional lead validates that pricing P functions are replaced by the new AVC syntax or standard SD pricing enhancements. 4. Technical architect performs a performance benchmark to ensure the new AVC model is actually faster than the legacy LOVC model.
Who gets blamed versus who owns it.
1. Blamed, product management seen as providing broken rules for the product. 2. Blamed, SD lead, the business assumes the sales order configurator is simply not working. 3. Actual owner, SD functional lead and VC architect responsible for the failure to audit legacy logic for AVC engine compatibility. 4. Root cause, assuming that the AVC engine is 100% backward compatible with legacy, IPC, and LOVC procedural logic. Configuration logic is often the most complex hidden code in the entire migration.
How this is actually fixed, the right way by a role.
1. VC architect mandates a syntax check on all object dependencies using the AVC-specific compiler. 2. ABAP development team implements the new baddies for AVC runtime to handle complex calculations that exceed standard configuration syntax. 3. SD functional lead moves legacy IPC Java logic into ABAP-based AVC constraint nets. 4. The team executes automated configuration testing to compare thousands of ECC LOVC configurations against S4 HANA AVC results.
What not to do, common wrong fixes.
1. Ignoring AVC compatibility errors in the sandbox, assuming classic VC will always be available as a fallback. SAP is pushing hard for AVC. 2. Trying to hack the engine by using direct database reads inside a variant function. This will kill HANA performance. 3. Using legacy Java IPC logic in a sidecar approach instead of migrating to native S4 HANA ABAP logic. 4. Failing to update the product data management (PDM) interfaces that feed the configuration data. Incomplete AVC migration creates a supply chain disaster where configured products cannot be quoted or built.
Follow-up 1. Do I have to move to Advanced Variant Configuration, AVC in S/4HANA?
Answer: not immediately. Classic VC (LOVC) is still supported in S/4HANA. However, if you want to use the new Fiori configurator apps, or if you have complex models that suffer from performance issues, you must move to AVC. The IPC Java engine is definitely deprecated, so any IPC-based customers must migrate to AVC or ABAP-based VC.
Follow-up 2. What is the biggest advantage of the new AVC engine?
Answer: the biggest advantage is the HANA native processing and the constraint net performance. AVC can solve thousands of configuration dependencies in milliseconds, whereas classic VC often felt slow for very large BOMs. AVC is also fully integrated with the S/4HANA analytics layer.
Follow-up 3. Curveball. What happens to my old object dependencies during migration?
Answer: most object dependencies will migrate and work in classic mode within S/4HANA. However, when you switch to an advanced profile, the AVC compiler will flag syntax that it considers non-declarative or procedural. You will likely need to refactor procedures into constraints to get the full benefit of the engine.
Exclusive pro tip.
Before the realize phase ends, use transaction VCH_audit to check the compatibility of your existing VC models. Identify any materials using legacy Java IPC user exits and mandate their refactoring into ABAP-based AVC baddies immediately, because the Java engine is a hard stop for S/4HANA Fiori compatibility.
Scenario 96. Side panel apps deactivation impact on SDGUI.
In the realize phase of an ECC to S/4HANA migration, many power users discover that the context-sensitive side panel apps they relied on in the NetWeaver Business Client, NWBC, for SD transactions have been deactivated or are non-functional. Because S/4HANA prioritizes a Fiori-first architecture, these legacy side panels, which provided real-time customer credit snapshots or sales history next to the VA01 screen, are no longer supported in their legacy form, leading to a loss of operational visibility for sales reps who continue to use the SAP GUI.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium user experience and productivity impact. 2. Phase, realize. 3. Frequency, common in organizations moving from NWBC to S/4HANA SAP GUI. 4. Primary ownership, SAP Fiori and UX lead. 5. Supporting SD functional lead. 6. Business ownership, sales operations manager. 7. Relevant SAP note, not applicable extensibility gap. Refer to SAP Note 2227014 for UI simplification context.
Diagnostic dashboard, symptoms and evidence.
How side panel deactivation appears during user training and testing. 1. Symptom: users open transaction VA02 or VA03 and the right-hand information pane is either blank or missing entirely. 2. Red flag: sales reps complain that they can no longer see a customer's outstanding invoices or recent deliveries while entering a new order. 3. Business impact: order entry speed decreases as users are forced to open multiple windows, for example, FBL5N or VL060, to find information previously visible in the side panel. 4. Detection: technical review of the NWBC configuration shows that the page builder chips and side panel tags are no longer mapped to S/4HANA screen fields. 5. Technical proof: the legacy WebDynpro ABAP components used for side panels are deprecated in S/4HANA in favor of Fiori analytical cards. Insight: side panels were a bridge technology in ECC. In S/4HANA, that bridge is removed in favor of a fully integrated Fiori UX.
Why this happens, scenario analysis and root cause.
1. S/4HANA shifts the design paradigm from transaction-centric SAP GUI to insight-to-action Fiori. 2. The legacy NWBC side panel technology relied on specific screen tagging logic that was not migrated to the redesigned S/4HANA transactions. 3. SAP has stopped investing in the Business Suite side panel framework, replacing it with Fiori object pages and side effects in Fiori elements. 4. Project teams often assume that users will instantly switch to Fiori, ignoring the fact that many SD users still prefer SAP GUI for high-volume data entry. The failure is a result of the UI architectural shift, leaving legacy SAP GUI power tools behind.
Why this is a migration exclusive failure.
1. In ECC, side panels were an add-on feature that remained compatible across various NetWeaver versions. 2. S/4HANA migration involves a fundamental change in how screen data is exposed to the UI layer, breaking the legacy tagging used by side panels. 3. The deprecation of legacy SD tables, VBUK or VBUP, means that many side panel apps which perform direct queries on these tables will no longer work. 4. This failure only surfaces when users log into the converted S/4HANA system and find their productivity-enhancing side panels are dead. This is a user experience debt failure triggered by the S/4HANA Fiori-first strategy.
Financial and customer impact.
1. Increased risk of customer credit violations, as sales reps no longer have immediate visibility into a customer's overdue status during order entry. 2. Operational inefficiency results in longer call handling times and higher back-office costs for the sales department. 3. Internal user resistance to the S/4HANA migration increases when users feel they are losing functionality compared to their old ECC system. 4. Training costs increase as the business must re-educate users on how to find data using the new Fiori analytical apps. Side panel deactivation creates an information vacuum that slows down the order-to-cash execution.
Governance and accountability, RACI model.
Managing the UX transition requires a bridge between functional SD and the Fiori team. 1. Accountable, SAP Fiori and UX lead owns the strategy for replacing legacy UI tools with modern S/4HANA alternatives. 2. Responsible, SD functional lead identifies which side panel apps were business critical in the legacy ECC system. 3. Consulted, ABAP custom code remediation lead provides the data logic needed to rebuild side panel info into Fiori apps. 4. Informed, sales operations manager approves the new insight to action flow for the sales team. UX accountability prevents the productivity drop often seen in poorly managed S/4HANA go-lives.
Ownership, who actually fixes it.
Resolving this requires a redesign of the user's workspace using Fiori technology. 1. SAP Fiori or UX lead analyzes the legacy NWBC side panel usage and maps the data requirements to existing S/4HANA Fiori apps. 2. SD functional lead configures sales order Fiori object pages to include the missing analytical cards, for example, credit limit, sales history. 3. ABAP development team creates new CDS-based analytical queries to feed the data into the Fiori UI layer. 4. Fiori lead enables app-to-app navigation so users can jump from the sales order to the customer analysis app with a single click.
Who gets blamed versus who owns it.
1. Blamed. SAP the business assumes the new system is simply worse because a favorite feature was removed. 2. Blame training team users claim they were not shown how to see the data they need. 3. Actual owner, SAP Fiori and UX lead responsible for the failure to provide a modern alternative to legacy side panels. 4. Root cause, treating the migration as a purely technical back-end upgrade while ignoring the front-end user experience. Failing to replace side panels is a failure to adopt the value proposition of S/4HANA Fiori.
How this is actually fixed, the right way by a role.
1. SAP Fiori and UX lead activates the S/4HANA standard Fiori app sales order fulfillment to provide a superior replacement for legacy side panels. 2. The team implements smart business KPIs on the Fiori Launchpad to provide real-time sales visibility before a user even opens an order. 3. SD functional lead configures Fiori My Home or overview pages tailored for the specific sales rep persona. 4. If SAP GUI must be used, the team explores the use of SAP screen personas to build a modern, simplified side panel experience within the GUI itself.
What not to do, common wrong fixes.
1. wasting time trying to technically re-enable legacy side panel logic that is unsupported in S/4HANA. 2. Telling users S/4HANA does not do that. This destroys project morale and user adoption. 3. Expecting users to navigate through 5 different SAP GUI screens to find data that was previously visible in one pane. 4. Assuming that a Fiori dashboard replaces a context-sensitive side panel. They serve different operational purposes. Shortcuts in UX remediation lead to long-term operational inefficiency and low user satisfaction.
Follow-up 1. Is there any direct equivalent to side panels in S/4HANA Fiori?
Answer: the architectural equivalent is the Fiori overview page or the object page with analytical cards. These are context-sensitive. For example, when you look at a sales order in Fiori, the system automatically shows cards for credit situation and order fulfillment status on the same page.
Follow-up 2. Can I still use the NetWeaver Business Client, NWBC, with S/4HANA?
Answer: yes, but it is no longer the primary focus. SAP's strategic direction is the Fiori Launchpad, FLP. While NWBC can still host SAP GUI transactions, the context-sensitive side panel logic is largely deprecated in favor of Fiori's native analytical capabilities.
Follow-up 3. Curveball. What if my users refuse to move to Fiori?
Answer: this is a change management failure. In S/4HANA, the digital core value, real-time reporting and CDS analytics, is primarily delivered via Fiori. If users stay in the legacy SAP GUI, they are essentially using a very expensive version of ECC and losing the ROI of the migration.
Exclusive pro tip.
During the Explore phase, conduct a day-in-the-life workshop with power users. Identify the exact side panel gadgets they use and map them to standard S/4HANA Fiori analytical cards. Do not wait for UAT to find out your sales team feels blind in the new system.
Category 1 wrap-up. Custom code remediation.
We have analyzed the primary technical failures in custom code, from the pricing data model shock and business partner hardcoding to the deprecation of legacy user exits and integration exits. These incidents prove that a successful realize phase requires more than just fixing syntax errors. It requires an architectural modernization of how the SD module interacts with the HANA database.
Transition to Category 2. Extensibility and clean core.
While Category 1 focused on fixing the past, Category 2 focuses on building for the future. We move from remediating legacy code to adopting the S/4HANA Clean Core strategy. Here, we analyze how the project must shift from traditional SAP modifications to a future-proof extensibility model that survives future S/4HANA upgrades.
Category 2. Extensibility and clean core.
Category 2 focuses on the architectural shift toward the clean core. In ECC, developers often modified standard SAP objects or used hacks to achieve business logic. S/4HANA, especially in RISE and public cloud environments, introduces strict rules about which hooks can be used. If the project fails to adopt in-app extensibility and stable APIs, the system becomes an unupgradable monolith that violates the very reason for moving to S/4HANA.
Category 2 incident list. Extensibility and clean core.
The following incidents represent the architectural failures in S/4HANA extensibility. 97. Clean core removes SD hooks. Relevant SAP note, not applicable extensibility gap. Reference SAP note 2198647. 98. In-app extensibility not replacing classic enhancements. Relevant SAP note, not applicable extensibility gap. Reference SAP note 2198647. 99. CDS authorization missing. Relevant SAP note, not applicable extensibility gap. Reference SAP note 2198647. 100. Fiori versus GUI logic divergence. Relevant SAP note, not applicable extensibility gap. Reference SAP note 2198647. 101. Workflow redesign incomplete. Relevant SAP note, not applicable extensibility gap. Reference SAP note 2198647. 102. Flexible workflow condition logic incomplete. Relevant SAP note, not applicable extensibility gap. Reference SAP note 2198647. These incidents highlight the risk of applying legacy enhancement mindsets to a modern digital core architecture.
Scenario 97. Clean Core removes SD hooks.
In the realize phase of an ECC to S/4HANA migration, development teams frequently discover that legacy hooks used to modify standard SD behavior are no longer available. As organizations adopt clean core principles, particularly in RISE with SAP or private cloud environments, SAP restricts access to internal subroutines and non-released objects. If custom code relied on these undocumented hooks to hack into standard pricing or delivery logic, the code becomes impossible to migrate without a total architectural redesign.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high architectural and compliance impact. 2. Phase, realize. 3. Frequency, common in systems with heavy core modifications or undocumented enhancements. 4. Primary ownership, SAP technical architect. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable extensibility gap. Reference SAP Note 2198647 for custom code adaptation context.
Diagnostic dashboard, symptoms and evidence.
How clean core hook deactivation appears during the build phase. 1. Symptom, custom ABAP code that previously worked triggers syntax error, field unknown or object not found during the S/4HANA check. 2. Red flag, developers attempt to bypass the clean core restriction by using unreleased SAP objects or direct database updates. 3. Business impact, specialized business rules for complex product pricing or regulatory shipping blocks cannot be replicated in S/4HANA, stalling the build. 4. Detection, the ABAP test cockpit, ATC, flags usage of internal SAP objects that are not part of the cloud-ready API set. 5. Technical proof, attempting to call an internal subroutine in the SAP MV45A program results in a runtime error because the object is now private or encapsulated. Insight, in ECC, the core was wide open. In S/4HANA, the core is protected by a layer of released APIs.
Why this happens, scenario analysis and root cause.
1. S/4HANA adopts a service-oriented architecture where standard SAP code is encapsulated to ensure future upgrade stability. 2. Legacy ECC developers frequently used implicit enhancements or modifications to hook into code blocks that were never intended for customer use. 3. Organizations moving to RISE with SAP must adhere to the extensibility guide, which forbids modifying the SAP software layer. 4. The project team failed to distinguish between custom code, Z objects, and modified code, hacks into standard SAP programs during the explore phase. The failure is a result of legacy modification-heavy mindsets clashing with modern stable API architectures.
Why this is a migration, exclusive failure.
1. ECC allowed developers to modify almost any part of the standard source code with an SSCR key. 2. S/4HANA private cloud and public cloud technically enforce a restricted ABAP environment for certain objects. 3. Because S/4HANA is a different product code base, many internal subroutines have been deleted, moved, or consolidated into private classes. 4. This failure only occurs when legacy modifications are physically ported to the new S/4HANA source code and fail the architectural check. This is an architectural debt failure triggered by the S/4HANA Clean Core mandate.
Financial and customer impact.
1. Future upgrade costs skyrocket if the Clean Core is violated, as every SAP support pack will require massive retesting of modified objects. 2. The business cannot adopt new S/4HANA features or public cloud innovations because their core is too dirty to be migrated. 3. Development costs for the migration increase by 30 to 50% as teams are forced to find complex architectural workarounds for lost hooks. 4. Regulatory compliance risks if custom hard-coded blocks in standard code are lost during the conversion process. Violating clean core principles today creates an unupgradable and expensive system tomorrow.
Governance and accountability, RACI model.
Clean core enforcement is a top-down architectural mandate. 1. Accountable, SAP technical architect owns the clean core compliance score and must reject any modification-heavy designs. 2. Responsible ABAP development team refactors legacy hacks into stable, released baddies or in-app extensibility points. 3. Consulted SD functional lead provides the business requirement that was previously solved by a core hack. 4. Informed IT transformation director monitors the modification count as a key project health metric. Clean core is an architectural discipline, not a technical syntax fix.
Ownership, who actually fixes it.
Resolving this requires a total shift from modification to extensibility. 1. SAP Technical Architect reviews all legacy modifications, objects in the SAP namespace, and identifies released SAP APIs to replace them. 2. ABAP Custom Code Remediation Lead enforces the use of side-by-side extensibility via SAP Business Technology Platform, BTP, for complex logic. 3. SD Functional Lead uses the Fiori in-app extensibility tool to add custom fields to VA01/VA02 instead of modifying the screen logic. 4. Technical team refactors core logic into on-stack extensibility using stable baddies provided by the S4 HANA Enhancement Spot framework.
Who gets blamed versus who owns it.
1. Blamed. SAP the business claims the new system is too restrictive compared to the flexibility of ECC. 2. Blamed. ABAP developers seen as slow because they have to spend weeks refactoring a single modification. 3. Actual owner. SAP Technical Architect responsible for the failure to define a clean core roadmap during the explore phase. 4. Root cause. Underestimating the gap between legacy hacks and S4 HANA stable extensibility. S4 HANA is not less flexible. It simply demands more architectural discipline.
How this is actually fixed, the right way by a role.
1. SAP Technical Architect mandates a zero modification policy for the project. 2. ABAP development team utilizes the cloud readiness check in the ATC to identify all non-released SAP objects being used. 3. The team replaces legacy core hacks with official SAP baddies, for example, baddie_SD_sales_basic, which are guaranteed to survive upgrades. 4. For UI changes, the team uses key user extensibility via Fiori to add fields, ensuring the UI layer stays decoupled from the core logic.
What not to do, common wrong fixes.
1. Applying for SSCR keys to modify S4 HANA standard code. This is a technical dead end that will block future upgrades. 2. Using dirty reads on internal SAP buffers instead of using official API methods. 3. Ignoring the unreleased object warnings in the ATC, assuming they will work fine in production. 4. Allowing offshore teams to hack into standard code to meet a deadline, creating long-term maintenance costs. Violating clean core principles is the fastest way to turn an S4 HANA project into a legacy technical debt nightmare.
Follow-up 1. Why is SAP so strict about clean core in S4 HANA?
Answer. Clean core ensures that your custom logic is decoupled from SAP standard code. This allows SAP to push monthly or yearly updates, especially in RISE or cloud, without breaking your system. If you modify the core, you are locked into a specific version, losing the agility that S4 HANA is designed to provide.
Follow-up 2. What is the difference between in-app and side-by-side extensibility?
Answer. In-app extensibility happens on stack using tools like Fiori key user apps or baddies. This is for logic that must be close to the data. Side-by-side extensibility happens on SAP BTP using OData APIs. This is for complex, standalone applications that you want to keep completely separate from your S4 HANA core.
Follow-up 3. Curveball. What if my business process absolutely requires a modification that SAP has not provided an API for?
Answer. In this rare case, you must submit a customer influence request to SAP to release the object or provide a baddie. In the interim, you must document the modification as a high-risk technical debt and plan for its immediate replacement as soon as a standard API is released.
Exclusive pro tip.
Before the realize phase starts, run the S4 HANA Cloud Readiness Check in the ABAP Test Cockpit against your legacy Z code. Identify every non-released SAP object and mandate an architectural review for those objects immediately. If it is not a released API, do not migrate it.
Scenario 98. In-app extensibility not replacing classic enhancements.
In the realize phase of an ECC to S/4HANA migration, development teams often attempt to migrate legacy, append structures, and screen exit logic into the S/4HANA core. However, for Fiori-based SD operations, these classic enhancements are often invisible or non-functional. Failure to adopt S/4HANA key user extensibility tools for adding custom fields to sales documents results in a fragmented user experience where data exists in the database but cannot be viewed or maintained in the modern Fiori UI.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium user interface and data persistence impact. 2. Phase, realize. 3. Frequency, extremely common in projects with Fiori-first UI strategies. 4. Primary ownership, SAP Fiori and UX lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, sales operations manager. 7. Relevant SAP note, not applicable extensibility gap. Reference SAP Note 2198647 for custom code adaptation context.
Diagnostic dashboard, symptoms and evidence.
How extensibility gaps appear during Fiori app deployment. 1. Symptom, custom fields added via legacy append structures to table VBAK are visible in transaction VA03 but missing from the managed sales orders Fiori app. 2. Red flag, developers are still creating new Z fields in the ABAP dictionary, SE11, instead of using the custom fields SAP Fiori app. 3. Business impact, sales reps cannot perform critical filtering or reporting on custom business attributes in the Fiori Launchpad. 4. Detection, checking the extensibility tab in the Fiori app reveals that the underlying OData service has not been extended to include the legacy Z fields. 5. Technical proof, the custom fields app shows no published extensions for the sales document business object despite legacy code being active. Insight, modern S/4HANA extensibility is end-to-end. If you only fix the database, you leave the UI broken.
Why this happens, scenario analysis and root cause.
1. Legacy ABAP developers are comfortable with SE11 and CMOD or SMOD and are often resistant to learning the web-based key user extensibility tools. 2. There is a lack of understanding that Fiori apps require an OData metadata extension to recognize and display custom database fields. 3. The project team fails to perform a UI audit to decide which legacy screen exits should be retired in favor of Fiori UI adaptations. 4. Organizations assume that brownfield means everything from the legacy UI layer will automatically work in the Fiori layer. The failure is a result of applying back-end remediation mindsets to a full-stack UI architecture.
Why this is a migration, exclusive failure.
1. In ECC, the SAP GUI was the only UI, so adding a field to SE11 and a screen exit was the 100% solution. 2. S/4HANA introduces a decoupled UI layer, Fiori IO data, that requires explicit publishing of extensions to be visible. 3. The shift to the S/4HANA sales document object model means that legacy screen exits in SAP MV45 are increasingly bypassed by modern apps. 4. This failure only surfaces when the business attempts to move away from SAP GUI and finds their custom data is trapped in the backend. This is a digital transformation failure triggered by the S/4HANA Modern UI mandate.
Financial and customer impact.
1. Lower ROI on the S/4HANA migration as users abandon Fiori and return to legacy SAP GUI to access their custom data. 2. Operational errors occur when sales reps miss critical custom info, like special handling instructions, because it is not on the Fiori screen. 3. Increased development costs as teams are forced to perform double work to fix fields that were incorrectly remediated in the first place. 4. Inaccurate analytics if the CDS views used for reporting are not extended to include the custom business logic. Fragmented user experiences lead to low system adoption and high support costs.
Governance and accountability, RACI model.
Extensibility management requires a unified UX and development strategy. 1. Accountable, SAP Fiori and UX lead owns the end-to-end visibility of custom data across all UI channels. 2. Responsible, ABAP custom code remediation lead ensures that database-level extensions are correctly exposed to the OData layer. 3. Consulted, SD functional lead defines which legacy custom fields are still required for the S/4HANA business process. 4. Informed, IT Transformation Director monitors the user adoption metrics of the new Fiori-based sales processes. Clean core extensibility requires moving from modification to configuration.
Ownership, who actually fixes it.
Resolving this requires adopting the S/4HANA Key User Extensibility Framework. 1. SAP Fiori lead uses the Custom Fields app to create and publish new business logic-aware fields for sales documents. 2. ABAP development team refactors legacy, append logic into baddies that are compatible with the new extensibility persistence. 3. SD functional lead uses UI adaptation in Fiori to place the fields in the correct groups on the sales order screen. 4. Technical architect ensures that the OData service, for example, API_sales_order, is updated to include the new fields for external interface use.
Who gets blamed versus who owns it.
1. Blamed, ABAP developers seen as forgetting to add fields to the new system. 2. Blamed, SAP the business assumes S/4HANA Fiori is less flexible than the old SAP GUI. 3. Actual owner, SAP Fiori and UX lead responsible for the failure to adopt the modern S/4HANA extensibility roadmap. 4. Root cause, treating Fiori as a skin on top of ECC rather than a new architectural layer. Legacy screen exit logic is technically debt that cannot be directly ported to Fiori.
How this is actually fixed, the right way by a role.
1. SAP Fiori lead mandates the use of the custom fields and logic app for all new SD field requirements. 2. ABAP development team maps legacy SE11 fields to the new extensibility framework using the enable for usage technical settings. 3. Developers use the cloud-ready baddies, for example, sales header check, to implement the business logic for these fields. 4. The team publishes the extensions to all relevant artifacts, OData services, CDS views, and Fiori UI elements in one single action.
What not to do, common wrong fixes.
1. Manually hacking the OData service in SE80 to add a field that was already added in SE11. This breaks the extensibility metadata. 2. Trying to use JavaScript to force a field onto a Fiori screen. S/4HANA uses a metadata-driven UI that will ignore these hacks. 3. Ignoring legacy screen exits in the sandbox, assuming users will not mind their absence in the new Fiori apps. 4. Creating custom Z tables to store order data because extending standard VBAK is too hard. This destroys reporting integrity. Avoiding the standard extensibility framework creates a shadow IT layer in your S/4HANA system.
Follow-up 1. What is the main benefit of using the Custom Fields app instead of SE11?
Answer: the Custom Fields app is a low-code tool that automatically handles the full-stack extension. When you add a field here, it simultaneously updates the database table, the OData service, the CDS views, and the Fiori UI. In the old way, SE11, you had to manually touch 4 different technical layers, increasing the risk of error.
Follow-up 2. Can I still see these Fiori-added fields in the legacy SAP GUI VA03 screen?
Answer: yes. SAP provides a mechanism to enable these new custom fields for use in classic GUI screens. This ensures that even if you have a hybrid user base, some on Fiori, some on GUI, everyone sees the same clean core data.
Follow-up 3. Curveball. What if I have complex logic that the Custom Fields app cannot handle?
Answer: for complex logic, you use on-stack developer extensibility, Tier 1. You still use the stable APIs and baddies, but you write the code in the ABAP environment. This allows for deep logic while still maintaining a clean core that will not break during the next S/4HANA upgrade.
Exclusive pro tip.
Before the realize phase starts, conduct an extension mapping session. Identify every legacy Z field in VBAK and VBAP, and decide if it will be migrated via the Custom Fields Fiori app. If a field is not mapped to an S/4HANA OData service, consider it invisible to your future users.
Scenario 99. CDS authorization missing.
In the realize phase of an ECC to S/4HANA migration, custom CDS views developed for real-time SD analytics often bypass standard SAP security protocols. Because S/4HANA Analytics rely on Data Control Language, DCL, for authorization checks, if developers create CDS views without accompanying DCL files, any user with access to the Fiori app can see all sales data across all sales organizations and company codes, violating corporate data privacy and segregation of duties, SOD policies.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium security and data privacy risk. 2. Phase, realize. 3. Frequency, very common in projects with heavy custom CDS analytics. 4. Primary ownership, SAP security and GRC lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable extensibility gap. Reference SAP Note 2198647 for custom code adaptation context.
Diagnostic dashboard, symptoms and evidence.
How CDS authorization gaps manifest during UAT and security audits. 1. Symptom, a sales rep for North America can see European sales figures in a custom Fiori order volume chart. 2. Red flag, CDS view definitions contain the annotation at access control. Authorization check. #not_ required for business-sensitive data. 3. Business impact, exposure of sensitive pricing and margin data to unauthorized personnel, leading to internal data breaches. 4. Detection, security testing with personas reveals that users are seeing records that their PFCG roles should technically block. 5. Technical proof, transaction SAC access control, shows that the custom CDS view lacks a corresponding data control language, DCL entry. Insight in S/4HANA, a CDS view without a DCL, is an open door to your company's most sensitive data.
Why this happens, scenario analysis and root cause.
1. Developers focus on the analytical logic of the CDS view, but treat security as a separate task for the security team. 2. Lack of awareness that S/4HANA CDS views do not automatically inherit the PFCG authorizations of the underlying database tables. 3. Pressure to deliver fast analytics leads developers to use the #not_ required annotation as a shortcut to bypass access denied errors during development. 4. The security team is often not trained on the new data control language, DCL, framework, and relies on legacy PFCG trace methods, SD0-1. The failure is an architectural disconnect between the development layer and the security layer.
Why this is a migration, exclusive failure.
1. ECC reporting was largely based on ABAP reports where authority check statements were manually coded by the developer. 2. S/4HANA Embedded Analytics moves the security check into the database layer via CDS and DCL. 3. Migration teams often wrap legacy ECC logic in CDS views, but forget to wrap the security logic in DCL files. 4. This failure only surfaces when the organization moves away from legacy reports to the new, high-performance, CDS-based Fiori dashboards. This is a security debt failure triggered by the S/4HANA analytical modernization.
Financial and customer impact.
1. Loss of competitive advantage if sensitive customer pricing or discount data is leaked internally. 2. Potential GDPR or data privacy fines if PII, personally identifiable information, in sales orders is exposed to unauthorized users. 3. Failed external audits because the system does not enforce the need-to-know principle for financial sales data. 4. Reputational damage to the IT department for failing to secure the new digital core during the migration. CDS authorization gaps directly compromise the data governance of the enterprise.
Governance and accountability, RACI model.
Securing CDS views requires an integrated DevSecOps approach. 1. Accountable, SAP security and GRC lead owns the overall data access policy and must sign off on the DCL strategy. 2. Responsible, ABAP custom code remediation lead ensures that every CDS view created by the team has a corresponding DCL file. 3. Consulted, SD functional lead defines the organizational levels, sales org plan, distribution channel that must be secured. 4. Informed IT Transformation Director monitors the security compliance of the new S/4HANA analytics layer. Security is not a post-project activity. It is a core development requirement.
Ownership, who actually fixes it.
Resolving this requires implementing data control language, DCL, for all custom views. 1. ABAP development team creates a DCL file for every custom CDS view using the define role syntax. 2. SD functional lead provides the specific mapping of sales org VKORG to the corresponding authorization object V_VBAC_VKO. 3. SAP security lead validates that the DCL correctly references the user's PFCG roles at runtime. 4. Technical architect performs a security stress test to ensure that unauthorized data is filtered out at the database level.
Who gets blamed versus who owns it.
1. Blamed. ABAP developers. The business assumes the developers showed too much data in the report. 2. Blamed. Security team executives assume the roles are broken because users can see everything. 3. Actual owner. SAP security and GRC lead responsible for the failure to enforce the DCL framework during the build phase. 4. Root cause. Treating CDS security as optional or secondary to the data logic. In S/4HANA, the developer provides the data. The DCL provides the security.
How this is actually fixed, the right way by a role.
1. ABAP development team updates all custom CDS views to include the annotation at access control. Authorization check, hash mandatory. 2. The team implements access controls, DCL, that use the aspect PFCG_auth to dynamically check the user's sales org permissions. 3. Security lead creates a test matrix to verify that data is correctly filtered for different regional sales personas. 4. IT Transformation Director mandates that no CDS view can be transported to production without an accompanying and active DCL entry.
What not to do, common wrong fixes.
1. Using the hash check annotation without actually creating a DCL. This defaults to access denied and confuses the users. 2. Hardcoding sales org values inside the CDS view logic. This makes the view unreusable and violates security principles. 3. Relying on Fiori app-level security. If the underlying CDS view is open, a savvy user can still access the data via Excel or API. 4. Ignoring the access control tab in ADT, ABAP development tools, during the unit testing phase. Security hacks in CDS views create a false sense of compliance that will fail a professional audit.
Follow-up 1. Why cannot I just use standard PFCG authorizations for CDS views?
Answer: you do use PFCG, but the DCL is the bridge. In ABAP, the code manually checks the role. In CDS, the database does not know about PFCG roles. The DCL file tells the HANA database, before you return this data, check the user's PFCG roles and only show the rows that match their sales org.
Follow-up 2. Is it true that DCLs can slow down the performance of my CDS views?
Answer: if designed poorly, yes. However, DCLs are optimized to run at the database level. It is much faster to filter 1 million rows at the database level via DCL than it is to bring all 1 million rows into ABAP and filter them manually with authority check.
Follow-up 3. Curveball. What if my CDS view joins multiple tables with different security rules?
Answer: this is where the architectural judgment comes in. You must decide which primary table, for example, VBAK, defines the security for the entire view. You then link the DCL to that primary table's organizational fields to ensure the row-level security remains consistent across the join.
Exclusive pro tip.
Before the realize phase ends, run a global audit of all custom CDS views. Any view using the #not_required or #not_allowed annotation for business data must be flagged for an immediate security review. In S/4HANA, an unsecured CDS view is a compliance ticking time bomb.
Scenario 100. Fiori versus GUI logic divergence.
In the realize phase of an ECC to S/4HANA migration, organizations frequently encounter inconsistent business behavior between the legacy SAP GUI and the new Fiori apps. Because S/4HANA is a hybrid environment, custom logic implemented in traditional user exits, like MV45FZZ, often relies on GUI-specific stateful memory or screen field interactions that do not exist in the stateless data-driven Fiori architecture. This results in a logic split where an order is blocked in the GUI but allowed in Fiori, or vice versa, leading to data corruption and audit failures.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high architectural and functional consistency risk. 2. Phase, realize. 3. Frequency, extremely common in projects with a hybrid UI strategy. 4. Primary ownership, SAP Fiori and UX lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, global order-to-cash process owner. 7. Relevant SAP note. SAP note 2, 198647. Custom code adaptation for S4 HANA.
Diagnostic dashboard, symptoms and evidence.
How logic divergence manifests during cross-interface testing. 1. Symptom. A mandatory custom field is correctly validated in transaction VA01, but remains empty and bypassed in the Create Sales Orders Fiori app. 2. Red flag. Legacy ABAP code contains if SYT code equals VA01 or if SYBINPT equals X logic that fails to account for OData service calls. 3. Business impact. Significant data integrity issues as Fiori users inadvertently bypass critical business controls and pricing validations. 4. Detection. Comparing document headers. VBAK for orders created in GUI versus Fiori reveals missing custom attributes in Fiori-originated documents. 5. Technical proof. Debugging via transaction SR debug shows that the OData call, API_sales_order, skips GUI-based screen logic modules entirely. Insight. If your business logic lives in the UI layer instead of the API layer, S4 HANA will expose that debt immediately.
Why this happens, scenario analysis and root cause.
1. Legacy ECC code often uses SET or get parameter or global memory variables to pass data between screens, a stateful model that is incompatible with stateless OData calls. 2. Developers frequently use GUI-specific commands like popup_ to confirm or message with screen-specific types that cause OData services to crash or hang. 3. S4 HANA Fiori apps use the Sales Document Object Model, SDOM, which is a class-based framework that triggers different exit points than the old procedural PBO/PI logic. 4. Project teams often remediate code for syntax, but fail to test the functional parity between the two interface layers. The failure is an architectural mismatch between stateful legacy code and stateless modern APIs.
Why this is a migration, exclusive failure.
1. In ECC, 100% of the users were on SAP GUI, so there was no second interface to worry about for core O2C logic. 2. S4 HANA introduces a completely different UI technology stack, UI5/Fiori, that runs in parallel with the legacy SAP GUI. 3. The migration requires that custom logic be UI agnostic, which was never a requirement in the 25-year history of ECC. 4. This failure only surfaces when the organization attempts to deploy Fiori apps while maintaining SAP GUI for power users. This is a technical debt failure triggered by the S4 HANA multi-channel UI architecture.
Financial and customer impact.
1. Inconsistent pricing and discount application leads to revenue leakage if Fiori users bypass margin check logic. 2. Audit failures occur when mandatory regulatory fields are captured in one system but missed in the other. 3. Operational frustration increases as users find that the rules are different depending on which screen they use. 4. High maintenance costs arise from having to maintain and debug two different sets of code for the same business rule. Logic divergence directly undermines the single source of truth promise of S4 HANA.
Governance and accountability, RACI model.
Ensuring logic parity requires a centralized architectural sign-off. 1. Accountable. SAP Fiori and UX lead owns the parity audit to ensure Fiori apps behave exactly like the legacy GUI counterparts. 2. Responsible. ABAP custom code remediation lead refactors legacy logic into UI agnostic baddies that trigger for both GUI and OData. 3. Consulted. SD functional lead provides the baseline business rules that must be enforced regardless of the UI. 4. Informed. IT Transformation Director monitors the risk of data inconsistency across the landscape. Logic consistency is an architectural mandate that must be enforced by the UX and ABAP leads.
Ownership, who actually fixes it.
Resolving this requires moving logic from the UI layer to the business logic layer. 1. ABAP Custom Code Remediation Lead identifies all SYT code or screen-specific logic in legacy includes. 2. ABAP Development Team moves this logic into stable baddies, like baddie_SD_sales, that are triggered by both the GUI and the OData services. 3. SAP Fiori Lead ensures that the Fiori UI provides the necessary fields to the OData layer, so the backend baddie has the required data. 4. Technical Architect implements data consistency checks that run at the save event, regardless of the entry channel.
Who gets blamed versus who owns it.
1. Blamed. SAP the business assumes the Fiori apps are buggy because they do not follow the company's rules. 2. Blamed. Testing team executives assume QA missed the scenario during integration testing. 3. Actual owner. ABAP Custom Code Remediation Lead responsible for failing to refactor stateful code into stateless logic. 4. Root cause, relying on legacy GUI-based hooks for business-critical controls. The failure is not in the Fiori app. It is in the legacy code's dependency on the SAP GUI.
How this is actually fixed, the right way by a role.
1. ABAP Custom Code Remediation Lead mandates a channel-agnostic coding policy for all SD enhancements. 2. Developers use the _OData check, or simply move all logic to the sales order check baddie, which executes for all input types. 3. Teams utilize the transaction buffer to store data during the order creation process, ensuring it is available to both GUI and OData calls. 4. The team executes parity testing, creating the exact same order in GUI and Fiori, and comparing the final database state in table VBAK.
What not to do, common wrong fixes.
1. Creating a separate set of logic for Fiori and a separate set for GUI. This is a maintenance nightmare. 2. Disabling Fiori apps and forcing everyone back to SAP GUI because the logic is easier to manage. This kills the ROI of S4 HANA. 3. Assuming that a cloud-ready baddie will automatically inherit your old global variable values from MV45FZZ. 4. Using hard-coded screen numbers in your ABAP logic to determine when to trigger a business rule. Shortcuts in UI parity will always lead to data corruption in the production environment.
Follow-up 1. Why does my legacy SET or get parameter fail in S4 HANA Fiori?
Answer: SET or get parameters are tied to the user's GUI session memory, stateful. Fiori apps run on OData services which are stateless. Each call to the database is a fresh start. If your logic expects a value to be sitting in a GUI buffer from a previous screen, it will find an empty field in Fiori, causing the logic to fail.
Follow-up 2. What is the recommended way to handle messages or pop-ups in S4 HANA baddies?
Answer: you must use the baddie's return table or the message container classes. You should never use a message E or a call screen inside a baddie. Instead, you populate an error message in the return structure, and the S4 HANA framework decides how to show it, either as a Fiori toast or pop-up or a SAP GUI status bar message.
Follow-up 3. Curveball. What if I have to use an old user exit that is not available as a baddie?
Answer: in these rare cases, you must wrap your logic in a cross-interface utility class. This class should be called by the old exit and the new API. It must be designed to find its data via standard database selects or stable buffers, rather than relying on the GUI-specific global memory of the SAP MV45 program.
Exclusive pro tip.
During the realize phase, pick your 10 most complex sales order business rules. Test them immediately using an OData testing tool like Postman as well as the SAP GUI. If the OData call bypasses the rule, your logic is state-dependent and must be refactored into a UI-agnostic baddie immediately.
Scenario 101. Workflow redesign incomplete.
In the realize phase of an ECC to S4 HANA migration, organizations often fail to fully transition from legacy business workflow, SWDD, to the new S/4HANA Flexible Workflow Framework. Because S/4HANA simplifies many O2C approvals, such as credit release, return orders, and billing blocks, through a Fiori-based configuration model, legacy custom workflow templates often become non-functional or unupgradable. This results in dead approval chains where sales documents are blocked, but no agents are notified, paralyzing the order-to-cash cycle.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process automation, and cash flow impact. 2. Phase, realize. 3. Frequency, common in systems with heavy custom approval logic. 4. Primary ownership, SD functional lead. 5. Supporting workflow developer. 6. Business ownership, sales operations manager. 7. Relevant SAP note 2198-647, custom code adaptation context.
Diagnostic dashboard, symptoms and evidence.
How workflow redesign failures manifest during integration testing. 1. Symptom, sales orders are placed on a billing block or credit block, but the responsible managers do not receive any notification in their Fiori My Inbox. 2. Red flag, the project team is still trying to modify legacy SWDD templates, for example, WS200,000XX, instead of activating S/4HANA flexible workflow scenarios. 3. Business impact, high-value shipments are stuck in the system for days, delaying revenue recognition and damaging customer relationships. 4. Detection, transaction SWI1 selection report for work items, shows workflow instances in error or stuck status due to missing S/4HANA object links. 5. Technical proof. The Manage Workflows for Sales Documents Fiori app shows 0 active scenarios despite the business requiring complex approvals. Insight, S/4HANA Flexible Workflow is a configuration paradigm. Legacy, SWDD is a development paradigm. Mixing them creates chaos.
Why this happens, scenario analysis and root cause.
1. S/4HANA moves away from the technical workflow engine toward a business user-friendly configuration engine, flexible workflow. 2. Legacy custom workflow templates often contain hard-coded ECC screen paths or obsolete table reads, VBUK or VBUP, that dump in S/4HANA. 3. The project team underestimates the effort required to migrate agent determination rules from legacy Z tables to the new S/4HANA team and responsibility management framework. 4. Business users are not trained on the My Inbox Fiori app, leading them to search for old SAP Office mails that the new system no longer sends. The failure is a result of trying to force legacy technical workflow logic into a modern, low-code framework.
Why this is a migration, exclusive failure.
1. In ECC, business workflow was the only option, and its technical structure, BOR objects, remained static for decades. 2. S/4HANA introduces the flexible workflow engine as the strategic direction, meaning many legacy BOR-based events are no longer triggered by modern apps. 3. The transition requires a fundamental shift in how status management interacts with the workflow engine. 4. This failure only surfaces when the organization attempts to process a document that triggers an approval event in the converted S/4HANA environment. This is a process automation failure triggered by the S/4HANA workflow engine modernization.
Financial and customer impact.
1. Stuck orders lead to missed shipment windows and potential late delivery penalties from large retailers. 2. Revenue is frozen in the system because billing blocks cannot be released by managers who are unaware of the pending tasks. 3. Audit compliance is compromised if the legacy workflow engine is bypassed, allowing orders to proceed without the mandatory financial sign-offs. 4. Excessive hypercare support costs as IT teams manually release thousands of blocked documents during the first month post-go-live. Workflow failures directly paralyze the order-to-cash execution and cash collection.
Governance and accountability, RACI model.
Modernizing workflows requires a tight sync between functional leads and UX leads. 1. Accountable, SD functional lead owns the definition of the approval scenarios and the business rules for order release. 2. Responsible, workflow developer configures the flexible workflow scenarios and implements custom agent determination rules. 3. Consulted, SAP Fiori and UX lead ensures that the My Inbox app is correctly configured and pushed to the right manager roles. 4. Informed. Sales Operations Manager validates that the new approval chains match the corporate governance policy. Workflow is no longer a developer-only task. It is a functional configuration task in S/4HANA.
Ownership, who actually fixes it.
Resolving this requires decommissioning legacy templates and activating modern scenarios. 1. SD Functional Lead identifies every active approval type in the legacy ECC system. For example, credit, price, return. 2. Workflow Developer uses transaction SWF_flex_activate to enable the standard sales document workflow scenarios. 3. The team implements team and responsibility management, Fiori app, to define the managers responsible for each sales org. 4. ABAP Developer refactors any complex agent logic into class-based agent determination baddies that the flexible workflow engine can call.
Who gets blamed versus who owns it.
1. Blamed. Workflow Developer. The business assumes the code for the workflow is broken. 2. Blamed. Training team users claim they were never told how to approve orders in S/4HANA. 3. Actual owner. SD Functional Lead responsible for failing to lead the workflow modernization workshops during the explore phase. 4. Root cause. Treating workflow as a lift and shift technical upgrade instead of a business process redesign. Legacy SWDD workflows are technical debt that should be retired, not remediate.
How this is actually fixed, the right way by a role.
1. SD Functional Lead mandates a zero SWDD policy for standard sales order and credit approval scenarios. 2. The team activates the flexible workflow for sales documents and configures it directly via the Fiori app. 3. Workflow Developer implements push notification so managers get a real-time alert on their mobile device when an order is blocked. 4. The team executes a stress test in the sandbox, triggering 500 simultaneous approvals to ensure the task gateway does not bottleneck.
What not to do, common wrong fixes.
1. Attempting to re-record a legacy SWDD template in S/4HANA. This is a waste of time as BOR objects are being deprecated. 2. Using hard-coded user IDs for workflow agents. In S/4HANA, you must use responsibility management for future-proof stability. 3. Ignoring the workflow section of the S/4HANA readiness check, assuming your old ECC workflows will just work. 4. Failing to configure the task gateway and the My Inbox app as a prerequisite for the realize phase. Shortcuts in workflow redesign will lead to a complete operational hard stop at go live.
Follow-up 1. Can I still use my old business workflows, SWDD, in S/4HANA?
Answer: technically, yes, but only for custom scenarios where SAP has not provided a flexible workflow scenario yet. However, your old workflows will not appear in the Fiori My Inbox without significant technical rework, and they will not trigger from the modern S/4HANA Fiori apps. You are effectively building an obsolete solution.
Follow-up 2. What is team and responsibility management, and why is it important?
Answer: it is a new S/4HANA framework that separates who approves from what is being approved. Instead of hard-coding agents in the workflow, you define a team, for example, North America sales managers. The workflow engine then dynamically finds the members of that team. This allows the business to manage their own approval agents without calling IT for a code change.
Follow-up 3. Curveball. What happens to my old workflow inbox in the SAP GUI SBWP?
Answer: SBWP still exists, but it is deprecated for S/4HANA end users. If you use SBWP, you lose the ability to see decision buttons and rich document context that Fiori provides. For a successful digital transformation, you must push all users toward the My Inbox Fiori app.
Exclusive pro tip.
Before the realize phase ends, run transaction SWIA to find every in-process workflow from the legacy system. If any of those are sales order related, mandate their transition to flexible workflow immediately. Do not allow legacy templates to be ported into the new production environment.
Scenario 102. Flexible workflow condition logic incomplete.
In the realize phase of an ECC to S/4HANA migration, development teams often struggle to implement complex start conditions for the new flexible workflow engine. Unlike legacy ECC workflows that used ABAP event receivers, Flexible workflow relies on a specific set of predefined CDS attributes. If the business requires an approval for a specific custom field or a complex customer grouping that is not part of the standard SAP workflow CDS view, the workflow will fail to trigger, allowing unapproved transactions to bypass financial controls.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high business logic and security compliance risk. 2. Phase, realize. 3. Frequency, common in organizations with complex discount or credit rules. 4. Primary ownership, SD functional lead. 5. Supporting workflow developer and CDS architect. 6. Business ownership, sales operations manager. 7. Relevant SAP note, not applicable extensibility gap. Reference SAP Note 2198647 context.
Diagnostic dashboard, symptoms and evidence.
How workflow condition failures manifest during unit testing. 1. Symptom, a sales order with a 50% discount is saved, but no workflow is triggered, even though the configuration says trigger if discount greater than 20%. 2. Red flag, the Manage Workflows Fiori app shows the workflow scenario as inactive or no conditions met in the technical trace. 3. Business impact, significant financial risk as high discount orders are processed without management oversight, leading to margin erosion. 4. Detection, checking the workflow trace in transaction SWF_process_, admin reveals that the CDS attributes for the discount field are returning null values. 5. Technical proof, the custom Z field added to VBAK is not part of the standard CDS view C_sales order workflow trigger, making it invisible to the workflow engine. Insight, flexible workflow is only as smart as the CDS views that feed it. If the data is not in the view, the logic does not exist.
Why this happens, scenario analysis and root cause.
1. S4 HANA flexible workflow uses condition evaluation based on a whitelist of fields exposed via specific CDS views, analytical views. 2. Legacy ECC start conditions use direct ABAP code which could access any table. Flexible workflow is restricted to the scenario context. 3. The project team failed to extend the standard workflow trigger CDS views to include custom SD business attributes. 4. The step conditions in the Fiori app are configured using string values that do not match the internal alpha-converted values in the database, for example, missing leading zeros. The failure is a result of the architectural disconnect between back-end fields and front-end workflow attributes.
Why this is a migration, exclusive failure.
1. In ECC, you could write an ABAP check function module to evaluate any complex condition before a workflow started. 2. S4 HANA Flexible Workflow is a no-code/low-code engine. If you want a custom condition, you must explicitly publish that field via the CDS extensibility layer. 3. The transition from code-based conditions to view-based conditions is a fundamental architectural shift unique to S4 HANA. 4. This failure only surfaces when the organization attempts to replicate complex legacy approval rules in the new S4 HANA environment. This is a technical extensibility failure triggered by the move to a metadata-driven workflow engine.
Financial and customer impact.
1. Revenue leakage occurs as unapproved discounts are applied to sales orders without management visibility. 2. Internal control, SOX, violations occur if the system fails to enforce segregation of duties for high-value billing releases. 3. Loss of management trust in the S4 HANA system if the approval engine is perceived as unreliable or easy to bypass. 4. Inaccurate financial forecasting if revenue-impacting returns are processed without the mandatory quality gate approvals. Workflow condition failures directly compromise the financial governance of the enterprise.
Governance and accountability, RACI model.
Enforcing complex workflow logic requires a triple sync between SD, CDS, and workflow teams. 1. Accountable SD functional lead defines the exact business conditions, the if or then logic for order approvals. 2. Responsible CDS architect extends the standard SAP workflow CDS views to include the custom business fields. 3. Consulted workflow developer configures the scenarios in the Fiori app and validates the condition evaluation logic. 4. Informed IT Transformation Director monitors the workflow bypass reports during user acceptance testing. A workflow condition is only as strong as its underlying data architecture.
Ownership, who actually fixes it.
Resolving this requires extending the workflow vocabulary of the S/4HANA engine. 1. SD Functional Lead identifies every custom attribute required for workflow triggering, for example, order reason, customer priority. 2. CDS Architect performs a CDS extension on the standard SAP workflow trigger view to expose these custom fields. 3. Workflow Developer uses transaction SWF_business_process to ensure the new CDS attributes are recognized by the condition framework. 4. The team uses the Manage Workflows Fiori app to remap the start conditions using the newly available attributes.
Who gets blamed versus who owns it.
1. Blamed SD Lead the business says, I told you to block any order with a 50% discount. Why did this order go through? 2. Blamed SAP the business assumes the new flexible workflow is too simple and cannot handle real business rules. 3. Actual owner, SD Functional Lead and CDS Architect responsible for the failure to extend the workflow vocabulary during the realize phase. 4. Root cause, assuming that any field in table VBAK is automatically available for use in the flexible workflow engine. Flexible workflow is a vocabulary-based engine. If you do not teach it the words, it cannot hear the rules.
How this is actually fixed, the right way by a role.
1. SD Functional Lead mandates a field inventory for all workflow triggers during the explore phase. 2. CDS Architect implements S/4HANA key user extensibility to add custom fields and ensures the workflow usage flag is checked. 3. Workflow Developer implements the BADI for workflow condition evaluation, SWF_workflow_condition_eval, for logic that is too complex for simple CDS views. 4. The team performs full volume testing, ensuring that the workflow triggers correctly for both high-value and edge case documents.
What not to do, common wrong fixes.
1. Attempting to hardcode conditions into the sales order save exit to trigger a legacy workflow as a workaround. 2. Using static strings for condition values that are subject to translation or format changes, like order reason descriptions. 3. Ignoring the workflow technical trace, SWF_process_admin. When a workflow fails to start, it tells you exactly which field failed the check. 4. Assuming that a credit limit check in SD is the same as a workflow start condition. They are different technical triggers. Hacking the save event to force a workflow is a violation of clean core and will break in the next upgrade.
Follow-up 1. Why cannot the flexible workflow engine see my custom Z fields in VBAK?
Answer: Flexible workflow does not read the raw database tables like VBAK. It reads from a specific consumption CDS view. If you add a field to the table but do not extend the CDS view and the vocabulary of the workflow scenario, the engine has no way of knowing that field exists. You must explicitly publish the field for workflow usage.
Follow-up 2. What if my workflow condition requires logic from multiple tables? For example, SD and MM.
Answer: This is why the CDS architect is critical. They must create a joined CDS view that brings all the required attributes into a single flat vocabulary that the workflow engine can understand. If the join is too complex, you must use a custom agent or condition BADI to perform the calculation in ABAP.
Follow-up 3. Curveball. Can I use BRF Plus for flexible workflow conditions?
Answer: Yes. SAP provides an integration where you can use a BRF Plus decision table to determine the workflow agent or the start condition. This is highly recommended for complex, high-maintenance rules like discount approvals by sales org and product group.
Exclusive pro tip.
Before the realize phase ends, use transaction SWF_flex_activate to review the available fields for your sales document scenarios. If a business-critical field is missing from the list, mandate a CDS extension task immediately. Never allow a manual approval workaround to become a permanent fix.
Category 2 wrap-up, extensibility and clean core.
Category 2 has highlighted the fundamental shift from traditional SAP modifications to the S/4HANA clean core strategy. We analyze the risks of logic divergence between Fiori and GUI, the critical nature of CDS authorizations, and the transition to flexible workflow. Successfully navigating this category means your system is built on stable, upgradable foundations that are ready for the modern digital core.
Section 3 Wrap-Up. Realize technical risks.
With the completion of Section 3, we have moved through the technical heart of the realize phase. We have remediated 15 years of legacy technical debt, optimized code for the HANA database, and enforced architectural discipline through the Clean Core mandate. While the system is now technically ready, the success of the migration now shifts to the fuel that runs the engine, the data.
Transition to Section 4 Data Migration Risks.
Even the most perfect ABAP code will fail if the data it processes is inconsistent or poorly synchronized. In Section 4, we address the data migration stage. This is often the most time-consuming part of an S/4HANA program, as it requires a massive effort in data cleansing, governance, and the mandatory transformation of customer and vendor records into the new business partner model.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Section 4 Data Migration Strategy and Governance.
Section 4 focuses on the strategic and operational risks of moving data from ECC to S/4HANA. In a brownfield conversion, data migration is not a simple copy and paste activity. It involves defining archiving scopes, managing massive volumes, and ensuring that legacy data complies with the strict validation rules of the S/4HANA data model. Failure here leads to failed conversion mocks and critical delays in the cutover window.
Section 4 Incident List.
This set of data migration incidents focuses on strategy, volume, master data cleansing, credit, localization, revenue, and data aging object migration. 103. Open versus historical data scope incorrect. Relevant SAP note not applicable data governance and cleansing. 104. Archiving scope misdefined. Relevant SAP note not applicable data governance and cleansing. 105. Data volume underestimated. Relevant SAP note not applicable data governance and strategy. 106. Selective migration inconsistency. Relevant SAP note not applicable data governance and strategy. 107. Migration object sequencing errors. Relevant SAP note not applicable data governance and strategy. 108. Mock loads inconsistent. Relevant SAP note not applicable data governance and strategy. 109. CVI preparation incomplete. Relevant SAP note 27133963 CVI master data sync. 110. Pricing condition cleansing insufficient. Relevant SAP note 22673008 pricing prechecks. 111. Customer master cleansing insufficient. Relevant SAP note not applicable data governance and cleansing. 112. Duplicate hierarchies unresolved. Relevant SAP note not applicable data governance and cleansing. 113. Tax classification incomplete. Relevant SAP note not applicable data governance and cleansing. 114. Credit exposure inconsistencies. Relevant SAP note not applicable data governance and cleansing. 115. Rebate agreements not prepared for CCM. Relevant SAP note not applicable data governance and cleansing. 116. Foreign trade commodity code migration failures. Relevant SAP note 2267310 foreign trade. 117. GST India CIN data migration failures. Relevant SAP note 2405502 and SAP note 2285611 GST India and master data. 118. Foreign trade fields obsolete but not cleansed. Relevant SAP note 2267310 foreign trade. 119. Open revenue contract migration errors. Relevant SAP note 2267319 and SAP note 2225170 revenue recognition. 120. Revenue reconciliation baseline not established. Relevant SAP note 2267319 and SAP note 2225170 revenue recognition. 121. Data aging object migration misalignment. Relevant SAP note 1616302 ILM policy. 122. Transportation master migration inconsistencies. Relevant SAP note 2267317 L ETRA to TM. 123. ILM policy alignment for SD data. Relevant SAP note 1616302 ILM policy. These incidents highlight the massive governance effort required to make data S/4HANA ready.
Scenario 103. Open versus historical data scope incorrect.
During the explore and realize phases of an ECC to S/4HANA migration, a critical misalignment often occurs between the business expectations and the technical data migration strategy. While technical teams typically aim to migrate only open transactions, such as open sales orders, deliveries, and unpaid invoices to minimize conversion downtime, the business users often expect full historical visibility for year-over-year analytics and customer sales history. If the scope is not strictly defined and reconciled early, the project faces massive rework during UAT or a complete failure of reporting tools on day one.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium strategic and reporting impact. 2. Phase, explore and realize. 3. Frequency, common in global organizations with heavy analytical requirements. 4. Primary ownership, data migration lead. 5. Supporting SD functional lead and business analytics lead. 6. Business ownership, sales operations director. 7. Relevant SAP note, not applicable data governance and cleansing. This is a project scoping and data strategy failure.
Diagnostic dashboard, symptoms and evidence.
How data scope misalignment manifests during testing. 1. Symptom, Fiori analytical apps like Sales Management Overview show no data for the previous fiscal year. 2. Red flag, the data migration object list in the migration cockpit only includes open document types, ignoring closed history. 3. Business impact, sales managers cannot compare current performance against historical benchmarks, leading to a loss of management trust. 4. Detection, reconciliation reports between ECC and S/4HANA show massive variances in total record counts for tables VBAK and VBRK. 5. Technical proof, the conversion logic in the SUM tool or migration cockpit uses filters that exclude documents with completed status. VBUPGBSTIA equals C. Insight, technical open data migration is fast, but historical data migration is what the business actually needs for continuity.
Why this happens, scenario analysis and root cause.
1. Project managers prioritize the technical cutover window, downtime, and push for minimal data footprint to ensure SUM finishes on time. 2. Failure to perform a data usage analysis to determine which historical records are legally required for tax audits versus operational reporting. 3. A lack of understanding of how S4 HANA embedded analytics works. These apps often require 2 or more years of history to provide predictive value. 4. The project team assumes that users will log into the old ECC system to view history, which is rarely acceptable for daily operations. The failure is a result of a strategy that prioritizes IT convenience over business operational requirements.
Why this is a migration exclusive failure.
1. In a standard ECC enhancement pack upgrade, all data is retained by default because the database is not being fundamentally replatformed. 2. S4 HANA Brownfield conversion triggers a data model transformation where every row must be evaluated for compatibility with the new ACDOCA and PRCD_elements models. 3. Because this transformation consumes significant CPU and time, project teams are forced to make a scope decision that they never had to make in ECC. 4. This failure only surfaces when the technical migration strategy is disconnected from the business reporting strategy. Migration forces a data pruning decision that standard upgrades never required.
Financial and customer impact.
1. Audit risks increase if historical billing data required for revenue recognition audits is missing from the live system. 2. Sales forecasting accuracy drops because the S4 HANA system lacks the baseline data needed for trend analysis. 3. Increased infrastructure costs if the business later decides to inject historical data post-go-live, requiring a secondary migration project. 4. Customer disputes cannot be resolved quickly if historical discount and pricing data is archived and inaccessible. Data scope gaps directly impact the company's ability to defend its historical financial performance.
Governance and accountability, RACI model.
Defining data scope requires a formal sign-off between business and IT. 1. Accountable data migration lead owns the data object list and ensures the technical load matches the approved scope document. 2. Responsible SD functional lead identifies the specific document types and status codes that define open versus relevant history. 3. Consulted business analytics lead defines the historical data requirements for Fiori embedded analytics. 4. Informed IT transformation director monitors the impact of data volume on the total cutover downtime. Accountability ensures that data scope is a deliberate decision, not a technical accident.
Ownership, who actually fixes it.
Resolving this requires a data tiering strategy and formal scope rebaselining. 1. Data migration lead extracts record counts from ECC for the last 5 years to provide the business with a volume reality check. 2. SD functional lead maps each sales document status to a migration category, live migration, archive but searchable, or discard. 3. Sales operations director signs off on the specific cutoff date, for example, migrate all data from Jan 1st, 2022 onwards. 4. Technical architect configures the migration cockpit filters to include the agreed-upon historical document ranges.
Who gets blamed versus who owns it.
1. Blamed data migration team. The business says, you forgot to load our 2023 sales data. 2. Blamed SAP users claim S4 HANA reporting is empty compared to ECC. 3. Actual owner, data migration lead and SD functional lead responsible for the lack of a documented and approved data scope document. 4. Root cause, assuming that technical migration limits are acceptable to business stakeholders without formal validation. Blame follows the missing data. Ownership follows the scope document.
How this is actually fixed, the right way by a role.
1. Data migration lead establishes a data selection policy during the explore phase, defining exactly how many years of history will move. 2. The team performs a Mach 1 migration with full volume to test the downtime impact of the historical data. 3. If history cannot be moved into S4 HANA due to volume, the team implements HANA native storage extension or an external data warehouse to keep history accessible. 4. Functional leads execute a data completeness check during the first week of UAT, comparing ECC and S4 record counts by fiscal year.
What not to do, common wrong fixes.
1. Migrating everything without cleansing. This will likely crash the SUM tool during the PRCD_elements conversion. 2. promising the business we will load the history after go live. Loading history into a live production system is technically complex and high risk. 3. Ignoring archived data that is still relevant for advanced returns, for example, returning an item sold 3 years ago. 4. Setting migration filters based on document date only, while ignoring financial year alignment. Shortcuts in data scope lead to a system that is technically live but operationally useless.
Follow-up 1. What is the typical data migration scope for a brownfield conversion?
Answer: most standard brownfield conversions migrate all master data and open transactional data. For SD, open typically means any document that is not yet fully invoiced or cleared. For history, most companies choose to migrate 1 to 2 years of closed data to support Fiori analytics, while older data is archived.
Follow-up 2. How does historical data affect the S/4HANA conversion downtime?
Answer: significantly. The most time-consuming part of the conversion is the transformation of pricing data, KONV, to PRCD_elements. If you have 50 million rows of historical pricing, the conversion could take days. This is why a strict data scope and archiving strategy are required to meet the go-live weekend window.
Follow-up 3. Curveball. Can we use SAP Signavio to help define the data scope?
Answer: yes. SAP Signavio Process Insights can show you exactly how much rot or dark data you have in your ECC system. For example, orders that were never finished from 10 years ago. This data-driven evidence helps convince the business to archive old data rather than migrating it to S/4HANA.
Exclusive pro tip.
During the Explore phase, generate a heat map of data usage from the last 24 months. If data has not been touched in 2 years, it belongs in an archive, not in S/4HANA. Use this map to get a formal scope sign-off from the CFO before you start your first mock migration.
Scenario 104. Archiving scope misdefined.
In the Explore phase of an ECC to S/4HANA migration, organizations often rush through the data pruning process to reduce the system size for HANA. However, misdefining the archiving scope results in critical active documents being moved to an archive before the migration. When the conversion begins, these archived documents are ignored by the S/4HANA transformation tools, leading to broken document flows. For example, a delivery in S/4HANA where the sales order was accidentally archived in ECC, and failed advanced returns processes.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process integrity and data loss risk. 2. Phase, explore and realize. 3. Frequency, common in systems older than 10 years with poor data hygiene. 4. Primary ownership, data archiving specialist. 5. Supporting SD functional lead and basis lead. 6. Business ownership, sales operations manager. 7. Relevant SAP note, not applicable data governance and cleansing. This is a data lifecycle management failure.
Diagnostic dashboard, symptoms and evidence.
How archiving scope errors manifest during the migration. 1. Symptom: in S/4HANA, the document flow for a billing document shows sales order does not exist or points to a missing object ID. 2. Red flag: massive archiving runs are executed in ECC just weeks before the final cutover without a residence time validation. 3. Business impact: inability to process returns, credit memos, or cancellations for documents that were prematurely archived. 4. Detection: checking transaction SARA in the legacy ECC system shows that the residence time was set to 0 or was bypassed for specific document types. 5. Technical proof: data migration logs show skip status for documents because the corresponding header record is missing from the physical VBAK table. Insight: archiving is a scalpel, not a sledgehammer. If you cut too deep, you kill the document flow integrity.
Why this happens, scenario analysis and root cause.
1. Project pressure to reduce the HANA database size, and thus the cloud hosting costs, leads to aggressive archiving policies. 2. Functional SD leads fail to account for long-running sales processes, such as 3-year service contracts or complex project-based billing. 3. The archiving team uses standard SAP residence times without realizing that custom Z processes in the legacy system keep documents open longer than standard. 4. A lack of integration between the archiving team and the data migration team. Archiving is often treated as a basis task rather than a business task. The failure is a result of treating archiving as a technical sizing exercise instead of a business lifecycle exercise.
Why this is a migration exclusive failure.
1. In ECC, if you archive too much, you could technically reload data from the archive, although it was difficult. 2. In S/4HANA Brownfield Conversion, the System Conversion Tools (SUM) do not look into ECC archives. They only transform data in the live database. 3. Once the conversion is finished, you cannot reload ECC formatted archives into the new S/4HANA data model. 4. This failure only surfaces when the newly converted S/4HANA system encounters a broken link to a document that should have been migrated but was archived instead. Archiving during a migration is a one-way street. Once archived, that data is invisible to the S/4HANA digital core.
Financial and customer impact.
1. Revenue leakage occurs when customers return goods, but the system cannot find the original sale to process the refund correctly. 2. Delayed cash application if incoming payments cannot be matched to billing documents that were prematurely archived. 3. Legal compliance risks if warranty or service documents are archived before their mandatory retention period in the live system. 4. High cost of manual data entry to reconstruct the document chain in S/4HANA so that business processes can continue. Archiving scope failures directly disrupt the audit trail of the order-to-cash process.
Governance and accountability, RACI model.
Successful archiving requires a triple sync between basis, functional, and business leads. 1. Accountable data archiving specialist owns the execution of the SARA jobs and the technical integrity of the archive files. 2. Responsible SD functional lead defines the residence time and retention period for every sales and billing document type. 3. Consulted basis lead monitors the impact of archiving on the overall database size and conversion performance. 4. Informed sales operations manager validates that active business processes will not be impacted by the archiving run. Functional teams must define the what. Archiving teams define the how.
Ownership, who actually fixes it.
Resolving this requires a residence time audit and cross-functional document flow validation. 1. SD functional lead reviews all incomplete and open documents in transaction V.02 and VB3 to ensure they are excluded from archiving. 2. Data archiving specialist configures the archive objects SD_VBAC and SD_VBRK with business-approved residence times. 3. Basis lead performs a archive index check to ensure that archive data can still be viewed read-only via the Archive Information System, SRI. 4. Business users perform a return of old sales simulation in the sandbox to verify that historical documents are still accessible for returns.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes basis deleted data during the migration. 2. Blamed data migration team. Users assume the data was simply forgotten during the load. 3. Actual owner SD functional lead responsible for failing to validate the residence time and business status of the data being archived. 4. Root cause treating archiving as a technical sizing task instead of a business logic task. Archiving failures are almost always functional logic errors, not technical basis errors.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates a residence time analysis based on the longest possible return window, for example, 2 years. 2. Data archiving specialist uses the check mode in transaction SARA to identify documents that are technically ready but functionally open. 3. The team implements ILM, Information Lifecycle Management policies to automate the archiving based on business-relevant dates rather than technical dates. 4. Basis team ensures that archive information structures are active, so that S/4HANA can still see the archived document headers in the document flow.
What not to do, common wrong fixes.
1. Setting residence times to 0 to clean the system before migration. This is architectural suicide for a brownfield conversion. 2. Archiving documents based only on creation date while ignoring the document status or billing status. 3. Failing to test the archive retrieval in the S/4HANA environment during the first mock conversion. 4. allowing archiving to run during the data freeze period of the cutover. Aggressive archiving without status validation will break the document flow of your new system.
Follow-up 1. What is residence time, and why is it critical for S/4HANA migration?
Answer: residence time is the number of days a document must stay in the live database after it has been closed before it can be archived. For a migration, you must set this carefully. If your business allows returns for up to 365 days, your residence time must be at least 366 days, or you will break the return process in S/4HANA.
Follow-up 2. Can I view archived ECC data from within S/4HANA?
Answer: yes, provided you move the archive files to a storage system that S/4HANA can access, and you activate the Archive Information System, SORI. However, the data will be read-only and will not participate in active business logic like automatic credit memos.
Follow-up 3. Curveball. Is it better to archive before or after the migration?
Answer: always archive before the migration. Archiving in ECC reduces the size of the database that needs to be converted, which significantly speeds up the SUM process. However, the scope must be strictly validated by the functional leads to ensure no live document threads are cut.
Exclusive pro tip.
Before you start any archiving run, execute transaction V.02, list of incomplete sales orders. Any document on that list is a candidate for cleansing but not archiving. If you archive an incomplete order, you create a permanent ghost entry in your document flow that can never be closed in S/4HANA.
Scenario 105. Data volume underestimated.
During the realize phase of an ECC to S/4HANA migration, the project team often fails to calculate the impact of massive data volumes on the conversion engine. Unlike standard upgrades, S/4HANA requires physical data transformation, such as converting billions of records from the KONV cluster to the PRCD_elements transparent table. Underestimating this volume leads to mock conversion cycles that exceed the technical downtime window, forcing the project to delay the go-live or aggressively delete data without business approval.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high technical execution and timeline risk. 2. Phase, realize and deploy. 3. Frequency, extremely common in large global enterprises. 4. Primary ownership, data migration lead. 5. Supporting basis lead and technical architect. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable data governance and strategy. This is a technical planning and sizing failure.
Diagnostic dashboard, symptoms and evidence.
How volume underestimation appears during conversion mocks. 1. Symptom: the data conversion step in the Software Update Manager, SUM, runs for 72 hours and eventually fails due to log file overflow. 2. Red flag: the project sizing was based on the ECC database size, for example 2 terabytes, without accounting for the temporary space needed for data transformation. 3. Business impact: the planned 48-hour cutover window is mathematically impossible to meet, leading to a canceled go-live. 4. Detection: comparing Mach 1 runtime with the available production downtime reveals a massive 200% variance. 5. Technical proof: database monitors show 100% CPU utilization and massive I/O wait times during the pricing table migration. Insight: in S/4HANA, the size of the database is less important than the number of records in pricing and finance.
Why this happens, scenario analysis and root cause.
1. Project managers assume that HANA is fast and will automatically solve the problem of processing 20 years of sales history. 2. Testing is performed in a small sandbox with only 10% of production data, giving a false sense of security regarding conversion speeds. 3. Failure to account for index rebuilding and table partitioning, which are required for high-volume SD tables like VBRP and PRCD_elements. 4. Legacy ECC systems often contain millions of orphan pricing records that should have been archived years ago. The failure is a result of a planning model that ignores the physics of data transformation.
Why this is a migration, exclusive failure.
1. ECC upgrades, for example, EHP 7 to EHP 8, are metadata upgrades where the physical data stays in place. 2. S/4HANA migration is a data model transformation where billions of cells are moved, recalculated, and reinserted into new tables. 3. The downtime requirement for S/4HANA is fundamentally driven by record counts in KONV, MATDOC, and ACDOCA. 4. This failure only surfaces during the first full-volume mock of the S/4HANA conversion process. S/4HANA introduces a transformation tax on data volume that ECC never had.
Financial and customer impact.
1. Massive budget overruns as the project is forced to perform multiple extra mocks to optimize conversion speed. 2. Business disruption if the system remains down past the Monday morning start of business, blocking all shipping and billing. 3. Loss of ROI as the company is forced to purchase more expensive HANA appliances than originally budgeted. 4. Reputational damage to the IT organization when a high-profile go-live is aborted at the last minute. Underestimated volume turns a technical migration into an expensive business crisis.
Governance and accountability, RACI model.
Managing volume risk requires a partnership between data and basis teams. 1. Accountable data migration lead owns the full volume data profile and the downtime calculation model. 2. Responsible basis lead optimizes the SUM parameters and database parallelization to achieve maximum throughput. 3. Consulted SD functional lead provides the minimal data set requirements in case aggressive archiving is needed. 4. Informed IT transformation director manages stakeholder expectations regarding the cutover window. Accountability ensures that downtime is a calculated risk, not a surprise.
Ownership, who actually fixes it.
Resolving this requires a technical dress rehearsal on production-grade hardware. 1. Data migration lead executes a data footprint analysis using the SAP readiness check tool. 2. Basis lead configures SUM parallelization parameters based on the number of available CPU cores. 3. Technical architect implements table partitioning for the largest SD tables, for example, VBFA and PRCD_elements, to speed up conversion. 4. The team performs a mock migration on a full copy of production data to establish a realistic downtime baseline.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes the servers are too slow. 2. Blamed SAP users claim the SUM tool is buggy because it takes too long. 3. Actual owner data migration lead responsible for the failure to perform a volume-based risk assessment early in the project. 4. Root cause, failing to bridge the gap between data volume and technical downtime. Blame targets the symptoms. Ownership targets the planning error.
How this is actually fixed, the right way by a role.
1. Data migration lead mandates a full copy of the production ECC system for the final 2 mock migrations. 2. Basis lead utilizes uptime processing features in the SUM tool to perform as much data transformation as possible before the system goes offline. 3. The team utilizes SAP NZDM, near zero downtime, technology if the standard conversion window is still too long. 4. Functional teams execute an emergency archiving sprint to remove non-essential document history from the conversion scope.
What not to do, common wrong fixes.
1. Extrapolating downtime from a sandbox run that only has 1 GB of data. Volume performance is non-linear. 2. Ignoring the data growth that happens in the production system between Mach 1 and the final cutover. 3. Assuming that adding more RAM to the HANA server will fix a single-threaded data conversion bottleneck. 4. Skipping the post-conversion index rebuild to save time, resulting in a system that is too slow to use after go-live. Shortcuts in volume testing will always lead to a catastrophic failure during the actual go-live weekend.
Follow-up 1. Which SD tables are the biggest bottlenecks during an S/4HANA conversion?
Answer: the biggest bottlenecks are KONV, converted to PRCD_elements, VBFA document flow, and via KPA/via PMA sales indices. If these tables have hundreds of millions of rows, they will dominate your downtime window. You must focus your archiving and optimization efforts on these specific objects.
Follow-up 2. What is SUM parallelization and why is it critical?
Answer: SUM can run multiple data transformation tasks at the same time. If you have a powerful server with 64 CPU cores, you can tell SUM to use 40 of them for data conversion. If you leave the default setting of 3 or 4, your migration will take weeks instead of days.
Follow-up 3, Curveball. Can I use selective data migration to avoid the volume issue?
Answer: yes, but that changes the project from a brownfield conversion to a selective data transition. This is much more complex and requires specialized tools like SAP data management and landscape transformation, DMLT. It solves the volume issue but introduces high risk regarding document flow integrity.
Exclusive pro tip.
Before starting your first mock, execute the downtime estimation tool provided in the SAP readiness check. Use these results to justify a full production copy for testing. Never accept a conversion plan that has not been tested against 100% of your production data volume.
Scenario 106. Selective migration inconsistency.
In the explore and realize phases of a selective data transition migration, organizations choose to move only a subset of data, such as specific sales organizations or the last 2 years of history. However, failure to analyze cross-object dependencies leads to critical data inconsistencies. If an open sales order is migrated but its original contract or the linked quotation is left behind in the legacy system, the document flow in S/4HANA breaks, preventing billing, returns, and historical audit reporting.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high data integrity and logic impact. 2. Phase, explore and realize. 3. Frequency, common in Bluefield or selective transition projects. 4. Primary ownership, data architect. 5. Supporting SD functional lead and integration architect. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable data governance and strategy. This is an architectural and link analysis failure.
Diagnostic dashboard, symptoms and evidence.
How selective migration errors manifest in the target system. 1. Symptom. Users attempt to create a credit memo in S/4HANA, but receive the error reference document 12345 does not exist. 2. Red flag. The migration strategy uses simple date-based filters for transactions without performing a VBF link analysis. 3. Business impact. Inability to process returns or warranties for historical sales, leading to revenue leakage and customer dissatisfaction. 4. Detection. Running a document flow report in S/4HANA shows dead ends where the predecessor document is missing. 5. Technical proof. SQL queries on table VBFA document flow in S/4HANA show references to VBELN numbers that do not exist in table VBAK. Insight. Selective migration is not a filter. It is a surgical procedure that must keep the nervous system of document links intact.
Why this happens, scenario analysis and root cause.
1. Organizations want to clean the slate and only move active business, but they fail to realize that an active order often depends on a closed quotation or contract. 2. Technical teams use standard migration objects that load data in silos, for example, customers first, then orders, without checking the deep links between them. 3. Lack of traceability matrix to ensure that all master data, materials, partners required for a specific transaction subset is also migrated. 4. Underestimation of the complexity of cross-company links, where an order in one migrated entity refers to a document in a non-migrated entity. The failure is a result of treating SAP data as individual records instead of a connected web of business events.
Why this is a migration, exclusive failure.
1. In a standard brownfield conversion, this is impossible because 100% of the database is moved and transformed together. 2. Selective data transition is a hybrid approach that purposefully splits the database, creating a risk of dangling references. 3. Standard SAP tools like the migration cockpit do not automatically crawl the document flow to find every predecessor document. 4. This failure only surfaces when the business attempts to execute a process that spans the selection boundary of the migration. Selective transition creates a data cliff where document links can easily fall off.
Financial and customer impact.
1. Revenue leakage occurs when contract-based pricing cannot be applied because the original contract was not migrated. 2. Audit failures arise when the system cannot provide a complete audit trail from a current invoice back to the original customer quote. 3. Operational delays, as users must manually look up data in the old ECC read-only system to finish transactions in S/4HANA. 4. Inaccurate commission payments, if the commission logic depends on historical document links that are now broken. Inconsistent data links directly degrade the reliability of the order-to-cash process.
Governance and accountability, RACI model.
Selective migration requires a deep partnership between data architects and SD experts. 1. Accountable data architect owns the selection logic and the technical integrity of the cross-document links. 2. Responsible SD functional lead defines the selection criteria, for example, which sales orgs, and validates the document flow requirements. 3. Consulted integration architect ensures that external systems are also aware of the selection boundary. 4. Informed IT transformation director monitors the risk of data gaps in the new S/4HANA system. Accountability ensures that selection does not become corruption.
Ownership, who actually fixes it.
Resolving this requires an object link analysis prior to the data load. 1. Data architect utilizes specialized tools like SAP DMLT to walk the tree of document links starting from the selected subset. 2. SD functional lead performs a document flow audit on sample orders to identify mandatory predecessors, contracts, quotes, inquiries. 3. Technical architect implements data integrity checks in the landing zone of S/4HANA to flag missing references before they are saved. 4. Data migration team executes bridge loads to bring in missing predecessor documents that were initially outside of the scope date range.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead users claim the order type is broken because they cannot refer to a contract. 2. Blamed data migration team, the business assumes they forgot to load specific records. 3. Actual owner, data architect responsible for the failure to design a link-aware selection algorithm. 4. Root cause, treating selective migration as a simple table filter rather than a business object transition. Data link errors are architectural failures, not functional configuration errors.
How this is actually fixed, the right way by a role.
1. Data architect mandated that selection criteria be applied to document chains, not individual tables. 2. The team implements a recursive selection logic. If an order is selected, the system automatically pulls its quotation, even if the quotation is 5 years old. 3. SD functional lead performs link testing in the sandbox, ensuring every migrated invoice can be navigated back to its origin. 4. The project team utilizes SAP Landscape Transformation, SLT, to replicate missing master data in real time if a link is discovered post-migration.
What not to do, common wrong fixes.
1. Relying on manual reference entry in S/4HANA to bypass a missing document link. This destroys the VBF audit trail. 2. Filtering based on last change date without realizing that an old contract might still be the source for a new order. 3. Assuming that business partners will automatically link to migrated customers if the BP was not part of the selection subset. 4. Allowing orphan deliveries to be migrated without their parent sales orders. Selective migration without dependency analysis will leave your S/4HANA system in a permanently inconsistent state.
Follow-up 1. Why is table VBFA so critical in selective migration?
Answer: Table VBFA is the map of the entire SD document flow. In a selective migration, you must query VBFA for every document you select to see what came before it. If you move document B but not its predecessor A, the reference fields in B will point to a ghost record, breaking standard SAP logic for returns and credits.
Follow-up 2. What is the selection boundary and how do I define it?
Answer: the selection boundary is the set of rules that defines what stays and what goes. A good boundary is usually based on company code or sales org plus a hard date. However, the architect must build exception rules to ensure that any document linked to an open item is brought across the boundary, regardless of its age.
Follow-up 3. Curveball. Is selective migration safer than a full brownfield conversion?
Answer: no. It is technically much riskier and more expensive. Selective migration is used when a company has so much data rot or such a massive database that a standard brownfield conversion is impossible. It requires 10 times more analysis to ensure data consistency compared to a standard conversion.
Exclusive pro tip.
When performing a selective migration, always include a link check step in your load logic. If a document refers to a predecessor that is not in the load file, the load should error out immediately. It is better to have a failed load than a successfully loaded inconsistent system.
Scenario 107. Migration object sequencing errors.
During the realize phase of an S/4HANA migration, data teams often encounter massive load failures due to incorrect sequencing of migration objects. In the SD module, data is highly relational. You cannot migrate a sales order if the business partner, material master, or pricing conditions do not already exist in the target system. Failure to define and execute a strict technical dependency map results in parent record not found errors, causing migration cycles to stall and requiring time-consuming data rollbacks.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium technical execution and logic impact. 2. Phase, realize and deploy. 3. Frequency, very common in projects using the SAP S/4HANA migration cockpit. 4. Primary ownership, data migration lead. 5. Supporting SD functional lead and technical architect. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable data governance and strategy. This is a technical orchestration and dependency failure.
Diagnostic dashboard, symptoms and evidence.
How sequencing errors manifest during mock migration cycles. 1. Symptom, Migration Cockpit LTMC or Migrate Your Data app returns thousands of validation errors stating that the customer or material is unknown. 2. Red flag, the data team attempts to load transactional data orders in parallel with master data partners to save time. 3. Business impact, migration timelines are extended as the team is forced to delete failed records and restart the load from scratch. 4. Detection, error logs show that internal IDs, for example GUIDs, for business partners were not generated before the sales order load attempted to reference them. 5. Technical proof, table VBAK entries in the target system show inconsistent status because the mandatory partner roles in table VBPA are missing. Insight, SAP migration is a building block process. If the foundation is not set, the upper floors will collapse.
Why this happens, scenario analysis and root cause.
1. Lack of a formal object dependency map that identifies the mandatory prerequisites for every SD data object. 2. Over-reliance on the automatic features of migration tools, which do not always enforce cross-object validation for custom Z fields. 3. Pressure to meet a go-live window leads teams to bypass sequential loads in favor of risky parallel processing. 4. Incomplete CVI, customer-vendor integration, synchronization, where the customer record exists but the business partner role is not yet active. The failure is a result of a technical strategy that ignores the relational integrity of the SAP data model.
Why this is a migration, exclusive failure.
1. In an established ECC system, data is created sequentially by users, ensuring that a material always exists before an order is placed. 2. S/4HANA migration is a bulk load event where millions of records are injected into an empty or semi-empty system in a short period. 3. Because S/4HANA uses new internal structures for business partners and pricing, the legacy ECC creation order is not enough to guarantee success. 4. This failure only surfaces when the migration engine attempts to validate a child record order against a non-existent parent record, BP. Bulk migration breaks the natural sequence of data creation that ECC took for granted.
Financial and customer impact.
1. The project cutover window is missed, resulting in a delayed go-live and significant business disruption costs. 2. Incomplete sales data in S/4HANA prevents the fulfillment of open orders, leading to lost revenue and customer penalties. 3. Financial reconciliation fails because billing documents are migrated without the corresponding cost of goods sold data from the material master. 4. High cost of manual data remediation if only a portion of a document chain is successfully migrated. Sequencing errors turn a structured migration into a chaotic data cleanup exercise.
Governance and accountability, RACI model.
Managing sequencing requires a strict master schedule for all data objects. 1. Accountable data migration lead owns the migration object sequence and the technical execution plan. 2. Responsible data migration team executes the loads according to the defined sequence and monitors for prerequisite errors. 3. Consulted SD functional lead validates the business object dependencies, for example, contracts before orders. 4. Informed Cutover manager monitors the progress of the data loads against the overall go-live timeline. Accountability ensures that no data is loaded until its prerequisites are verified.
Ownership, who actually fixes it.
Resolving this requires an end-to-end sequencing audit and technical verification. 1. Data migration lead creates a technical object dependency matrix that lists every table and its foreign key requirements. 2. Technical architect configures the migration cockpit to enforce prerequisite checks before allowing a load to proceed. 3. SD functional lead provides the cross-object business logic. For example, quotations must be loaded before sales orders. 4. Data migration team executes a smoke test with 10 records for every object to verify the sequence before the bulk load.
Who gets blamed versus who owns it.
1. Blamed data migration team. The business assumes the loaders are not doing their job correctly. 2. Blamed SAP users claim the migration cockpit is too restrictive or hard to use. 3. Actual owner data migration lead responsible for the failure to design a technically sound load sequence. 4. Root cause, treating SAP data as isolated flat files instead of a connected relational database. In SAP, the sequence of the load is as important as the data in the file.
How this is actually fixed, the right way by a role.
1. Data migration lead mandates the use of the standard SAP object sequence, org data first, then master data, then transactional data. 2. The team implements a gate check approach. Transactional data loads, for example, VBAK, cannot start until a 100% success report is generated for master data, for example, BP and MATNR. 3. Technical architect utilizes automation scripts to verify record counts in the target system tables before the next object in the sequence is triggered. 4. Functional leads perform chain testing after each load to ensure the document flow is technically traversable.
What not to do, common wrong fixes.
1. Loading data in parallel using multiple migration cockpit projects without checking for cross-object locks or dependencies. 2. Attempting to skip the master data load by manually creating a few records. This leads to GUID mismatches and failed transactions later. 3. Ignoring warning messages during the validation phase of the load. Warnings often indicate missing prerequisites that will become hard errors during the load. 4. Deleting data directly from the S4 HANA database tables to fix a sequencing error instead of using the standard cancel and rollback features. Shortcuts in sequencing lead to orphan data that can take weeks to clean up.
Follow-up 1. What is the mandatory load sequence for a standard SD migration?
Answer: the sequence is strictly 1. Organizational structures, sales org plant. 2. Master data materials, business partners, pricing conditions. 3. Predecessor transactions, quotes, contracts. 4. Main transactions, orders, deliveries. And 5. Subsequent documents, billing documents.
Follow-up 2. How do I handle circular dependencies in migration?
Answer: circular dependencies are rare in standard SAP but common in custom Z tables. In these cases, you must perform a two-pass load. Load the basic records first to establish the IDs, then perform a secondary update load to populate the complex relational fields once all records exist.
Follow-up 3. Curveball. Can the SAP migration cockpit automatically determine the sequence?
Answer: only partially. The cockpit knows the internal dependencies of a single object. For example, it knows an order needs a header. However, it does not automatically know that your custom sales order interface depends on a specific Z table being loaded first. You must design the orchestration layer yourself.
Exclusive pro tip.
Before the first mock migration, create a migration runbook that lists every data object and its prerequisite ID. Use a stoplight system to ensure that no technical loader is allowed to trigger a transactional load until the master data lead has given a green light sign-off.
Scenario 108. Mock loads inconsistent.
In the realize phase of an ECC to S/4HANA migration, organizations perform multiple mock migrations to refine the data load process. However, a critical failure occurs when the data snapshots used for each mock are inconsistent. If Mock 1 uses a different set of sales organizations or a different data cutoff date than Mock 2, the testing results become non-comparable. This prevents the team from establishing a performance baseline or verifying that the fixed errors from a previous mock stay fixed.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium project governance and quality impact. 2. Phase, realize. 3. Frequency, common in large global programs with disjointed work streams. 4. Primary ownership, data migration lead. 5. Supporting basis lead and SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable data governance and strategy. This is a data, life cycle, and testing governance failure.
Diagnostic dashboard, symptoms and evidence.
How mock inconsistency appears during the migration cycle. 1. Symptom, error counts fluctuate wildly between mocks, for example, 100 errors in Mock 1, 5,000 errors in Mock 2, without a clear technical reason. 2. Red flag, the data team uses live data extracted from the ECC production system at different timestamps for each mock cycle. 3. Business impact, inability to prove that the cleansing efforts are working, leading to a loss of project momentum and stakeholder confidence. 4. Detection, comparing the control totals of the source data, reveals that the record counts for table VBAK differ significantly between test cycles. 5. Technical proof, the mapping rules in the migration cockpit have been modified between mocks without a formal version control or change log. Insight, a mock migration is a scientific experiment. If you change the variables, the results are scientifically invalid.
Why this happens, scenario analysis and root cause.
1. Pressure to start the mock leads the team to use whatever data is available in the sandbox rather than waiting for a formal production snapshot. 2. Lack of a data extraction script that is version controlled and used consistently across all migration environments. 3. The project team fails to implement a data freeze in the test environment, allowing functional teams to manually change data during the load process. 4. Organizations underinvest in the data staging area, leading to fragmented and uncoordinated data extractions from legacy systems. The failure is a result of treating mock migrations as practice runs rather than technical validations.
Why this is a migration, exclusive failure.
1. ECC upgrades typically use the entire database, so selection inconsistency is not an issue. 2. S/4HANA migration often involves selective data loads or complex transformations that require multiple testing iterations, mocks. 3. Because these mocks determine the technical downtime for the final go-live, any inconsistency in the data volume or complexity makes the estimate useless. 4. This failure only surfaces when the team attempts to reconcile the results of two different migration cycles. Migration requires iterative testing. If the iterations are inconsistent, the project cannot improve.
Financial and customer impact.
1. Increased consulting costs as the team is forced to perform Mock 3 or Mock 4 simply to establish a reliable baseline. 2. Unexpected errors during the final production cutover because specific data scenarios were lost between mock cycles. 3. Loss of management trust in the IT organization's ability to execute a safe and predictable go-live. 4. Operational risk on day 1. If the cleansed data from Mock 1 was overwritten by dirty data in a later, inconsistent mock. Inconsistent mocks create a false sense of readiness that is shattered during the final cutover.
Governance and accountability, RACI model.
Ensuring mock consistency requires a frozen data strategy and strict version control. 1. Accountable, data migration lead owns the mock execution plan and ensure that data snapshots are consistent. 2. Responsible, basis lead performs the system refreshes and ensures the data staging environment is frozen for the duration of the mock. 3. Consulted, SD functional lead validates that the representative data set chosen for the mock reflects all business variants. 4. Informed, IT Transformation Director monitors the error trend as a key indicator of project readiness. Accountability ensures that each mock builds upon the success of the previous one.
Ownership, who actually fixes it.
Resolving this requires a standardized extraction and staging architecture. 1. Data migration lead defines a golden data set, a frozen snapshot of production data that is used for all mock cycles. 2. Technical architect implements data fingerprinting to verify that the source data file has not changed between extraction and load. 3. Basis lead ensures that the S/4HANA target environment is refreshed to a clean state before every mock migration begins. 4. SD functional lead verifies the scope parameters, for example, company codes and date ranges, are identical in every extraction run.
Who gets blamed versus who owns it.
1. Blamed, SD functional lead seen as being unable to provide final requirements for the data. 2. Blamed, technical architect executives assume the migration tools are not working consistently. 3. Actual owner, data migration lead responsible for the failure to enforce a mock governance policy. 4. Root cause, treating each mock migration as an isolated event rather than part of a continuous quality improvement cycle. Consistency is not a technical feature. It is a governance discipline.
How this is actually fixed, the right way by a role.
1. Data migration lead mandates the use of a single production snapshot that is copied to the staging area once and used for all testing. 2. The team implements version-controlled mapping tables in the migration cockpit to ensure that logic changes are tracked and audited. 3. Functional leads use a standardized reconciliation report to verify that the input and output counts are identical across all mocks. 4. The team executes a delta load simulation to test how new records created in production, since the snapshot will be handled during the final cutover.
What not to do, common wrong fixes.
1. Using live data for every mock. You will never be able to debug an error if the source data is changing every day. 2. Skipping the system refresh before a mock to save time. Loading data into a dirty environment will cause primary key conflicts. 3. Allowing developers to manually tweak data in the target system to pass a test. This logic will be lost during the final production load. 4. Comparing results between a selective mock, one sales org, and a full mock, all sales orgs, without normalizing the data. Inconsistent mocks are a form of technical debt that will eventually come due on go-live day.
Follow-up 1. What is the ideal number of mock migrations for an SD project?
Answer: for a standard brownfield conversion, a minimum of 3 mocks is recommended. Mock 1, data and performance baseline. Mock 2, validation of cleansing and mapping. And Mock 3, the technical dress rehearsal for cutover. Large global programs may require 5 or more.
Follow-up 2. How do I handle delta data that is created during the migration weekend?
Answer: this is handled via a delta migration strategy. After the initial bulk load, you perform a secondary extraction of records created or changed since the last snapshot. The extraction logic must be identical to the bulk load logic to ensure consistency.
Follow-up 3. Curveball. Can we perform a mock migration using anonymized or scrambled data?
Answer: technically yes, using tools like SAP Test Data Migration Server, TDMS. However, scrambling data often hides the real-world data errors, like special characters in addresses, that cause load failures. It is always better to perform the final mock using a raw, non-scrambled copy of production data.
Exclusive pro tip.
Establish a mock readiness checklist. A mock migration cannot start until the extraction script is version locked, the target system is confirmed as clean, and the control record counts have been audited. In data migration, slow is smooth and smooth is fast.
Scenario 109. CVI preparation incomplete.
In the realize phase of an ECC to S/4HANA migration, the customer-vendor integration synchronization is the single most frequent point of technical failure. S/4HANA mandates that all customers and vendors must be transformed into business partners before the system conversion begins. If the preparation in ECC, such as mapping account groups to BP groupings or resolving underlying data inconsistencies in table KNA1, is incomplete, the CVI cockpit will block the migration, resulting in a failed technical cutover.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high critical path and technical roadblock. 2. Phase, realize and deploy. 3. Frequency, extremely common in all brownfield conversions. 4. Primary ownership, master data management lead. 5. Supporting ABAP custom code remediation lead and SD functional lead. 6. Business ownership, global master data governance manager. 7. Relevant SAP note. SAP note 2713963. CVI master data sync.
Diagnostic dashboard, symptoms and evidence.
How CVI preparation failures appear during the synchronization process. 1. Symptom, the CVI cockpit transaction MDS_load_cockpit shows a red status with thousands of records failing to synchronize. 2. Red flag, the post-processing office transaction MDS_PPO2 is flooded with errors like postal code is incorrect or tax number is invalid. 3. Business impact, the technical conversion, SUM, cannot proceed because the pre-check for business partners returns a hard error. 4. Detection, running the CVI_cockpit pre-check report reveals missing mandatory mapping for specific SD account groups. 5. Technical proof, errors in table MDS_control_OBJ_HYS show that the synchronization process timed out due to mass data inconsistencies. Insight, CVI is not just a technical bridge. It is a data audit that ECC allowed you to ignore for 20 years.
Why this happens, scenario analysis and root cause.
1. Legacy ECC data was often created with incomplete status or with bypassed validation rules using custom Z upload tools. 2. Failure to align the customer account groups in SD with the business partner groupings in the cross-application component configuration. 3. Underestimating the contact person migration. ECC handled contacts as separate objects, table KNVK, that must now be fully integrated BPs. 4. The project team attempts to run the CVI sync without first applying the mandatory CVI pre-check SAP notes and data cleansing reports. The failure is a result of treating CVI as a switch rather than a data reconstruction project.
Why this is a migration, exclusive failure.
1. ECC functioned perfectly with separate customer and vendor tables that had no mandatory link to a central partner object. 2. S4 HANA physically requires the BP to customer link for the application logic to execute VA01 or BP transactions. 3. Standard ECC upgrades do not check for postal code accuracy or tax ID duplicates. The S4 HANA CVI engine enforces these strictly. 4. The failure only surfaces during the prepare and realize stages of an S4 HANA brownfield conversion. CVI is a mandatory gatekeeper that only exists in the S4 HANA migration lifecycle.
Financial and customer impact.
1. Blocked cutover leads to delayed go-live, costing the organization hundreds of thousands of dollars in extended project burn rates. 2. Inaccurate BP mapping results in customer credit data being lost, leading to unintended delivery blocks or unauthorized credit exposure. 3. Customer disputes arise if ship-to or bill-to addresses are truncated or corrupted during the synchronization process. 4. Revenue leakage if pricing conditions tied to specific customer IDs fail to migrate because the BP was not created. CVI failures directly threaten the integrity of the enterprise master data backbone.
Governance and accountability, RACI model.
CVI requires the highest level of coordination in the migration project. 1. Accountable, master data management lead owns the final state of the business partner records and signs off on data readiness. 2. Responsible, SD functional lead defines the mapping for SD account groups and ensures that all mandatory fields are captured. 3. Consulted, ABAP custom code remediation lead implements custom CVI mapping baddies for complex customer hierarchies. 4. Informed, IT transformation director monitors the sync percentage as the primary metric for cutover readiness. Accountability ensures that data cleansing is completed before the technical team touches the system.
Ownership, who actually fixes it.
Resolving this requires a clean sync verify methodology. 1. MDM lead executes the CVI pre-check report, SAP note 2216176, to identify all technical and data errors in the ECC system. 2. Data migration team runs mass cleansing scripts to fix missing postal codes, email formats, and invalid tax IDs in table KNA1. 3. SD functional lead configures the direction, customer to BP mapping in the IMG for each account group. 4. Technical architect utilizes the MDS_load_cockpit to trigger the synchronization in blocks of 5,000 records to ensure performance stability.
Who gets blamed versus who owns it?
1. Blamed data migration team. The project board assumes the load failed. 2. Blamed SAP users claim the BP transaction is too difficult to use. 3. Actual owner, master data management lead responsible for the lack of data governance during the years leading up to the migration. 4. Root cause, decades of dirty data being exposed by the strict S4 HANA validation engine. You cannot fix CVI in the conversion weekend. You must fix it in the legacy system months before.
How this is actually fixed, the right way by a role.
1. MDM lead mandates a zero error policy for the MDS_PPO2 error queue in the ECC production system before the conversion starts. 2. The team implements CVI mapping baddies to handle custom SD fields that are not part of the standard BP structure. 3. Developers refactor any legacy customer exits to use the new BP framework, FSBP, to ensure data stays in sync after go live. 4. The project team executes a minimock migration, focusing only on CVI, to ensure the number ranges are perfectly aligned between BP and customer IDs.
What not to do, common wrong fixes.
1. Attempting to skip the synchronization for old or inactive customers. S4 HANA requires all records in the database to be converted. 2. Changing customer numbers to match BP numbers without checking for hard-coded values in custom ABAP code. 3. Disabling mandatory fields in the BP configuration just to pass the CVI check. This will cause errors in downstream billing and tax processes. 4. Relying on the standard mapping if you have highly customized sales areas or customer hierarchies. Shortcuts in CVI mapping will create orphan BPS that haunt your financial reporting for years.
Follow-up 1. What is the most common data error that causes CVI to fail?
Answer: the most common error is invalid email address or incorrect country code. ECC was very lenient with these fields, but the BP engine, which follows international standards, is extremely strict. You must use the CVI_cockpit pre-check reports to find and fix these before you start the sync.
Follow-up 2. Should I keep the customer number and the BP number the same?
Answer: yes. This is the industry best practice for brownfield migrations. By aligning the number ranges, you minimize the impact on custom reports and external interfaces that rely on the customer ID. If the numbers differ, you create a massive mapping debt for the business users.
Follow-up 3. Curveball. What happens if I have the same record as both a customer and a vendor in ECC?
Answer: this is the golden opportunity of CVI. You can link both records to a single business partner ID. This provides a 360-degree view of the relationship and allows for automatic netting of payables and receivables, which was much harder to achieve in ECC.
Exclusive pro tip.
Do not start your CVI synchronization in the sandbox. Start it in a copy of production or stage months before the migration. The volume and variety of real production data will uncover thousands of errors that a clean sandbox never will. Treat CVI as a standalone project, not a subtask.
Scenario 110. Pricing condition cleansing insufficient.
During the realize phase of an S4 HANA migration, organizations often neglect the cleansing of legacy pricing condition records. S4 HANA converts document pricing from the KONV cluster to the PRCD_elements transparent table, which enforces much stricter data integrity rules. If the legacy KONV table contains orphan records, conditions without a header, overlapping validity dates for the same key, or invalid currency conversions, the conversion engine will crash or produce inconsistent billing values after the migration.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high data integrity and financial impact. 2. Phase, realize and deploy. 3. Frequency, common in systems with decades of pricing history. 4. Primary ownership SD functional lead. 5. Supporting data migration lead and ABAP custom code remediation lead. 6. Business ownership sales controller. 7. Relevant SAP note 2267308 S4 HANA pricing data model.
Diagnostic dashboard, symptoms and evidence.
How insufficient pricing cleansing appears during the migration process. 1. Symptom: the S4 HANA conversion tool, SUM, fails during the conversion of pricing tables with a SQL integrity error. 2. Red flag: massive variances in net value are discovered during financial reconciliation between the legacy and target systems. 3. Business impact: inability to invoice customers or process credit memos on day 1 because the pricing engine returns errors for migrated documents. 4. Detection: running the pricing data consistency report, SAP Note 22288056, reveals millions of inconsistent records in table KONP and KONV. 5. Technical proof: database logs show duplicate key errors during the insert into table PRCD_elements. Insight: if your pricing data is dirty, the S4 HANA conversion engine will act as a filter that blocks your entire migration.
Why this happens, scenario analysis and root cause.
1. ECC allowed for incomplete document saves and manual database deletes, hacks, that left orphan condition records in the KONV cluster. 2. Decades of custom pricing interfaces that bypass standard BAPI often inserted records with invalid internal formats or scale types. 3. Failure to perform pricing archiving, object SD_cond, resulting in the migration engine attempting to convert 20 years of irrelevant data. 4. The project team underestimates the impact of numeric precision changes. S4 HANA handles currency decimals differently in the new transparent tables. The failure is a result of applying modern integrity rules to legacy historical data.
Why this is a migration, exclusive failure.
1. ECC upgrades kept the KONV cluster structure, which was very forgiving of data inconsistencies. 2. S4 HANA migration physically moves data into the PRCD_elements table, which uses strict relational database constraints. 3. The transformation tool, SUM, includes a mandatory validation step that did not exist in standard ECC enhancement packs. 4. This failure only surfaces when the physical data model is changed during the S4 HANA system conversion window. S4 HANA forces a level of pricing data discipline that ECC never required.
Financial and customer impact.
1. Revenue recognition is blocked if the system cannot calculate the condition value, KWERT, for historical sales. 2. Inaccurate customer invoices lead to high rates of billing disputes and delayed cash collection after go-live. 3. Audit failures occur if the company cannot prove the pricing calculation logic for historical documents due to missing records. 4. Increased cost of migration, as the project is forced to stop and perform emergency data cleansing during the cutover weekend. Pricing data failures directly erode the gross-to-net margin accuracy of the company.
Governance and accountability, RACI model.
Cleansing pricing data requires a mix of functional expertise and technical scripts. 1. Accountable: SD functional lead owns the integrity of the pricing logic and signs off on the final net value reconciliation. 2. Responsible: data migration lead executes the consistency checks and manages the cleansing of orphan records. 3. Consulted: sales controller validates that the cleansing of old records does not impact historical financial reporting. 4. Informed: IT transformation director monitors the pricing conversion runtime during the mock migration cycles. Accountability ensures that pricing accuracy is not sacrificed for migration speed.
Ownership: who actually fixes it.
Resolving this requires a find, cleanse, reconcile methodology. 1. SD functional lead runs the pricing consistency check reports provided in SAP Note 22288056. 2. Data migration lead creates SQL scripts to identify and delete orphan records in KONV that have no corresponding entry in VBAK or VBRK. 3. SD functional team resolves overlapping validity dates for condition records in transaction VK12. 4. Technical architect performs a net value comparison on 10,000 documents to verify that the S/4HANA conversion produced the same result as ECC.
Who gets blamed versus who owns it?
1. Blamed, basis team. The business assumes the technical upgrade corrupted the pricing tables. 2. Blamed, SAP. The users claim the new data model is buggy. 3. Actual owner, SD. Functional lead responsible for the failure to manage the pricing data lifecycle in the legacy system. 4. Root cause, years of technical debt in the pricing master data being exposed by the S/4HANA migration. Pricing conversion errors are usually data problems, not software bugs.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates a hard archiving run for all pricing condition records that have been expired for more than 5 years. 2. The team implements a technical cleansing program to remove any KONV records with invalid document numbers, KNUMV. 3. Basis team applies the latest S/4HANA conversion pre-checks to find and fix inconsistencies in currency decimal settings. 4. Developers refactor custom pricing routines to ensure they do not create new inconsistencies during the migration of open documents.
What not to do, common wrong fixes.
1. Attempting to migrate 50 million pricing records without running a consistency check. The conversion will likely fail halfway through. 2. Deleting pricing records that are still linked to open documents to speed up the migration. This will break billing. 3. Assuming that compatibility views will hide data integrity issues, views will actually expose them as runtime errors. 4. Ignoring currency decimal variances between ECC and S/4HANA for specific niche currencies. Ignoring pricing cleansing is a high-stakes gamble with your company's revenue accuracy.
Follow-up 1. Why is table PRCD_elements so much stricter than table KONV?
Answer: KONV was a cluster table, meaning the data was stored in a compressed, non-readable format. SAP could not easily enforce relational integrity on cluster data. PRCD_elements is a standard transparent table, meaning the HANA database validates every row for key uniqueness and data type compliance, exposing every error that was previously hidden.
Follow-up 2. What happens if I find thousands of orphan pricing records?
Answer: you must delete them from the KONV table in the legacy ECC system before the migration. SAP provides specific reports in the readiness check and relevant SAP notes to identify these. If you do not delete them, the SUM tool will attempt to convert them and fail, delaying your entire project.
Follow-up 3. Curveball. Can I use the S/4HANA migration to reset my pricing and start fresh?
Answer: only if you are doing a greenfield or selective migration. In a standard brownfield conversion, you are moving the entire database, including the pricing history. If you want to start fresh, you must archive your old data and only migrate the open pricing conditions, which is a major project effort.
Exclusive pro tip.
Before the realize phase ends, execute report PRC_MIG_check_tools from SAP Note 2228056 in your ECC production system. This report acts as a flight simulator for the pricing conversion. Fix every error it flags in production immediately, because any error there will become a project-stopping failure during your final cutover.
Scenario 111. Customer master cleansing insufficient.
During the realize phase of an ECC to S/4HANA migration, the project often stalls due to thousands of validation errors in the customer master data. In ECC, many fields were optional or poorly validated, leading to incomplete addresses, invalid tax IDs, and inconsistent communication data. S/4HANA Business Partner Synchronization enforces international data standards strictly. If this data is not cleansed in the legacy system before synchronization, the CVI process will fail, blocking the migration of sales and billing history.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium master data and governance impact. 2. Phase, realize. 3. Frequency, very common in organizations with global and legacy customer bases. 4. Primary ownership, master data management lead. 5. Supporting SD functional lead and ABAP custom code remediation lead. 6. Business ownership, master data governance council. 7. Relevant SAP note, not applicable data governance and cleansing. This is a data quality and discipline failure.
Diagnostic dashboard, symptoms and evidence.
How insufficient master data cleansing manifests during the migration. 1. Symptom. The CV synchronization cockpit shows a failure rate of 30% or higher for the customer load. 2. Red flag. Master data teams are manually fixing individual records in the PPO2 queue rather than executing mass cleansing scripts. 3. Business impact. The technical conversion downtime is extended because business partner synchronization must be completed before the system is usable. 4. Detection. Running the S/4HANA readiness check identifies thousands of customers with missing mandatory fields like postal code or country. 5. Technical proof. Errors in transaction MDS_PPO2 explicitly state address data is inconsistent or email address format is invalid. Insight. S/4HANA Business Partner is an international standard. It does not tolerate the local workarounds used in ECC.
Why this happens, scenario analysis and root cause.
1. For decades, ECC users were allowed to save customer records with placeholder data, for example, 99999 for postal codes, to bypass screen requirements. 2. Legacy Z upload programs and EDI interfaces often bypass standard SAP field validations when creating customers in table KNA1. 3. Inconsistent configuration of mandatory fields across different regional sales organizations created a fragmented data landscape. 4. The project team underestimated the effort of the address cleansing workstream, assuming CVI was a purely technical mapping task. The failure is a result of treating master data as a secondary technical object rather than a strategic asset.
Why this is a migration, exclusive failure.
1. Standard ECC upgrades, like moving from EHP6 to EHP8, do not revalidate existing master data records. 2. S/4HANA migration requires the creation of a business partner for every customer, which triggers the business partner validation engine. 3. This engine is hard-coded to enforce ISO standards for addresses, emails, and bank details that ECC allowed you to ignore. 4. This failure only surfaces when the system transition from the customer model to the business partner model begins. Migration turns quiet data debt into loud technical blocks.
Financial and customer impact.
1. Delayed go-live increases project costs by tens of thousands of dollars for every week the master data team is stuck in cleansing. 2. Customer invoices are sent to incorrect or formatted email addresses, leading to payment delays and increased DSO. 3. Incorrect ship-to addresses result in returned freight and increased logistics costs for the company. 4. Sales reps are unable to create orders for strategic customers whose records failed the migration check. Master data quality is the prerequisite for order-to-cash automation and cash flow stability.
Governance and accountability, RACI model.
Master data cleansing is a business-led activity supported by IT. 1. Accountable master data management lead owns the data quality KPIs and the final sign-off for load readiness. 2. Responsible data migration team executes the cleansing scripts and monitors the CV synchronization logs. 3. Consulted SD functional lead provides the business context for regional data requirements and mandatory fields. 4. Informed sales operations manager monitors the impact of data cleansing on sales user productivity. Accountability ensures that the business takes ownership of their own data quality.
Ownership, who actually fixes it.
Resolving this requires a legacy-first cleansing approach. 1. MDM lead identifies all customers that have not had an active transaction in the last 24 months and flags them for deactivation rather than cleansing. 2. Data migration team uses SAP Information Steward or custom SQL scripts to find and correct invalid data formats in table KNA1. 3. SD functional lead updates the account group configuration in ECC to ensure new records created during the migration project meet S/4HANA standards. 4. Business users manually validate and enrich the top 500 strategic customer records to ensure zero errors for key accounts.
Who gets blamed versus who owns it.
1. Blamed data migration team. The business assumes the loader is corrupting the data. 2. Blamed, SAP. The users claim S/4HANA is too picky compared to ECC. 3. Actual owner, master data management lead responsible for the historic failure to enforce data entry standards. 4. Root cause, years of data rot and bypassed validations in the legacy ECC environment. The migration is the messenger. The data is the problem.
How this is actually fixed, the right way by a role.
1. MDM lead mandates the use of the CVI_cockpit pre-checks in the production ECC system 6 months before go live. 2. The team implements real-time validation in the ECC system using SAP Note 2216176 to prevent users from adding new dirty data during the project. 3. Data migration team executes mass updates using transaction mass or custom LSMW routines to standardize email and address formats. 4. The team utilizes third-party address validation services, like Experian or Locate, to enrich and verify global customer addresses before the S/4HANA sync.
What not to do, common wrong fixes.
1. Bypassing the CVI validations by turning off mandatory fields in the BP configuration. This will cause invoices to fail later. 2. Attempting to cleanse data directly in the S/4HANA system after the load. This makes the data inconsistent with the source ECC system. 3. Ignoring duplicate records during the cleansing phase. Duplicates will cause the CVI link to fail if the tax ID is the same. 4. Waiting for the technical cutover to find out which records fail. At that point, it is too late to fix thousands of records. Shortcuts in master data cleansing will haunt your analytics and billing accuracy for years.
Follow-up 1. What are the most common fields that trigger CVI failures?
Answer. The top failure points are 1. Invalid email formats, missing @ or domain. 2. Postal codes not matching the country length requirements. 3. Missing search terms. And 4. Invalid tax jurisdictions. You must focus your automated cleansing scripts on these 4 areas first.
Follow-up 2. How does deactivating old customers help the migration?
Answer. Every record in the database must be converted during a brownfield migration. By marking old, unused customers as marked for deletion, you can often exclude them from certain strict validations or prioritize the cleansing effort on the active records that truly matter for the business.
Follow-up 3. Curveball. Can I use the S/4HANA migration cockpit to fix my data during the load?
Answer. Partially. The migration cockpit allows for mapping values, for example, change ECC term to S/4HANA term B. However, it cannot invent data that is missing. If the source ECC record is missing a mandatory email or phone number, the cockpit will simply error out. Cleansing must happen at the source.
Exclusive pro tip.
Run the report CVI_upgrade_check_resolve in your ECC production system immediately. It provides a detailed error log for every customer record that will fail the S/4HANA conversion. Treat the output of this report as the mandatory to-do list for your master data team.
Scenario 112. Duplicate hierarchies unresolved.
During the realize phase of an ECC to S/4HANA migration, organizations often discover that their customer hierarchies are riddled with circular references and duplicate nodes. In ECC, the hierarchy table KNVH was relatively flexible and rarely validated for logical consistency. However, S/4HANA uses hierarchies for critical pricing, rebate, and commission logic. If duplicate or orphan nodes exist in the legacy data, the migration of hierarchy assignments will fail or result in incorrect discount applications after go live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logic and pricing integrity impact. 2. Phase, realize. 3. Frequency, common in systems with complex national account structures. 4. Primary ownership, SD functional lead. 5. Supporting master data management lead. 6. Business ownership, sales controller and pricing manager. 7. Relevant SAP note, not applicable data governance and cleansing. This is a structural data integrity failure.
Diagnostic dashboard, symptoms and evidence.
How duplicate hierarchy errors manifest during testing. 1. Symptom, a sales order for a subsidiary customer fails to pick up the national account discount triggered by the hierarchy. 2. Red flag, data migration logs for object customer hierarchy show thousands of skip errors due to parent node not found. 3. Business impact, significant revenue leakage or customer overcharging due to failed pricing determination at the hierarchy level. 4. Detection, running a recursive SQL query on table KNVH reveals records where a customer is listed as its own parent circular reference. 5. Technical proof, transaction VDH1N in S4 HANA shows broken tree structures where nodes are disconnected from the root. Insight, an ECC hierarchy is just a table. An S4 HANA hierarchy is a financial control mechanism.
Why this happens, scenario analysis and root cause.
1. Over 15 years, customers were merged or acquired, but the hierarchy assignments in ECC were never updated or cleaned. 2. Legacy Z programs for hierarchy maintenance did not check for overlapping validity dates, datab and datby, for the same node. 3. ECC allowed dangling nodes where a customer was assigned to a parent ID that had been deleted or deactivated. 4. The project team failed to realize that S4 HANA requires every node in the hierarchy to be a fully synchronized business partner. The failure is a result of treating hierarchies as a reporting view rather than a business rule engine.
Why this is a migration, exclusive failure.
1. In ECC, a broken hierarchy node rarely caused a system crash. It simply resulted in a pricing not found error which users often ignored. 2. S4 HANA migration tools, Migration Cockpit, perform referential integrity checks that prevent the load of a node if its parent is missing. 3. The transition to the business partner model requires that hierarchy root nodes be correctly defined and converted to BPs. 4. This failure only surfaces when the hierarchy data is physically extracted and validated against the new S4 HANA business partner set. Migration forces a level of structural data integrity that ECC never enforced.
Financial and customer impact.
1. Incorrect pricing on sales orders leads to thousands of billing corrections and credit or debit memo requests post-go-live. 2. Rebate agreements tied to hierarchy nodes fail to accrue correctly, resulting in massive financial misstatements at month-end. 3. Commission payments to sales reps are calculated incorrectly if the repo to hierarchy mapping is broken. 4. Customer trust is eroded when global national account contracts are not honored in the new system. Hierarchy failures directly disrupt the company's ability to execute global contracts.
Governance and accountability, RACI model.
Hierarchy cleansing requires alignment between sales and MDM teams. 1. Accountable, SD functional lead owns the pricing and rebate logic driven by the hierarchy and signs off on the final tree structure. 2. Responsible, master data management lead executes the data cleansing scripts and resolves duplicate nodes in table KNVH. 3. Consulted, pricing manager validates the impact of hierarchy changes on current customer contracts. 4. Informed, sales controller monitors the accuracy of rebate accruals post-migration. Functional leads must define the truth of the customer relationship. MDM must implement it.
Ownership, who actually fixes it.
Resolving this requires a bottom-up hierarchy audit. 1. SD functional lead extracts the full KNVH table and identifies nodes where the validity to date is in the past. 2. MDM lead executes a duplicate check on table KNVH to find customers assigned to multiple parents in the same hierarchy type. 3. Pricing manager reviews orphan nodes customers with no parent to decide if they should be linked to a national account. 4. Data migration team uses the migration cockpit to load the cleaned hierarchy nodes in a strictly sequential top-down order.
Who gets blamed versus who owns it.
1. Blamed master data team. The sales team assumes my customer was moved to the wrong group. 2. Blamed SD lead. The business assumes the pricing condition was configured incorrectly. 3. Actual owner, SD functional lead responsible for the failure to validate the hierarchy logic during the Explore workshops. 4. Root cause, treating hierarchy as a static report instead of a dynamic business rule engine. If the tree is broken, the fruit pricing will be bad.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates a hierarchy cleanup sprint during the realize phase to resolve circular references. 2. The team implements a validation exit in transaction VDH1 to prevent users from creating overlapping hierarchy assignments. 3. MDM lead ensures that all root nodes are migrated as business partners before the child nodes are loaded. 4. Technical architect performs a hierarchy comparison test, ensuring that the HIE_cust condition in pricing returns the same results in S/4HANA as in ECC.
What not to do, common wrong fixes.
1. Migrating expired hierarchy records just to keep history. This will confuse the pricing engine and cause condition not found errors. 2. Ignoring circular references, assuming the system will just skip them. Circularity will cause infinite loops in pricing routines and dump the system. 3. Allowing hierarchy assignments to point to inactive customers who were not migrated to S/4HANA. 4. Using the S/4HANA migration to redesign the entire hierarchy. This is a massive scope creep that should be handled as a separate project. Shortcuts in hierarchy cleansing will lead to a nightmare of manual pricing overrides post-go-live.
Follow-up 1. What is a circular reference in a hierarchy, and why is it dangerous?
Answer: a circular reference happens when customer A is the parent of customer B, and customer B is mistakenly listed as the parent of customer A. In S/4HANA, when the pricing engine tries to roll up the hierarchy to find a discount, it will loop forever between A and B, eventually causing a system_no_role_memory short dump.
Follow-up 2. Do I need to move from ECC customer hierarchy to S/4HANA flexible hierarchy?
Answer: not necessarily. S/4HANA still supports the classic KNVH-based SD customer hierarchy. However, if you want advanced analytical rollups in Fiori, you should explore flexible hierarchies. For a brownfield conversion, the safest path is to clean and migrate the classic hierarchy first.
Follow-up 3. Curveball. What happens to my hierarchy-based rebates during migration?
Answer: S/4HANA replaces classic rebates with settlement management. The new engine is extremely sensitive to the hierarchy structure. If the hierarchy node is not found during the settlement run, the system will not calculate the accruals, leading to significant financial variances.
Exclusive pro tip.
Before migrating hierarchy data, run report RV_customer_hierarchy_check, if available, or create a custom query to find nodes with the same parent and child ID. These are self-referencing errors that will break the S/4HANA document pricing immediately.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 113. Tax classification incomplete.
In the realize phase of an ECC to S/4HANA migration, the project team often discovers that thousands of customer records are missing mandatory tax classifications in table KNVI. while ECC allowed users to save customer sales area data without defining tax indicators for every relevant country and tax category. The S/4HANA Business Partner Synchronization Engine enforces these fields as mandatory. If the tax classification data is incomplete or inconsistent, the CVI process will error out, preventing the migration of customer master data and blocking the creation of new sales orders.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium data governance and tax compliance impact. 2. Phase, realize. 3. Frequency, common in multinational ECC systems with organic growth. 4. Primary ownership, SD functional lead. 5. Supporting master data management lead and tax lead. 6. Business ownership, corporate tax manager. 7. Relevant SAP note, not applicable data governance and cleansing. This is a data quality and master data configuration failure.
Diagnostic dashboard, symptoms and evidence.
How tax classification gaps manifest during the CVI synchronization. 1. Symptom. The CVI synchronization cockpit triggers the error tax classification not maintained for tax category during the customer ABP load. 2. Red flag. New sales orders created in the converted S/4HANA environment default to tax-exempt regardless of the customer's actual status. 3. Business impact. Inaccurate tax calculation on invoices leads to significant financial liability and potential penalties during government audits. 4. Detection. A SQL query on table KNVI reveals customers with sales areas, KNB1, but no corresponding entries for mandatory tax types like MWST or UTXJ. 5. Technical proof. Transaction MDS_PPO2 shows synchronization objects stuck with required field missing errors for tax indicators. Insight. ECC tolerated missing tax data by defaulting to 0. S/4HANA demands a deliberate tax indicator for every sales org.
Why this happens, scenario analysis and root cause.
1. Legacy ECC master data teams often used placeholder or null values for tax indicators during mass customer creation. 2. New tax categories were added to the SD configuration, OVK3, over the years, but existing customer records were never backfilled with the required indicators. 3. The project team fails to realize that the business partner validation engine runs a comprehensive check across all sales areas, even those that are rarely used. 4. Internal custom Z programs for customer creation bypass the standard SAP GUI checks that would have normally caught missing tax data. The failure is a result of a cumulative data debt where tax fields were ignored because they did not cause a hard stop in ECC.
Why this is a migration, exclusive failure.
1. ECC upgrades never re-verified the KNVI table for existing records, allowing incomplete tax data to survive for decades. 2. S/4HANA migration requires the creation of the FLCU01 Sales Customer BP role, which triggers a mandatory validation of all tax categories assigned to that sales org. 3. Because CVI is a synchronous event, one single missing tax field will block the entire business partner record from being created. 4. The failure only appears when the technical conversion engine, SUM, or the CVI cockpit attempts to transform the legacy customer into the new BP model. Migration forces a level of tax data discipline that standard ECC operations never required.
Financial and customer impact.
1. Revenue loss occurs if customers are incorrectly charged VAT or GST due to a default taxable indicator assigned during a rushed migration. 2. Significant credit memo backlogs post-go-live as the business attempts to correct thousands of invoices with wrong tax amounts. 3. Delayed cash flow as customers refuse to pay invoices with incorrect tax calculations. 4. Audit failures and legal exposure if the company cannot justify the tax status of its historical customer base. Tax classification errors directly impact the net profitability and compliance status of every sale.
Governance and accountability, RACI model.
Tax data cleansing requires a bridge between SD and the tax department. 1. Accountable. SD functional lead owns the configuration of tax categories and the accuracy of the tax determination logic. 2. Responsible Master Data Management Lead executes the data cleansing and enrichment of the KNVI table. 3. Consulted Corporate Tax Lead provides the legal guidance on which tax indicators apply to specific customer segments. 4. Informed IT Transformation Director monitors the CVI error rate related to tax classification during mock migrations. Accountability ensures that tax data is legally accurate, not just technically complete.
Ownership, who actually fixes it.
Resolving this requires a tax mapping and mass update exercise. 1. SD Functional Lead extracts a matrix of all active sales organizations and their required tax categories from Transaction OVK3. 2. MDM Lead identifies every customer missing a classification for those specific categories and generates a cleansing file. 3. Corporate Tax Lead approves a default logic for inactive or old customers, for example, set to exempt if no sale in 5 years. 4. Data Migration Team uses transaction mass or custom scripts to populate the KNVI table in the legacy ECC system before the sync.
Who gets blamed versus who owns it.
1. Blamed Master Data Team. The business assumes the BP migration corrupted the customer records. 2. Blamed SD Lead users claim the pricing procedure is calculating tax incorrectly. 3. Actual owner, SD Functional Lead responsible for failing to define mandatory tax fields during the initial project blueprint. 4. Root cause, treating tax classification as an optional field during 20 years of ECC data entry. If the tax indicator is wrong, no amount of configuration will produce the right invoice.
How this is actually fixed, the right way by a role.
1. SD Functional Lead mandates a tax readiness audit during the realize phase using report CVI_upgrade_check_resolve. 2. The team implements a data firewall in ECC that blocks the creation of any new customer without a full set of tax classifications. 3. Tax Lead provides an inclusion or exclusion list based on tax residency to ensure only relevant tax categories are migrated. 4. Technical Architect performs a tax determination stress test in S4 HANA to ensure the new BP tax fields are correctly feeding the pricing engine.
What not to do, common wrong fixes.
1. Defaulting all missing classifications to taxable 1 to bypass the CVI check. This will cause massive overbilling and legal disputes. 2. Hard-coding tax classifications into the pricing procedure as a workaround. This destroys the flexibility of the tax engine. 3. Ignoring classifications for ship to parties, assuming only sold to matters. Tax is determined by the destination, not just the buyer. 4. Deleting the tax category from configuration to pass the CVI check without understanding the impact on VAT or GST reporting. Shortcuts in tax data will result in a compliance nightmare that the CFO will have to answer for.
Follow-up 1. Why does S4 HANA CV? I care about tax categories that aren't even used in my country.
Answer: if your sales organization is configured to check for a specific tax category, for example, UTXJ for the US, the CVI engine will demand a value for every customer in that sales org, even if the customer is located in Canada. You must either maintain the classification or refine your configuration to only check relevant categories.
Follow-up 2. What is the best way to mass update tax classifications in ECC?
Answer: the most reliable way is using transaction mass with object KNA1. You can select the tax indicator table and perform a mass fill based on customer account group or country. However, you must ensure your tax mapping logic is approved by the tax department first.
Follow-up 3. Curveball. Can I use external tax engines like Vertex to bypass this issue?
Answer: no. Even with Vertex or Avalara, SAP still requires the tax classification indicator on the customer master to decide whether to call the external engine and what taxability status to send to it. The master data remains the trigger for the entire process.
Exclusive pro tip.
Before starting the realize phase, run a simple count on table KNVI. If the number of entries is significantly lower than the number of entries in table KNA1, you have a major tax data gap. Mandate a tax data enrichment sprint immediately before your first mock migration begins.
Scenario 114. Credit exposure inconsistencies.
In the realize and deploy phases of an ECC to S4 HANA migration, Organizations often encounter massive discrepancies in customer credit exposure. S/4HANA replaces the legacy SD credit management, based on tables S066 and S067, with SAP FSCM credit management, based on the credit management server, and table UKM_item. If the migration of open orders and deliveries is not executed correctly, or if the ECC credit reorganization was not performed before the cutover, the new system will show incorrect credit limits used values, resulting in legitimate orders being blocked on day one.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial risk and supply chain disruption. 2. Phase, realize and deploy. 3. Frequency, extremely common in projects moving to FSCM credit management. 4. Primary ownership, credit manager. 5. Supporting SD functional lead and FICO lead. 6. Business ownership, global credit director. 7. Relevant SAP note, not applicable data governance and cleansing. Refer to SAP Note 2270544 for credit management transition context.
Diagnostic dashboard, symptoms and evidence.
How credit exposure inconsistencies appear during the conversion. 1. Symptom. A customer with a $1 million credit limit and $0 in open orders is suddenly blocked for a $100 purchase in S/4HANA. 2. Red flag reconciliation reports show that the total liability in FSCM table UKM_totals does not match the credit value in ECC transaction FD33. 3. Business impact. Thousands of sales orders are blocked on day one, paralyzing the warehouse and triggering an emergency call to the credit department. 4. Detection. Comparing the output of report UKM_transfer_ items in S/4HANA against the legacy ECC credit tables reveals missing transaction data. 5. Technical proof. Table UKM_item contains duplicate or stale entries for sales orders that were already delivered or canceled in the legacy system. Insight. If your ECC credit data was inconsistent, the S/4HANA migration will amplify those errors into hard stops for your business.
Why this happens, scenario analysis and root cause.
1. In ECC, credit exposure was stored in LIS, Logistics Information System, tables, which frequently became out of sync due to system crashes or unhandled document errors. 2. The migration report UKM_transfer_ items, used to move exposure to FSCM, only works correctly if the legacy ECC system is in a perfectly reconciled state. 3. Failure to run the ECC credit reorganization reports, RVCred 77 and RVCred 88, immediately before the final data snapshot. 4. Misunderstanding the credit horizon. S/4HANA FSCM evaluates exposure differently than ECC, often including long-term future orders that ECC ignored. The failure is a result of treating credit migration as a technical copy rather than a business reconciliation.
Why this is a migration, exclusive failure.
1. ECC upgrades kept the same S066 and S067 structures, so the credit exposure inherited any existing inconsistencies without changing the logic. 2. S/4HANA migration physically deletes the legacy credit tables and builds a new exposure record in the FSCM component. 3. The shift from FIAR credit to FSCM credit requires a one-time data transformation that is notoriously sensitive to document status errors. 4. This failure only surfaces when the new credit check engine is activated in the converted S/4HANA production environment. S/4HANA exposes hidden credit errors that were buried in the legacy LIS tables for years.
Financial and customer impact.
1. Massive shipment delays result in lost revenue and potential service level agreement penalties from customers. 2. Customer frustration peaks when strategic clients are blocked for small amounts due to ghost exposure from years ago. 3. Increased financial risk if the migration underreports exposure, allowing customers to exceed their credit limits without a block. 4. Operational chaos, as the credit team is forced to manually release thousands of orders, while the data team attempts to fix the exposure records. Credit exposure failures directly threaten the cash-to-cash cycle and customer relationships.
Governance and accountability, RACI model.
Reconciling credit requires a partnership between sales, finance, and IT. 1. Accountable credit manager owns the final credit exposure balance and the policy for blocking or releasing orders. 2. Responsible SD functional lead identifies open transactions and ensures they are correctly flagged for credit migration. 3. Consulted FICO lead validates the aged receivables open invoices being passed from FIAR to FSCM. 4. Informed IT transformation director monitors the credit block rate as a critical go-live success metric. Accountability ensures that no order is blocked due to a technical migration error.
Ownership, who actually fixes it.
Resolving this requires a clean snapshot rebuild approach. 1. SD functional lead runs report RVCred 77 in the legacy ECC system to rebuild the LIS credit tables S066/S067 before the final cutover. 2. Credit Manager performs a top 100 customer reconciliation, comparing transaction FD33 ECC to transaction UKM_BP S4 HANA. 3. Data Migration Team executes the credit exposure migration reports in S4 HANA, for example, FINS_MIG_credit_MGMT. 4. Technical Architect utilizes report UKM_check_payment_recip_ for _BP to ensure business partner IDs are correctly linked to the credit exposure.
Who gets blamed versus who owns it.
1. Blamed, SD functional lead the sales team says, you messed up the credit configuration. 2. Blamed, SAP the business assumes the new FSCM engine is too restrictive or inaccurate. 3. Actual owner, credit manager and SD lead responsible for failing to perform a full credit data scrub prior to the cutover. 4. Root cause, migrating inconsistent ghost transactions from legacy ECC tables into the new FSCM model. A credit block in S4 HANA is usually a symptom of a data migration error, not a functional setting.
How this is actually fixed, the right way by a role.
1. Credit manager mandates a credit freeze 48 hours before the cutover to ensure no new transactions disrupt the baseline. 2. The team implements a post-migration rebuild using transaction UKM_recon_ rebuild to force a recalculation of all exposure from open documents. 3. SD functional lead validates the credit segment assignments to ensure they match the legacy credit control areas. 4. The team performs a day one smoke test, creating orders for high-volume customers and verifying that the credit limit used updates in real time without error.
What not to do, common wrong fixes.
1. Assuming that running RVCred 77 in ECC once is enough, you must run it immediately before the final data extraction. 2. Manually overriding credit limits in S4 HANA to bypass blocks. This hides the underlying data inconsistency and creates future risk. 3. Ignoring small discrepancies in exposure during the mock migration. These often point to structural issues in document status that will impact thousands of records. 4. Failing to migrate historical or R data, thinking that only open sales orders matter for credit. Exposure is a total of orders, deliveries, and unpaid invoices. Shortcuts in credit data migration will lead to an operational crisis in the first week of go-live.
Follow-up 1. Why did SAP replace the old SD credit management with FSCM?
Answer: the old system relied on LIS tables which were notoriously unstable and difficult to reconcile. FSCM credit management is a modern, unified engine that works across multiple SAP systems and modules. It provides a real-time, 360-degree view of credit risk, including bank data and external credit ratings, which ECC could not do.
Follow-up 2. What is a ghost exposure and how do I find it?
Answer: ghost exposure occurs when a sales order was canceled or finished, but the credit table, S066, still shows an open balance. You find it by comparing the total of open VBAK and VBAP items against the credit values in FD33. If FD33 is higher, you have ghost exposure that must be purged via RVCred 77.
Follow-up 3. Curveball. Can I keep using my old ECC credit control areas in S4 HANA?
Answer: no. You must map your credit control areas to the new credit segments in FSCM. While they serve a similar purpose, the configuration and master data assignments are different. This mapping is a mandatory step in the explore and realize phases of the migration.
Exclusive pro tip.
1 week before the final cutover, run transaction FCV_order_ check to identify any sales orders with inconsistent credit statuses. Fix these orders in the legacy ECC system before you take the final data snapshot. If an order is inconsistent in ECC, it will become a permanent block in S/4HANA.
Scenario 115. Rebate agreements not prepared for CCM.
In the realize phase of an ECC to S/4HANA migration, organizations often discover that their active rebate agreements in table KONV are incompatible with the new settlement management framework. S/4HANA deprecates classical SD rebates in favor of condition contract management. If legacy agreements are not settled or technically prepared for transition, the migration of open accruals will fail, leading to massive financial variances and the inability to pay out rebates to customers post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial and process transformation impact. 2. Phase, realize and deploy. 3. Frequency, extremely common in consumer products and retail industries. 4. Primary ownership SD functional lead. 5. Supporting FICO lead and data migration lead. 6. Business ownership, sales controller and commercial manager. 7. Relevant SAP note. SAP note 2267377. S4 TWL SD rebate processing replaced by settlement management.
Diagnostic dashboard, symptoms and evidence.
How rebate preparation failures appear during the conversion process. 1. Symptom. The settlement management migration reports return errors stating that the legacy rebate index table VBox is inconsistent. 2. Red flag. Active rebate agreements in ECC have a status of released for settlement but contain unposted manual accruals. 3. Business impact. Significant financial misstatements as rebate accruals are not carried forward into the Universal Journal ACDOCA. 4. Detection. Comparing table KONV ECC with table WCOCO S/4HANA shows that multi-year agreements were not converted into condition contracts. 5. Technical proof. The conversion program WBSIR_MIG_rebate fails because the legacy rebate condition types are not mapped to the new settlement management condition types. Insight. In S/4HANA, the VBox index is deleted. If your rebate data relies on it, the migration will stall.
Why this happens, scenario analysis and root cause.
1. Classical SD rebates utilized a specific index table, VBox, to track billing documents, which SAP has physically removed in S/4HANA to simplify the data model. 2. Settlement management, CCM, uses a contract-based approach which requires a much higher level of data integrity than the legacy agreement-based approach. 3. Organizations fail to perform a final settlement of expired ECC rebates, leaving millions of redundant records in the migration scope. 4. Lack of alignment between the SD and FI teams regarding how accruals should be represented in the new condition contract architecture. The failure is a result of moving from a statistic-based rebate model to a document-based settlement model.
Why this is a migration, exclusive failure.
1. ECC upgrades allowed legacy rebates to continue functioning across versions without any architectural changes. 2. S/4HANA migration is a hard stop for classical rebates. You cannot create or settle old agreements in the new system. 3. The transformation of KONV records into WCOCO records is a one-time technical event that only occurs during the S/4HANA migration lifecycle. 4. This failure only surfaces when the system transition tool attempts to bridge the gap between the old SDBIL engine and the new LOAB engine. S/4HANA forces a mandatory migration of rebates that no ECC upgrade ever required.
Financial and customer impact.
1. Inaccurate financial accruals lead to profit and loss variances that can trigger internal and external audit investigations. 2. Delayed payments to customers for earned rebates result in lost market share and damaged commercial relationships. 3. Operational paralysis in the sales department, as controllers must manually calculate rebates in Excel because the system migration failed. 4. Increased risk of double payment if accruals are migrated incorrectly and then manually adjusted by users post-go live. Rebate failures directly impact the net-to-net margin and the company's bottom line.
Governance and accountability, RACI model.
Rebate migration requires a precise handover between SD and finance. 1. Accountable, SD functional lead owns the mapping of legacy agreements to the new condition contract management, CCM scenarios. 2. Responsible data migration lead executes the technical conversion programs and reconciles the record counts. 3. Consulted, sales controller validates the accrual balances and signs off on the settlement accuracy. 4. Informed, IT transformation director monitors the impact of rebate migration on the total cutover timeline. Accountability ensures that the commercial promise to pay is not lost during the technical migration.
Ownership, who actually fixes it.
Resolving this requires a clean close convert methodology. 1. SD functional lead identifies all active rebate agreements and categorizes them into to be settled in ECC or to be migrated to S4 HANA. 2. Basis team runs the VBox reorganization reports, transaction VBOF, in the legacy system to ensure the index is 100% accurate. 3. Sales controller performs a final payout for all agreements expiring before the go-live date to minimize the migration footprint. 4. Data migration team utilizes the settlement management migration workbench to transform the remaining KONV records into condition contracts.
Who gets blamed versus who owns it.
1. Blamed, SD lead the business assumes the rebate config was lost during the migration. 2. Blamed, SAP the users claim S4 HANA is too complex because they cannot find transaction VBO1. 3. Actual owner, SD functional lead and sales controller responsible for the failure to cleanse the rebate portfolio in ECC. 4. Root cause, maintaining thousands of expired and unsettled rebate agreements in the legacy production system for years. Rebate migration errors are usually a symptom of poor commercial data hygiene.
How this is actually fixed, the right way by a role.
1. SD functional lead mandates a hard close of all rebate agreements in ECC that are more than 2 years old. 2. The team implements the new settlement management configuration in S4 HANA, contract types and settlement types, during the realize phase. 3. Data migration team uses report WBSIR_MIG_rebate to migrate open accrual balances directly into the new condition contracts. 4. Sales controller executes a rebate parallel run, comparing the settlement results of a sample agreement in both ECC and S4 HANA.
What not to do, common wrong fixes.
1. Attempting to bring over legacy KONV agreements without converting them to WCOCO contracts. They will be functionally dead in S4 HANA. 2. Manually inventing accrual balances in S4 HANA via GL postings to bypass the migration errors. This destroys the audit trail. 3. Ignoring the pricing condition mapping. If the rebate condition in ECC is not mapped to the contract condition in S4, no accruals will post. 4. Waiting until the final cutover to test the settlement run, transaction WB2R_SC, for migrated contracts. Shortcuts in rebate migration will result in a financial reconciliation nightmare at your first month-end close.
Follow-up 1. Can I still use transaction VBO1 in S4 HANA?
Answer: no. Transaction VBO1 is completely blocked in S4 HANA. You must use the new condition contract transactions, WCOCO. While the business logic of payouts based on sales remains, the technical framework and the user interface are fundamentally different.
Follow-up 2. What happens to the historical rebate index, VBox, during the migration?
Answer: in S4 HANA, SAP has replaced the VBox index with a much more efficient on-the-fly calculation based on the main document tables. During the migration, the system uses the VBox data one last time to calculate the starting accrual balance, and then the table is physically deleted from the HANA database.
Follow-up 3. Curveball. Is settlement management only for rebates?
Answer: not at all. S4 HANA Settlement Management is a unified framework that replaces SD rebates, MM purchasing rebates, and even complex commission models. It is a much more powerful engine that allows for delta accruals and multidimensional settlement rules that were impossible in ECC.
Exclusive pro tip.
Before the realize phase ends, execute the report RC_rebate_re_inc in your ECC production system. This tool identifies documents that are missing from the rebate index. Fixing these inconsistencies in ECC is the only way to ensure your S/4HANA condition contracts start with a golden accrual balance.
Scenario 116. Foreign trade commodity code migration failures.
In the explore and realize phases of an ECC to S/4HANA migration, organizations often fail to migrate commodity codes and harmonize system HS codes correctly. S/4HANA deprecates the legacy foreign trade components, tables EIKP and EIPO, and replaces them with international trade. If the commodity codes stored in the material master, table MRC, are not transformed into the new classification framework, export deliveries will be blocked, and intrastat reporting will fail on day one.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium compliance and logistics impact. 2. Phase, explore and realize. 3. Frequency, common in manufacturing and global trading companies. 4. Primary ownership, SD functional lead. 5. Supporting MDM lead and global trade lead. 6. Business ownership, compliance manager and logistics director. 7. Relevant SAP note. SAP note 2267310. S4TWL SDFT foreign trade replaced by international trade.
Diagnostic dashboard, symptoms and evidence.
How commodity code migration failures manifest in the new system. 1. Symptom, deliveries to international destinations are automatically placed on an export block and cannot be processed for PGI. 2. Red flag, the commodity code field in the material master MM03 appears empty or contains obsolete values after the migration. 3. Business impact, legal non-compliance for international shipments, resulting in customs delays and potential fines for incorrect reporting. 4. Detection, checking table/SAP/SLL/MRITC in S/4HANA reveals 0 entries despite thousands of materials being migrated. 5. Technical proof, intrastat reports, transaction ENRA, return empty results or errors regarding missing material classification. Insight in ECC, commodity codes were attributes of the material. In S/4HANA, they are classifications within a trade framework.
Why this happens, scenario analysis and root cause.
1. S/4HANA moves the storage of commodity codes from the material master table, MRC, to a dedicated international trade classification table. 2. Legacy ECC data often contained non-standard commodity codes that do not match the official government numbering schemes enforced by S/4HANA. 3. Failure to realize that commodity codes in S/4HANA are time-dependent, meaning they must have a valid from and to date assigned during migration. 4. Project teams assume that foreign trade, SDFT, is part of the core SD module, but it has been physically removed and replaced by a new submodule. The failure is a result of a major architectural shift in how SAP handles global trade compliance.
Why this is a migration, exclusive failure.
1. ECC upgrades kept the foreign trade data in MRC and T604, ensuring that no data was ever lost or moved during an upgrade. 2. S/4HANA brownfield conversion involves a mandatory decommissioning of the foreign trade tables EIKP and EIPO. 3. The migration of commodity codes requires a specific technical report, for example, /SAPSLL/Maric_migration, which is unique to the S/4HANA transition. 4. This failure only surfaces when the organization attempts to perform an export transaction in the newly converted environment. Migration turns a simple master data field into a complex classification object.
Financial and customer impact.
1. Blocked export shipments lead to missed revenue targets and significant backlog management costs. 2. Increased customs audit risk if the migrated commodity codes do not align with the latest regional tariff schedules. 3. Customer service delays as logistics teams must manually reclassify thousands of materials to clear shipping blocks. 4. Financial penalties for inaccurate intrastat reporting during the first month post-go-live. Commodity code failures directly block the order-to-cash pipeline for global businesses.
Governance and accountability, RACI model.
Trade compliance migration requires a bridge between SD and global trade teams. 1. Accountable, SD functional lead owns the operational logistics flow and the removal of export blocks. 2. Responsible, MDM lead executes the extraction, cleansing, and load of commodity code classifications. 3. Consulted, global trade lead provides the official tariff numbers and validates the legal compliance of the data. 4. Informed, logistics director monitors the shipping volume to ensure no international delays occur after cutover. Accountability ensures that global trade is not treated as a technical afterthought.
Ownership, who actually fixes it.
Resolving this requires a classification-centric migration strategy. 1. Global Trade Lead provides the master commodity code list with valid numbering schemes for each country. 2. MDM Lead extracts legacy codes from MRC and T604 and maps them to the new S/4HANA numbering schemes. 3. Technical team runs the International Trade Migration Cockpit to populate the new classification tables. 4. SD Functional Lead configures the international trade settings in S/4HANA to ensure the system checks the new tables during delivery creation.
Who gets blamed versus who owns it.
1. Blamed, MDM team. The business assumes the material master migration was corrupted. 2. Blamed, SAP users claim the export control logic is broken in the new system. 3. Actual owner, SD functional lead and MDM lead responsible for the failure to adopt the new international trade data model. 4. Root cause, treating commodity codes as a text field rather than a regulated classification. Trade data failures are usually due to missed architectural changes, not bad data entry.
How this is actually fixed, the right way by a role.
1. MDM lead mandates a data enrichment sprint to assign validity dates to all migrated commodity codes. 2. The team implements numbering scheme configuration, transaction/SAP/SLL/menu_legal, to define how codes are structured by country. 3. Developers refactor any legacy foreign trade user exits to use the new international trade baddies, for example, baddie_SDRQ_main. 4. The team executes an export simulation test, creating deliveries for all major destination countries to verify the trade blocks are correctly released.
What not to do, common wrong fixes.
1. Manually typing commodity codes into the material master in S/4HANA. This often bypasses the required time dependency logic. 2. Ignoring intrastat errors in the sandbox, assuming they are purely financial and will not block logistics. 3. Using legacy T604 table lookups in custom ABAP code. This table is obsolete and will return empty results in S/4HANA. 4. Assuming that if you have SAP GTS, Global Trade Services, you do not need to migrate commodity codes to S/4HANA. Shortcuts in trade data migration will lead to a supply chain halt at the border.
Follow-up 1. Where do I find the commodity code in the S/4HANA Material Master?
Answer: it is no longer a simple field on the Foreign Trade Export Data tab. Instead, you must go to the Sales, General, or Plant tab and look for the International Trade Classification button. This opens a separate screen where you assign codes to a specific numbering scheme and validity period.
Follow-up 2. What is a numbering scheme and why do I need it?
Answer: a numbering scheme defines the structure and length of the commodity code for a specific regulatory body. For example, EU Intrastat or US Schedule B. S/4HANA requires this scheme so it can validate that the code entered matches the legal requirements of the country of origin or destination.
Follow-up 3. Curveball. Can I use S/4HANA International Trade for embargo checks?
Answer: yes. S/4HANA International Trade includes basic embargo and legal control checks. However, if your business requires sanctioned party list screening or complex pro forma invoice management, you should continue to use SAP GTS, which integrates deeply with the S/4HANA SD module.
Exclusive pro tip.
Before migrating, download the official government tariff schedule for your primary export countries. Use this list to validate your legacy ECC MRC STAWN values. If the legacy code is no longer in the government list, change it in ECC before the migration to avoid invalid code errors in S/4HANA.
Scenario 117. GST India CIN data migration failures.
In the realize phase of an ECC to S/4HANA migration for India-based entities, organizations often face critical failures in migrating country India now. CIN data. Legacy GST data, such as GST registration numbers and tax classification codes, was stored in specific localization tables like J_1IMO cust. In S/4HANA, this data must be migrated to the Business Partner Tax Registration Framework. If the mapping between legacy CIN tables and the new BP tax categories is not precisely defined, tax calculation in sales orders will fail, and GST-compliant invoicing will be impossible.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high localization and legal compliance impact. 2. Phase, realize. 3. Frequency, common in all India-specific S/4HANA conversions. 4. Primary ownership, SD and localization lead. 5. Supporting master data management lead and FICO lead. 6. Business ownership, India finance director. 7. Relevant SAP note. SAP note 2405502 and SAP note 2285611. GST India simplifications and master data.
Diagnostic dashboard, symptoms and evidence.
How GST India migration failures appear during testing. 1. Symptom, sales orders for Indian customers fail to calculate SGST, CGST, or IGST, leaving tax amounts at 0. 2. Red flag, the tax number 3 field in the business partner BUT000 is empty or contains formatted strings that the GST engine cannot parse. 3. Business impact, inability to generate legally valid GST tax invoices, GSTR1, resulting in heavy government penalties and blocked shipments. 4. Detection, comparing table J_1IMO cust in ECC with table DFKKO tax num in S/4HANA shows a discrepancy in record counts. 5. Technical proof, runtime error in the pricing engine, condition type JOIG or JOSG, stating that the GST registration status of the partner is unknown. Insight, India GST is a hard stop compliance requirement. If the master data does not move, the business does not ship.
Why this happens, scenario analysis and root cause.
1. Legacy India localization, CIN, relied on secondary tables that were outside the standard KNA1 customer master flow. 2. S/4HANA consolidates all global tax registrations into a single BP tax number framework using specific tax categories like IN1, IN2, and IN3. 3. Project teams often use standard CVI mapping, but forget to configure the India-specific tax category mappings required for the GST engine. 4. Legacy data in J_1IMO cust often contains expired GST IDs or duplicate PAN numbers that violate S/4HANA's strict tax validation rules. The failure is a result of treating localization data as an extra field rather than a core BP attribute.
Why this is a migration, exclusive failure.
1. ECC upgrades kept localization data in the J_1I tables, requiring 0 transformation for the tax engine to continue working. 2. S/4HANA migration forces the localization to core transition, where data must physically move into the DFKKO tax num table. 3. Standard SAP CVI tools do not automatically migrate CIN tables unless specific localization-aware SAP notes are applied to the ECC system. 4. This failure only surfaces during the first India scope mock migration when the pricing engine fails to find a valid GST ID. Migration forces a structural relocation of India-specific data that ECC never required.
Financial and customer impact.
1. Massive revenue risk due to the inability to collect GST, which must then be paid by the company to the government from its own margins. 2. Customer disputes arise when clients cannot claim input tax credit because the invoice was generated with an incorrect or missing GST ID. 3. Supply chain paralysis, as e-way bills cannot be generated without valid GST master data on the delivery document. 4. High operational costs to manually correct thousands of tax registration entries in the business partner records. India GST errors directly impact both the corporate tax liability and the customer's cash flow.
Governance and accountability, RACI model.
Localization migration requires a partnership between SD, Finance, and the India Business Unit. 1. Accountable. India Finance Director owns the legal compliance of the GST data and signs off on the tax invoice accuracy. 2. Responsible. SD and Localization Lead defines the mapping from legacy CIN tables to S4 HANA BP tax categories. 3. Consulted. Master Data Management Lead executes the data extraction and load into the new tax registration structures. 4. Informed. IT Transformation Director monitors the India localization workstream for any go-live blockers. Accountability ensures that localization is not treated as a peripheral technical task.
Ownership, who actually fixes it.
Resolving this requires a localization-specific data transformation plan. 1. SD and Localization Lead identifies all active tax categories in transaction OVK3 and maps them to the Indian GST law. 2. MDM Lead extracts data from J_1IMO cust and standardizes the GST ID formats into a 15-character alphanumeric string. 3. ABAP Development Team applies SAP Note 24055002 to ensure the CVI cockpit recognizes the India localization fields. 4. India Finance Team performs a GST R1 simulation in the sandbox to verify that the migrated data produces a valid tax return.
Who gets blamed versus who owns it.
1. Blamed. Master Data Team. The business assumes the GST numbers were lost during the load. 2. Blamed. SD Functional Lead. The users claim the pricing procedure is not calculating tax. 3. Actual Owner. SD and Localization Lead responsible for failing to define the BP tax category mapping during the explore phase. 4. Root cause. Underestimating the complexity of moving from legacy CIN tables to the unified S4 HANA BP framework. The failure is in the architectural mapping, not the data load itself.
How this is actually fixed, the right way by a role.
1. SD and Localization Lead mandates the configuration of tax categories. IN1 for GST, IN2 for PAN, IN3 for TAN in S4 HANA. 2. The team implements the CVI_ mapping BADI to ensure that data from J_1IMO cust is correctly routed to the BP tax number table. 3. MDM Lead executes a duplicate PAN check in ECC, as S4 HANA will block the creation of multiple BPs with the same PAN number. 4. Technical Architect performs a tax determination test using transaction VF01 to ensure the GST registration is correctly fetched from the BP master.
What not to do, common wrong fixes.
1. Ignoring the J_1I tables and assuming the GST numbers are already in the KNA1STCD3 field. In many older ECC systems, they are not. 2. Manually entering GST IDs in S4 HANA after the migration. This is impossible for large volumes and will delay the first billing run. 3. Disabling tax duplicate checks in the BP configuration to bypass PAN errors. This will cause major legal issues during tax audits. 4. Failing to apply SAP Note 22856111 before the CV synchronization begins. Shortcuts in GST localization will lead to a complete operational shutdown for the Indian business units.
Follow-up 1. Why is tax category IN1 so critical for India S4 HANA?
Answer. In S4 HANA, the GST engine no longer looks at the old CIN tables. It specifically looks for a tax number assigned to tax category IN1 in the business partner record. If this specific category is missing, the system treats the customer as unregistered, leading to incorrect tax calculations or billing blocks.
Follow-up 2. What happens to the legacy CIN tables, like J_1IMO cust, after migration?
Answer. These tables become obsolete and are no longer updated by the S4 HANA system. While the data might still exist in the database for a period of time, it is dead data that is ignored by the standard SD and FICO engines. All new registration data must be maintained via the BP transaction.
Follow-up 3, Curveball. Can I use the S/4HANA migration to consolidate multiple GST IDs for one customer?
Answer: yes. This is a primary benefit of the BP model. In ECC, you might have created separate customer IDs for each state registration. In S/4HANA, you can have one business partner with multiple tax registration entries, each linked to a different state or region, simplifying your master data landscape.
Exclusive pro tip.
Before starting the realize phase, run report J_1 IGST_partner_cleanup, if available, or a custom script in ECC to reconcile J_1 IMO_cust against KNA1. Any GST ID that does not have a 100% match with the customer's PAN prefix must be corrected in ECC first, or the S/4HANA tax engine will throw an invalid identification error.
Scenario 118. Foreign trade fields obsolete but not cleansed.
In the realize phase of an ECC to S/4HANA migration, organizations often encounter ghost data in their SD documents. S/4HANA deprecates the legacy foreign trade SDFT component and its associated tables, EIKP and EIPO. While these fields physically remain in the sales and delivery tables for backward compatibility, the underlying business logic is moved to international trade. If legacy data in these fields is not cleansed, or if custom Z reports continue to read them, the system will display stale or conflicting export information, leading to customs errors and shipping delays.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium data integrity and reporting impact. 2. Phase, realize and post-go live. 3. Frequency, extremely common in global companies with 10+ years of ECC history. 4. Primary ownership, data migration lead. 5. Supporting SD functional lead and ABAP custom code remediation lead. 6. Business ownership, global logistics director. 7. Relevant SAP note. SAP note 2267310. S4 TWL foreign trade replaced by international trade.
Diagnostic dashboard, symptoms and evidence.
How obsolete foreign trade fields manifest after conversion. 1. Symptom. A custom export invoice printout shows a commodity code that is different from the one maintained in the material master. 2. Red flag, legacy custom reports are still joining tables VBAK and EIKP to determine the country of origin for international sales. 3. Business impact. Customs documents are rejected by port authorities because the stale data from the EIPO table contradicts the current trade classification. 4. Detection. SQL queries on tables EIKP or EIPO in S/4HANA return data for newly created documents, indicating that legacy code is incorrectly writing to dead tables. 5. Technical proof. The ATC check flags access to the V_EIKP compatibility view as a performance and architectural warning. Insight. In S/4HANA, EIKP and EIPO are read-only snapshots of the past. They should never be used for current business logic.
Why this happens, scenario analysis and root cause.
1. The Brownfield Conversion Tool, SUM, transforms data into new tables but does not empty the legacy tables to prevent breaking unremediate custom code. 2. Developers assume that because the EIKP or EIPO fields still contain data, they are still the source of truth for export compliance. 3. S/4HANA International Trade uses a completely different set of tables, starting with /SAPSLL/ that legacy Z reports are not aware of. 4. Project teams fail to communicate to the business that foreign trade is not just a UI change, but a total database engine replacement. The failure is a result of allowing legacy data debt to coexist with modern digital core logic.
Why this is a migration, exclusive failure.
1. In ECC upgrades, EIKP and EIPO were the only tables for foreign trade, so the source of truth never moved. 2. S/4HANA migration physically replaces the SDFT submodule with a new application logic that ignores the old tables. 3. The conversion of EIKP or EIPO data into the new international trade tables is a one-time technical event that can leave discrepancies if not audited. 4. This failure only surfaces when the organization attempts to run a business process that relies on both legacy Z code and new S/4HANA logic. Migration creates a parallel universe of trade data that standard upgrades never had.
Financial and customer impact.
1. Increased customs clearance fees and demurrage charges due to conflicting data on shipping documentation. 2. Revenue recognition is delayed when international deliveries are held at the border because the trade classification is out of sync. 3. Legal risks and potential blacklisting by trade authorities if the company repeatedly submits incorrect export declarations. 4. Inaccurate duty drawback claims because the financial reports are pulling commodity codes from obsolete legacy tables. Stale trade data directly threatens the company's known shipper status and global export compliance.
Governance and accountability, RACI model.
Trade data governance requires coordination between the data and logistics teams. 1. Accountable data migration lead owns the successful transformation of legacy trade data and the zero data status of dead fields. 2. Responsible ABAP custom code remediation lead identifies and refactors every Z report that reads from EIKP and EIPO. 3. Consulted SD functional lead provides the business rules for which export documents must be searchable post-migration. 4. Informed Global Logistics Director monitors the shipping block rate in the first month post-go-live. Accountability ensures that legacy ghost data is purged or neutralized before the business goes live.
Ownership, who actually fixes it.
Resolving this requires a purge and refactor strategy. 1. Data migration lead mandates that all EIKP and EIPO fields be ignored during the go-live reconciliation process. 2. ABAP development team replaces legacy table lookups with calls to the new international trade APIs and CDS views. 3. SD functional lead ensures that any custom fields in EIKP or EIPO are moved to the international trade classification extensibility layer. 4. Compliance manager validates that the pro forma invoice prints data only from the new S/4HANA/SAP SLL/tables.
Who gets blamed versus who owns it.
1. Blamed. ABAP developers the business assumes the developers used the wrong field in a report. 2. Blamed. SAP the users claim S/4HANA is confusing because the same data appears differently in different screens. 3. Actual owner, data migration lead responsible for the failure to neutralize the legacy foreign trade tables. 4. Root cause, allowing obsolete data to remain active in the search paths of custom business logic. Dead tables tell no tales, unless you leave them in your reports.
How this is actually fixed, the right way by a role.
1. Data migration lead mandates a technical cleansing of EIKP and EIPO in the target system post-conversion, where supported. 2. ABAP custom code remediation lead enforces a strict ban on V_EIKP and V_EIPO compatibility views for any new developments. 3. The team implements a data firewall that prevents custom code from writing back to the legacy foreign trade fields. 4. Functional leads execute a data discrepancy report that compares the EIPO commodity code with the /SAPSLL/MRITC classification and flags mismatches.
What not to do, common wrong fixes.
1. Keeping legacy foreign trade reports as is and assuming the compatibility views will handle the business logic. They will not. 2. Syncing data back from S/4HANA International Trade to the legacy EIKP tables. This is a massive technical waste and creates confusion. 3. Ignoring empty fields in the new trade screens, assuming the data is still in the old place. The old place is now dead. 4. Using the same Z program for export documentation that was used in ECC for 20 years without a 100% code rewrite. Shortcuts in trade data cleansing will result in your products being stuck at the border on Monday morning.
Follow-up 1. If SAP note 22673110 says foreign trade is gone, why can I still see the tables EIKP and EIPO in S/4HANA?
Answer: the tables remain in the data dictionary, DDIC, so that the system does not immediately crash when legacy code runs. However, Standard S/4HANA transactions no longer read from or write to these tables. They are ghost tables that only exist to provide a safety net for unremediated custom code.
Follow-up 2. What is the risk of using the V_EIKP compatibility view?
Answer: performance. Compatibility views are virtual. They have no indexes and require the HANA database to perform complex joins at runtime to simulate the old table structure. If you use them in a high-volume shipping report, the report will likely time out and block the logistics wave.
Follow-up 3. Curveball. How do I find the replacement for a specific EIPO field in S4HANA?
Answer: you must use the S/4HANA International Trade CDS views. For example, commodity codes are now managed through the CDS view I_Intel TRD product classification. You should point all your new Z reports to these standard S/4HANA views rather than legacy tables.
Exclusive pro tip.
Perform a global code search for the string EIKP and EIPO in the realize phase. Mandate that every hit be refactored to use the new I_Intel TRD CDS views. Never go live with a custom report that depends on a deprecated foreign trade table, because that data will be static and incorrect from day one.
Scenario 119. Open revenue contract migration errors.
In the realize and deploy phases of an ECC to S/4HANA migration, organizations often encounter critical failures when moving open revenue-relevant sales orders. S/4HANA deprecates legacy SD revenue recognition, tables VBREK and VBREV, in favor of SAP revenue accounting and reporting, or RR. If the migration of open contracts does not precisely align the inception-to-date revenue already recognized in ECC with the new performance obligation logic in S/4HANA, the system will trigger incorrect double postings or fail to recognize remaining revenue, leading to material financial misstatements.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial compliance and revenue integrity risk. 2. Phase, realize and deploy. 3. Frequency, common in industries with service contracts or milestone billing. 4. Primary ownership, SD and FICO lead. 5. Supporting data migration lead and revenue accountant. 6. Business ownership, corporate controller and CFO. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue recognition simplifications.
Diagnostic dashboard, symptoms and evidence.
How open revenue contract migration failures appear during conversion. 1. Symptom: sales orders migrated to S/4HANA show a revenue accounting error in the document header and fail to create a revenue accounting item or ROI. 2. Red flag: the inception-to-date revenue value in SAP ROR does not match the historical recognized revenue in legacy ECC table VBREV. 3. Business impact: inability to close the first month end in S/4HANA due to massive unreconciled balances in deferred revenue accounts. 4. Detection: error logs in transaction FRR_monitor show contract could not be created due to missing fulfillment events for migrated orders. 5. Technical proof: table FRR_D_ posting shows duplicate revenue catch-up entries for periods that were already closed and audited in ECC. Insight: revenue migration is not a data copy. It is a financial cut and paste that must be balanced to the cent.
Why this happens, scenario analysis and root cause.
1. Legacy SD revenue recognition was account-based, while SAP ROR is contract-based, requiring a fundamental shift in data granularity. 2. Failure to accurately calculate and freeze the recognized revenue in ECC at the exact moment of the cutover snapshot. 3. Inconsistent mapping of SD item categories to performance obligations or POBs in the SAP ROR engine. 4. Underestimation of the catch-up logic in SAP ROR, which attempts to reevaluate the entire life of the contract based on S/4HANA rules. The failure is a result of moving from a simple GL posting model to a complex contract liability model.
Why this is a migration, exclusive failure.
1. In ECC upgrades, the VBREK and VBREV tables remained active, and existing revenue schedules were never recalculated. 2. S/4HANA migration physically deactivates the old revenue engine, making it impossible to continue using legacy schedules. 3. The inception-to-date migration process is a unique, one-time transformation event required only during the S/4HANA transition. 4. This failure only surfaces when the system attempts its first revenue posting run, transaction, FAR_REV_post, in the new environment. Migration forces a revaluation of every open dollar of revenue in the company.
Financial and customer impact.
1. Material misstatements in the quarterly financial reports, leading to potential regulatory investigations and loss of investor confidence. 2. Delayed revenue recognition directly impacts the corporate P&L and can cause the company to miss earnings targets. 3. Operational overhead increases as the revenue accounting team is forced into months of manual reconciliation in Excel. 4. Audit costs skyrocket as external auditors require 100% testing of the migrated revenue contract population. Revenue migration errors are the highest-risk financial incidents in an S/4HANA program.
Governance and accountability, RACI model.
Revenue contract migration requires deep integration between sales and finance. 1. Accountable, FICO lead owns the final financial accuracy of the revenue postings and the IFRS 15 compliance sign-off. 2. Responsible, SD functional lead identifies all open revenue-relevant documents and ensures the SD attributes feed the RI monitor correctly. 3. Consulted, revenue accountant validates the inception-to-date recognized revenue balances for each contract. 4. Informed, CFO monitors the financial risk and the impact on the public-facing financial statements. Accountability ensures that the technical migration does not override accounting principles.
Ownership, who actually fixes it.
Resolving this requires a technical and financial snapshot and load strategy. 1. FICO lead defines the revenue transition method, cumulative or retrospective, based on the accounting policy. 2. SD functional lead executes the report to create revenue accounting items for all open sales orders. 3. Data migration team loads the recognized revenue history into the RAR staging tables to establish the inception-to-date baseline. 4. Revenue accountant performs a cent-by-cent reconciliation between the ECC VB/REV table and the S/4HANA FRR_D_contract table.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead the business assumes the sales order configuration is causing the revenue error. 2. Blamed. SAP users claim the RAR engine is too complex and produces wrong numbers. 3. Actual owner, SD and FICO lead jointly responsible for the failure to define the transition baseline data. 4. Root cause, failing to align the historical recognized revenue with the new contract-based logic during the realize phase. Revenue errors are architectural mapping failures, not simple data entry mistakes.
How this is actually fixed, the way by a role.
1. FICO lead mandates a revenue freeze in ECC, ensuring no new postings happen after the final data snapshot is taken. 2. The team implements a custom migration wrapper to populate the legacy recognized revenue fields in the RAR load. 3. ABAP development team implements baddies in the SD-RAR interface to handle complex contract modifications that occurred in ECC history. 4. Functional teams execute a financial dry run, posting revenue for 100% of migrated contracts in a non-production environment to verify accuracy.
What not to do, common wrong fixes.
1. Migrating open orders without their inception-to-date revenue history. This will cause the system to recognize all historical revenue again on day 1. 2. Manually adjusting the deferred revenue GL account without updating the corresponding SAP RR contract. This creates a permanent subledger variance. 3. Ignoring fully invoiced orders that still have recognized revenue pending. If the revenue is not finished, the contract must migrate. 4. Assuming that legacy SD revenue recognition settings, VKOA, will automatically work with the new RAR logic. Shortcuts in revenue migration will result in a financial audit failure and a possible restatement of earnings.
Follow-up 1. What is inception-to-date revenue, and why is it the key to migration?
Answer: inception-to-date revenue is the total amount of revenue recognized for a contract from its start date until the cutover day. S/4HANA needs this number as a starting point so it can calculate the remaining revenue correctly. If this number is missing or wrong, the system will either miss revenue or double post it.
Follow-up 2. Can I migrate revenue data using the standard S/4HANA migration cockpit?
Answer: yes, but with caution. While the cockpit can load the sales orders, the integration into SAP RER requires a separate set of technical steps and specialized migration reports provided by SAP specifically for revenue accounting transition.
Follow-up 3. Curveball. What if I do not use SAP RER and move to event-based revenue recognition instead?
Answer: event-based revenue recognition is simpler and integrated into the Universal Journal, but the migration challenge remains the same. You must still tell the system how much revenue was already recognized in ECC to avoid duplicating the postings during the event in S/4HANA.
Exclusive pro tip.
Before the final cutover, run the revenue comparison report between table VBREV and the general ledger in ECC. If these do not match 100% in the legacy system, they will never match in S/4HANA. Fix your legacy variances first to ensure a golden baseline for your migration.
Scenario 120. Revenue reconciliation baseline not established.
In the realize phase of an ECC to S/4HANA migration, organizations often fail to establish a formal reconciliation baseline for revenue. This baseline represents the audited financial state of sales revenue, deferred revenue, and unbilled receivables in the legacy ECC system at the point of migration. Without this documented starting point, the project team cannot prove to auditors that the revenue recognized in S/4HANA post-go-live is a true continuation of the historical financial records, leading to a loss of financial integrity.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial governance and audit impact. 2. Phase, explore and realize. 3. Frequency, common in large-scale conversions with decentralized finance teams. 4. Primary ownership, FICO lead and revenue accountant. 5. Supporting SD functional lead and data migration lead. 6. Business ownership, corporate controller. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue recognition transition.
Diagnostic dashboard, symptoms and evidence.
How the lack of a revenue baseline manifests during the project. 1. Symptom: during testing, the finance team asks, is this number correct? And the IT team cannot provide an audited ECC report to compare against. 2. Red flag: the data migration strategy mentions sales order counts but contains no mention of dollar value reconciliation at the subledger level. 3. Business impact: external auditors refuse to sign off on the first quarterly report post-migration due to insufficient evidence of data migration accuracy. 4. Detection: the project reconciliation report only shows record counts, for example, 500 orders migrated, rather than financial balances. 5. Technical proof: mismatches between the legacy GL account balances for revenue and the new S/4HANA Universal Journal postings. Insight: if you cannot prove where you started in ECC, you cannot prove you arrived correctly in S/4HANA.
Why this happens, scenario analysis and root cause.
1. Project teams treat migration as a technical IT load of records rather than a financial cutover of value. 2. Failure to involve the internal audit and compliance teams early in the explore phase to define the required reconciliation evidence. 3. The complexity of inception-to-date revenue logic makes it difficult to produce a single, simple report in the legacy ECC system. 4. Assumptions that standard SAP conversion logs, which show successful record moves, are sufficient for financial auditing. The failure is a result of prioritizing technical success over financial compliance.
Why this is a migration, exclusive failure.
1. Standard ECC upgrades do not move data between different financial subledgers, so the baseline never changes. 2. S/4HANA migration involves moving revenue data from SD tables, VBREV, to RER tables or the Universal Journal ACDOCA, which is a point-to-point value transfer. 3. The legal requirement to prove continuity of revenue during a system change is a unique compliance hurdle of the S/4HANA migration. 4. This failure only surfaces when the first financial audit occurs after the production system has been live for 1 quarter. Migration creates a break in the chain that only a formal baseline can bridge.
Financial and customer impact.
1. Qualified audit opinions or a failure to file financial results on time, leading to severe regulatory and stock market penalties. 2. Inaccurate reporting of contract assets and liabilities on the balance sheet, affecting the company's valuation and credit rating. 3. High cost of forensic accounting post-go-live to reconstruct the migration history and satisfy auditor demands. 4. Loss of management confidence as the finance department cannot explain variances in revenue growth versus the previous year. A missing revenue baseline is a red flag for any professional financial auditor.
Governance and accountability, RACI model.
Establishing a baseline is a collaborative effort between finance and the data team. 1. Accountable corporate controller owns the final sign-off on the financial migration accuracy and the audited baseline. 2. Responsible revenue accountant identifies the required ECC reports and extracts the audited balances for all revenue accounts. 3. Consulted data migration lead ensures that the migration tools capture the data required to reconcile back to the baseline. 4. Informed internal audit lead validates the reconciliation methodology before the final production cutover. Accountability ensures that financial truth is the primary goal of the migration.
Ownership, who actually fixes it.
Resolving this requires a value-based reconciliation framework. 1. Corporate controller mandates a revenue baseline document that lists every open revenue contract ID and its ECC dollar value. 2. Revenue accountant executes ECC transaction VF44 or RAR reports to capture the recognized to-date and deferred values. 3. Data migration lead implements total value checks in the migration cockpit to compare the SUM of ECC source values against S/4HANA target values. 4. Internal audit team performs a spot check audit on high-value contracts during each mock migration cycle.
Who gets blamed versus who owns it.
1. Blamed. IT project manager executives assume the project failed to provide the necessary reporting tools. 2. Blamed. Data migration team auditors claim the data load was not properly verified. 3. Actual owner, corporate controller and FICO lead responsible for the failure to define the reconciliation standard during the explore phase. 4. Root cause, treating the revenue migration as a technical object rather than a financial audit item. Audit failures are governance gaps, not technical glitches.
How this is actually fixed, the way by a role.
1. Corporate controller establishes a reconciliation policy that requires a signed-off baseline 30 days before go-live. 2. The team implements automatic value match scripts that compare table VBREV ECC to table FRR_D_ contract S/4HANA after every load. 3. Revenue accountant creates a transition ledger that tracks the movement of every cent from the legacy subledger to the new universal journal. 4. Functional leads execute baseline drills during UAT, where auditors are invited to pick an order and trace its value from ECC to S/4HANA.
What not to do, common wrong fixes.
1. Waiting until after go-live to generate the ECC baseline reports. If the data changes during the cutover, your baseline is invalid. 2. Using approximate or rounded numbers for reconciliation, auditors will reject any variance that cannot be explained down to the cent. 3. Assuming that a balanced trial balance in FIGL means the revenue subledger migration was successful. 4. Failing to document the in-flight transactions that moved during the technical cutover window. Shortcuts in revenue reconciliation will lead to a material weakness finding in your corporate audit.
Follow-up 1. What specific reports should I use in ECC to establish a revenue baseline?
Answer: for classical SD revenue recognition, use reports like VF47, revenue recognition, revenue recognized, and VF48, revenue recognition, revenue not yet recognized. These provide the detailed contract-level data needed to balance against the new S/4HANA subledger.
Follow-up 2. Why is dollar value reconciliation harder than record count reconciliation?
Answer: record counts only tell you if the shell of the order moved. Dollar value reconciliation proves that all the complex pricing, tax, and currency conversion logic inside the order moved correctly. It captures the financial truth of the record, which is much more sensitive to data model changes.
Follow-up 3, Curveball. Can the S/4HANA readiness check help with revenue reconciliation?
Answer: the readiness check will tell you that you have revenue recognition data to migrate, but it cannot tell you the value of that data. Establishing the baseline and proving the reconciliation is a manual governance task that must be managed by the project team.
Exclusive pro tip.
Invite your external auditors to review your reconciliation baseline and mock migration results during the realize phase. By getting their approval on the methodology early, you prevent a crisis during the first post-go-live financial audit.
Scenario 121. Data aging object migration misalignment.
In the realize phase of an ECC to S/4HANA migration, organizations often fail to align their legacy data with the new S/4HANA data aging framework. Unlike classic archiving, which moves data to an external server, data aging allows cold data to stay in the HANA database, but in a less memory-intensive state. If SD objects like sales orders or deliveries are misaligned during migration, active documents may be moved to the cold partition prematurely, making them invisible to standard SD transactions and causing significant operational delays.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high database architecture and visibility impact. 2. Phase, realize and deploy. 3. Frequency, common in high-volume systems using SAP HANA native storage extension. 4. Primary ownership, SAP data architect. 5. Supporting basis lead and SD functional lead. 6. Business ownership, IT infrastructure director. 7. Relevant SAP note. SAP note 1616302. Information Lifecycle Management Policy.
Diagnostic dashboard, symptoms and evidence.
How data aging misalignment appears during post-migration testing. 1. Symptom. A user searches for a recent sales order in transaction VA03, but the system returns the message document does not exist even though it is in the database. 2. Red flag. HANA memory consumption spikes unexpectedly because cold data objects are being frequently rewarmed by unoptimized Z reports. 3. Business impact. Order fulfillment teams cannot process returns or inquiries for documents that have been aged out of the hot partition. 4. Detection. Checking transaction DAG underscore data underscore OBJ shows SD objects, for example, SD underscore VBAK with inconsistent temperature partitions. 5. Technical proof. SQL queries on the HANA database show the data exists in the cold partition, but the application layer is not configured to read from it. Insight. Data aging is a visibility layer. If the settings are wrong, your data is there but your users are blind.
Why this happens, scenario analysis and root cause.
1. The project team treats data aging as a direct replacement for archiving without understanding that aged data still consumes HANA storage. 2. Failure to define the residence time for the hot partition based on real-time business usage patterns for SD documents. 3. Custom Z reports were not updated with the mandatory data aging annotations, causing them to ignore all documents in the cold partition. 4. The data migration scripts moved historical records into S/4HANA without assigning the correct age status, leaving them in the expensive hot memory. The failure is a result of treating database storage temperature as a basis task rather than a business task.
Why this is a migration, exclusive failure.
1. ECC did not have the concept of hot and cold data within the same database. Data was either live or archived. 2. S/4HANA migration introduces the Data Aging Framework, DAG, to manage the TCO of the HANA appliance. 3. The movement of data between hot and cold partitions is a new technical process unique to the S/4HANA architecture. 4. This failure only surfaces when the newly converted S/4HANA system attempts to manage large volumes of historical SD data. Migration introduces a new tiered storage logic that ECC never required.
Financial and customer impact.
1. Massive increase in cloud hosting costs if historical data is not correctly aged out of the expensive hot memory tier. 2. Customer service delays as reps must wait for cold data to be retrieved or rewarmed during telephone inquiries. 3. Inaccurate financial reporting if aged revenue records are skipped by custom analytical queries. 4. Risk of system timeouts during month-end if the HANA database is overwhelmed by unpartitioned historical SD tables. Data aging failures directly impact the total cost of ownership and system performance.
Governance and accountability, RACI model.
Data aging requires a synchronization between basis and the business. 1. Accountable, SAP data architect owns the data tiering strategy and the logical partitioning of SD tables. 2. Responsible basis lead configures the HANA native storage extension and executes the data aging runs. 3. Consulted, SD functional lead defines the temperature threshold. For example, documents older than 2 years are cold. 4. Informed, IT infrastructure director monitors the HANA memory savings achieved through the aging strategy. Accountability ensures that data is stored in the most cost-effective tier without losing operational visibility.
Ownership, who actually fixes it.
Resolving this requires an application-aware data storage design. 1. SAP Data Architect identifies the SD tables suitable for aging, for example, VBAK, VBAP, VBRK, and defines the partitioning keys. 2. Basis lead activates the data aging business functions and creates the required storage groups in the HANA database. 3. ABAP development team adds the with data aging clause to all custom SQL queries to ensure cold data is searchable. 4. SD functional lead validates that return orders for aged historical sales can still be processed without technical error.
Who gets blamed versus who owns it.
1. Blamed, basis team the business assumes the system is buggy because data is disappearing. 2. Blamed, SAP users claim S/4HANA cannot handle history as well as ECC could. 3. Actual owner, SAP data architect responsible for the failure to define a data temperature policy. 4. Root cause, treating data aging as a technical sizing trick rather than a fundamental change in data visibility. Visibility issues in S/4HANA are often storage tiering errors, not lost data.
How this is actually fixed, the way by a role.
1. SAP Data Architect mandates a data aging impact assessment for all custom O2C reports. 2. Basis lead implements HANA native storage extension to allow cold data to reside on disk while remaining accessible to the application. 3. The team configures the data aging objects, transaction dia GOBJ with specific business rules for residence time. 4. Functional leads execute a cold data retrieval test, ensuring that aged documents can be displayed in transaction VA03 using the aged data flag.
What not to do, common wrong fixes.
1. Using data aging as a way to avoid archiving. Aging is for data that might still be needed. Archiving is for data that is legally dead. 2. Moving data to cold storage based only on creation date while ignoring open document statuses. 3. Assuming that standard Fiori apps will automatically see cold data, many require a specific configuration to include aged records. 4. Ignoring the impact of data aging on database backup and restore times. Shortcuts in data tiering will lead to a self-inflicted data loss scenario for your end users.
Follow-up 1. What is the difference between data archiving and data aging in S/4HANA?
Answer: data archiving, SRA, moves data out of the database to an external file. The data is no longer reachable by standard transactions. Data aging, DAG, keeps data in the database but moves it from memory to disk cold. The data is still reachable by standard transactions if the data aging flag is set.
Follow-up 2. How do I know if my SD document is in the hot or cold partition?
Answer: you can check the field _dataaging in the database tables like VBAK. If the field is populated with a date, the record has been aged. In the application layer, you will notice that search results for that document will only appear if the Include Aged Data checkbox is selected.
Follow-up 3. Curveball. Can I rewarm data that has been aged?
Answer: yes. You can change the aging parameters or run a reverse aging job to move records back from the cold partition to the hot partition. This is often necessary if the business suddenly decides they need to perform mass changes on historical data.
Exclusive pro tip.
Before the realize phase ends, perform a report audit. Identify every Z report that reads from VBA-K and VBA-P. Mandate that these reports be updated to include the aged data selection parameter. If you miss this, your custom reports will give false zeros for any historical period that has been aged.
Scenario 122. Transportation Master Migration Inconsistencies.
In the realize phase of an ECC to S/4HANA migration, organizations often face severe disruptions in logistics due to inconsistencies in transportation master data. S/4HANA deprecates legacy transportation, LETRA, in favor of SAP Transportation Management, TM. If the migration of transportation zones, routes, and carriers, who must now be migrated as business partners, is not precisely synchronized, the system will fail to determine valid routes in sales orders, blocking the delivery creation process and halting the entire outbound supply chain.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logistics and integration impact. 2. Phase, realize and deploy. 3. Frequency, common in companies with global logistics networks. 4. Primary ownership, SD and TM functional lead. 5. Supporting master data management lead and basis lead. 6. Business ownership, global logistics director. 7. Relevant SAP note. SAP note 2267317. LETRA to TM simplification.
Diagnostic dashboard, symptoms and evidence.
How transportation migration failures manifest during testing. 1. Symptom, sales orders are created but return the warning no route could be determined, resulting in missing delivery dates. 2. Red flag, the carrier field in the delivery document is empty because the legacy forwarding agent ID was not correctly linked to a business partner. 3. Business impact, inability to group orders into shipments, leading to a complete halt in warehouse picking and loading operations. 4. Detection, checking table TROZ, transportation zones. In S/4HANA reveals missing entries for regional zones that were active in ECC. 5. Technical proof, errors in the S/4HANA route determination log transaction 0 VTC, showing that the zone-to-zone mapping is incomplete. Insight in S/4HANA, a route is no longer just a text string. It is a technical link between geographical master data points.
Why this happens, scenario analysis and root cause.
1. Legacy ECC transportation data was often inconsistent, with routes pointing to deleted shipping points or non-existent zones. 2. S/4HANA requires that all carriers and forwarding agents be converted to business partners with the role BBP000 service provider. 3. The project team fails to realize that S/4HANA Transportation Management uses a different geographical master structure than LETRA. 4. Underestimating the impact of transportation zone redesign. S/4HANA requires zones to be harmonized across sales and purchasing for unified TM use. The failure is a result of treating transportation as a customizing copy instead of a master data transformation.
Why this is a migration, exclusive failure.
1. ECC upgrades allowed LETRA data to remain static, with zero impact on the route determination engine. 2. S/4HANA migration involves the physical deactivation of LETRA, except for basic shipping, forcing a transition to the TM data model. 3. The synchronization of forwarding agents into the BP model is a mandatory technical requirement unique to S/4HANA. 4. This failure only surfaces when the new S/4HANA embedded TM logic attempts to calculate a route for a migrated sales order. Migration turns a legacy logistics setting into a mandatory TM prerequisite.
Financial and customer impact.
1. Supply chain paralysis at go-live leads to missed revenue targets and significant backlog management costs. 2. Inaccurate freight cost calculation results in incorrect customer billing and margin erosion. 3. Customer service delays as logistics teams must manually override routes for every shipment to bypass the system error. 4. Increased freight costs as the system fails to optimize shipments due to missing master data links. Transportation, master data failures directly block the physical movement of goods and cash.
Governance and accountability, RACI model.
Transportation migration requires a bridge between SD and logistics teams. 1. Accountable, Global Logistics Director owns the outbound shipping process and the accuracy of the route determination. 2. Responsible, SD and TM functional lead defines the mapping for transportation zones and routes in the new TM framework. 3. Consulted, Master Data Management lead executes the conversion of carriers and forwarding agents into business partners. 4. Informed, IT Transformation Director monitors the route determination success rate during the SIT and UAT phases. Accountability ensures that freight execution is not sacrificed during the technical migration.
Ownership, who actually fixes it.
Resolving this requires a route-by-route validation strategy. 1. SD Functional Lead extracts the legacy route determination matrix from transaction 0 VTC and identifies all active routes. 2. MDM Lead ensures that every forwarding agent in table LFA1 is synchronized as a business partner with the service provider role. 3. Technical Team runs the LETRA to TM migration, reports to move shipping points and zones into the new TM locations. 4. Logistics Director performs a shipment simulation, verifying that S/4HANA correctly calculates the transit time and carrier for key routes.
Who gets blamed versus who owns it.
1. Blamed, Master Data Team. The business assumes the carrier record was deleted during the migration. 2. Blamed, SD Lead. The warehouse team claims the shipping config is broken. 3. Actual owner, SD and TM functional lead responsible for the failure to define the zone location mapping during the explore phase. 4. Root cause, treating the LETRA to TM transition as a technical switch rather than a business process re-engineering. Logistics failures are usually due to missed geographical master data, not bad configuration.
How this is actually fixed, the way by a role.
1. SD and TM lead mandates a transportation zone harmonization to ensure sales and purchasing use the same geographical IDs. 2. The team implements location management in S/4HANA transaction/SAP/PO/LOC3 to represent shipping points as TM locations. 3. MDM lead utilizes the CVI synchronization reports to ensure that carrier tax IDs and addresses are 100% compliant with TM requirements. 4. Technical Architect performs a route determination stress test, ensuring the system can determine a valid route for 50,000 orders in under 1 minute.
What not to do, common wrong fixes.
1. Attempting to manually enter routes in sales orders to bypass the determination error. This will break freight cost calculation. 2. Ignoring carrier BP role errors, assuming they will not impact the sales order. TM requires a valid BP to finalize the route. 3. Using legacy T630 tables for custom route reports. These tables are functionally dead in an S/4HANA TM-centric environment. 4. Assuming that basic shipping in S/4HANA is 100% identical to ECC LETRA. There are subtle differences in shipment status handling. Shortcuts in transportation. Master data will lead to a complete shipping halt at the warehouse dock.
Follow-up 1. Can I still use classic routes and shipments in S/4HANA?
Answer: yes, but only under the basic shipping license, which is a temporary bridge. The strategic direction is S/4HANA Transportation Management, TM. Even if you use basic shipping, your forwarding agents must still be migrated as business partners, making CVI a mandatory step for logistics.
Follow-up 2. What is the biggest change in carrier master data in S/4HANA?
Answer: the carrier is no longer just a vendor. In S/4HANA, the carrier is a business partner with a specific service provider role. This role contains TM-specific attributes like carrier type and standard carrier alpha code, SCSC, which are required for modern logistics communication.
Follow-up 3. Curveball. Do I need to migrate my legacy transportation zones if I do not use S/4HANA TM?
Answer: yes. Even for basic shipping and standard route determination in SD, the system still checks the transportation zone of the customer and the shipping point. If these zones were not migrated or assigned to the correct country, the system will fail to find a route.
Exclusive pro tip.
Before the final cutover, run report/scmtms/mig_la_tra_tm to validate your master data readiness. This report identifies locations and business partners that are missing mandatory TM attributes. Fix these gaps in the sandbox first to ensure your logistics flow is bulletproof on day one.
Scenario 123. ILM policy alignment for SD data.
During the realize phase of an ECC to S/4HANA migration, failure to align the information lifecycle management ILM policies with the new SD data model creates a critical risk for GDPR compliance and data security. S/4HANA uses ILM to manage the blocking and deletion of business partners. If legacy SD residence and retention periods for sales orders and billing documents are not synchronized with the BP end-of-purpose logic, the system will either prematurely delete active customer data or fail to purge personal data as required by law.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high legal compliance and data security risk. 2. Phase, explore and realize. 3. Frequency, common in multinational companies operating in the EU or California. 4. Primary ownership, SAP GRC and data privacy lead. 5. Supporting data migration lead and SD functional lead. 6. Business ownership, data privacy officer and corporate counsel. 7. Relevant SAP note. SAP note 1616302. Information Lifecycle Management Policy.
Diagnostic dashboard, symptoms and evidence.
How ILM policy misalignment manifests after migration. 1. Symptom: a business partner is suddenly blocked and invisible to sales reps, even though the customer has an open sales order in the system. 2. Red flag: the end-of-purpose check transaction BUPA_PRE_EOP flags thousands of BPs for deletion while they still have active SD document flows. 3. Business impact: legal non-compliance due to overretention of personal data or operational disruption due to underretention of active master data. 4. Detection: checking table ILM_OBJ_assign shows SD objects, for example, SD_VBAK, with retention periods that conflict with the business partner ILM object. 5. Technical proof: errors in the blocking and deletion log stating that business partner is still in use by a document that should have been archived. Insight: ILM is the legal clock of your data. If the SD clock and the BP clock are out of sync, the system will paralyze.
Why this happens, scenario analysis and root cause.
1. ECC handled data deletion through simple archiving, SRA, whereas S/4HANA requires a unified lifecycle based on business purpose. 2. Failure to realize that a business partner cannot be blocked or deleted until all its linked SD, MM, and FI transactions have reached their retention period. 3. The project team used standard ILM policies for BP without validating the specific legal retention requirements of the sales department, for example, 10 years for tax. 4. Organizations fail to implement legal holds in ILM for documents involved in active litigation, leading to accidental data purging during migration. The failure is a result of treating data privacy as a basis setting instead of a legal requirement.
Why this is a migration, exclusive failure.
1. ECC systems often ignored the blocking and deletion framework because it was an optional add-on that few companies activated. 2. S/4HANA migration makes ILM the strategic foundation for managing business partner privacy and the right to be forgotten. 3. The transition to the BP model forces a synchronization of data lifecycles that never existed in the old customer-centric model. 4. This failure only surfaces when the data privacy jobs are first executed in the newly converted S/4HANA environment. Migration forces a level of data lifecycle synchronization that ECC allowed you to ignore for decades.
Financial and customer impact.
1. Massive financial penalties, up to 4% of global turnover, for GDPR violations if personal sales data is not purged according to policy. 2. Loss of customer trust if the company cannot fulfill a right to be forgotten request due to technical inconsistencies in the SD data. 3. Inability to complete repeat sales if a customer record was accidentally blocked by an overaggressive ILM retention policy. 4. High cost of data recovery to restore documents that were purged prematurely during an unvalidated ILM run. ILM failures directly threaten the company's legal standing and its market reputation.
Governance and accountability, RACI model.
ILM policy design requires a partnership between legal and IT. 1. Accountable, data privacy officer owns the data retention policy and the legal definition of the end of purpose. 2. Responsible, SAP GRC and data privacy lead configures the ILM rules and retention periods in the S4 HANA system. 3. Consulted, SD functional lead identifies the business-critical documents that must be protected from premature deletion. 4. Informed, corporate counsel monitors the compliance audit reports to ensure zero data privacy violations. Accountability ensures that IT cleanliness never violates legal compliance.
Ownership, who actually fixes it.
Resolving this requires a policy-first data governance framework. 1. Data privacy officer provides a retention matrix specifying how many years each SD document type must be kept live. 2. SAP GRC lead configures the ILM audit areas and ILM policies, transaction IRMPOL based on the legal matrix. 3. SD functional lead ensures that custom SD status management is correctly integrated with the end of purpose check. 4. Data migration team performs a deletion simulation in the sandbox to verify that only dead data is purged.
Who gets blamed versus who owns it.
1. Blamed, basis team. The business assumes basis deleted the records by mistake. 2. Blamed, SAP users claim the BP model is too restrictive for their business. 3. Actual owner, data privacy officer responsible for the failure to define a unified data lifecycle policy. 4. Root cause, treating ILM as a technical archiving task instead of a corporate compliance mandate. If you do not define the purpose of your data, the system will assume it has no purpose.
How this is actually fixed, the way by a role.
1. Data privacy officer mandates a global data inventory to map all personal data fields in the SD module. 2. The team implements simplified blocking and deletion for business partners, ensuring the SD to BP link is the primary trigger. 3. SAP GRC lead configures condition fields in ILM to distinguish between standard and legal hold documents. 4. Technical team executes a GDPR audit trail test, proving that a customer's right to erasure can be fulfilled technically in S4 HANA.
What not to do, common wrong fixes.
1. Migrating historical data to S4 HANA with infinite retention to avoid ILM errors. This is a massive GDPR violation. 2. Manually unblocking business partners in the database to bypass ILM logic. This corrupts the audit trail and is legally risky. 3. Ignoring the ILM settings in the master data workstream, assuming they will be fixed later. ILM is built into the S4 HANA core. 4. Assuming that residence time in SORA is the same as retention period in ILM. They are mathematically related but logically different. Shortcuts in ILM policy will lead to a financial and legal disaster during your first government audit.
Follow-up 1. What is the end of purpose check in S4 HANA?
Answer: the end of purpose, EOP check, is an automated tool that determines if a business partner still has active business. For SD, the EOP engine checks table VBAK and VBRK. If the documents are closed and have passed their residence time, the engine concludes the BP has reached its end of purpose and can be blocked.
Follow-up 2. Can I keep my SD documents longer than my business partner data?
Answer: no. This is a common architectural mistake. You cannot keep the transactional data, orders, longer than the master data, BP, because the order becomes an orphan that cannot be displayed or audited. Your ILM policies must be designed so that the master data is only purged after the last linked transaction is purged.
Follow-up 3. Curveball. What is a legal hold in SAP ILM?
Answer: a legal hold is a manual lock placed on a specific document or business partner that prevents it from being archived or deleted, regardless of the ILM policy. This is used during litigation or audits to ensure that evidence is preserved. The system will bypass all automated deletion jobs for any object with an active legal hold.
Exclusive pro tip.
Before starting your mock migrations, create a retention policy sign-off document. This document must list every SD object and its legal retention period, signed by the General Counsel. Use this as your golden rule for configuring ILM, ensuring IT is never blamed for illegal data retention.
Section 4 Wrap-up. Data migration strategy.
Section 4 has detailed the strategic and governance failures that occur before the system is technically converted. We analyzed how poor data scoping, aggressive archiving, and insufficient master data cleansing create a fragile foundation. The takeaway for any architect is that data readiness is the primary prerequisite for a stable S/4HANA system. If the data is not reconciled and cleansed in the legacy ECC environment, no amount of technical automation can guarantee a successful outcome.
Transition to Section 5. Conversion window incidents.
Once the code is remediated and the data is cleansed, we move into the most high-pressure phase of the project, the technical conversion window. In Section 5, we analyze the incidents that occur during the actual cutover weekend. This is where the Software Update Manager, or SUM, executes the physical transformation of the database, and where technical sequencing errors can lead to an immediate rollback of the entire migration.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Section 5. Surviving the technical conversion.
Section 5 focuses on the incidents triggered during the technical downtime. These are often purely technical or execution-based failures where the system is in a state of transition. At this stage, the risks shift from functional design to basis and technical orchestration. We will examine failures in table conversion, synchronization errors, and the technical conflicts that arise when the HANA database is pushed to its limits during mass data restructuring.
Section 5 Incident List.
This group of conversion window incidents focuses on the technical transformation of core SD data, orchestration, integration mapping, and database-level conversion risks. 124. CV synchronization failures. Relevant SAP note, SAP note 2713963 CV check report. 125. Pricing condition table conversion errors. Relevant SAP note, SAP note 2267308 pricing data model. 126. Document flow inconsistencies during SUM. Relevant SAP note not applicable basis and technical upgrade. 127. Output migration NAST to BRF plus failures. Relevant SAP note 2228611 output management. 128. Credit migration errors. Relevant SAP note not applicable cutover and basis execution. 129. Open delivery conversion conflicts. Relevant SAP note not applicable cutover and basis execution. 130. Billing migration inconsistencies. Relevant SAP note not applicable cutover and basis execution. 131. Number range conflicts. Relevant SAP note not applicable cutover and basis execution. 132. SPDD SBAU removes SD enhancements. Relevant SAP note not applicable cutover and basis execution. 133. Migration cockpit failures. Relevant SAP note not applicable cutover and basis execution. 134. Data freeze mismanagement. Relevant SAP note not applicable cutover and basis execution. 135. ATP category mapping issues. Relevant SAP note not applicable cutover and basis execution. 136. Background job conflicts. Relevant SAP note not applicable cutover and basis execution. 137. SDFI integration mapping inconsistencies. Relevant SAP note not applicable cutover and basis execution. 138. Differentiation category dependent FS dataset errors. Relevant SAP note 2265093 and SAP note 2713963, BP approach and CVI sync. 139. Revenue contract migration runtime failures. Relevant SAP note 2267319 and SAP note 2225170 revenue recognition. 140. Flexible workflow activation sequencing errors. Relevant SAP note not applicable cutover and basis execution. 141. HANA 2.0 index rebuild conflicts during SD table conversion. Relevant SAP note 1813245, HANA index rebuild. These incidents represent the critical path of the technical conversion weekend.
Scenario 124. CV synchronization failures.
In the technical conversion window of an ECC to S4 HANA migration, the customer vendor integration, or CVI, synchronization is the primary gatekeeper for the entire system. While preparation happens during realize, the physical synchronization of thousands of records often triggers unexpected technical failures during the downtime. If the MDS_load_ cockpit encounters locked records or technical timeouts during the final sync, the conversion remains incomplete and the system cannot be released to the business.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high cutover and system readiness impact. 2. Phase, deploy technical conversion window. 3. Frequency, very common in brownfield migrations. 4. Primary ownership, MDM lead and basis lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note 2713963 CVI master data sync.
Diagnostic dashboard, symptoms and evidence.
How CVI technical failures manifest during the conversion weekend. 1. Symptom. The CVI synchronization run in transaction MDS_load_ cockpit stalls at 99% and never completes. 2. Red flag, massive growth in the system log SM21, referencing in queue locks on table BUT000 during the conversion. 3. Business impact. The technical downtime exceeds the 48-hour window, forcing a go or no-go decision based on incomplete master data. 4. Detection, checking transaction MDS_PPO2 reveals hundreds of objects in stage status that cannot commit to the database. 5. Technical proof, background job logs for the CVI synchronization show time limit exceeded or database connection lost errors. Insight. CVI during cutover is a high-volume database event. Any infrastructure bottleneck will cause a sync failure.
Why this happens, scenario analysis and root cause.
1. Massive data volume in the contact person table KNV leads to memory overflow in the MDS_load_ cockpit buffer. 2. Background work processes are incorrectly configured, causing the CVI sync to run in a single-threaded mode rather than parallel processing. 3. The Software Update Manager, or SUM, triggers the CVI sync while other post-conversion database indexes are still being built, leading to massive I and O contention. 4. Failure to apply the latest CVI-related SAP notes to the ECC system prior to the final technical conversion. The failure is a result of technical execution limits being reached during the high-pressure conversion window.
Why this is a migration, exclusive failure.
1. ECC updates never required a synchronous transformation of customer records into a completely different database object business partner. 2. S4 HANA migration enforces a mandatory synchronization gate. You cannot bypass the CVI process and still have a functional SD module. 3. The MDS load engine is a specialized migration tool that is not used in standard ECC maintenance or enhancement pack upgrades. 4. This failure only occurs when the system attempts to finalize the CVI link as part of the technical brownfield conversion. CVI is the technical heart of the S4 HANA migration. There is no equivalent in the ECC world.
Financial and customer impact.
1. Delayed go-live results in a complete halt of sales order entry, leading to millions of dollars in deferred revenue. 2. Warehouse operations are paralyzed because deliveries cannot be processed for customers whose BP synchronization failed. 3. Inconsistent partner data in the system leads to incorrect pricing and tax calculations once the system is finally live. 4. Extreme pressure on the technical team leads to manual data hacks which compromise the long-term integrity of the master data. A CVI failure during the conversion window is a project-stopping event with immediate financial consequences.
Governance and accountability, RACI model.
Fixing CVI failures during cutover requires a rapid response team. 1. Accountable, IT Transformation Director owns the go or no-go decision based on the technical completion of the sync. 2. Responsible, basis lead monitors system performance and manages the background work processes for the MDS load. 3. Consulted, MDM lead provides immediate data cleansing instructions for records that trigger technical errors. 4. Informed, project manager tracks the CVI progress against the hourly cutover schedule. Accountability ensures that technical bottlenecks are escalated and resolved in minutes, not hours.
Ownership, who actually fixes it.
Resolving this requires technical system tuning and expert data intervention. 1. Basis lead increases the number of available background work processes, RDISP and WP_no_BTC, to allow for maximum parallelization of the CVI sync. 2. MDM lead monitors transaction MDS_PPO2 in real time and executes immediate ignore or force commands for non-critical errors. 3. ABAP lead reviews short dumps in SD22 to identify any custom baddies or exits that are slowing down the synchronization loop. 4. Technical architect utilizes SAP Note 2713963 to apply last-minute patches to the CVI cockpit engine.
Who gets blamed versus who owns it.
1. Blamed. MDM lead the business assumes the data was not ready for the migration. 2. Blamed. Basis lead the project manager assumes the server performance is to blame for the delay. 3. Actual owner. Technical architect responsible for the failure to stress test the CVI engine with full production volumes during the mock cycles. 4. Root cause. Underestimating the database resources required for a synchronous mass update of the master data layer. Cutover failures are often the result of insufficient technical dry runs.
How this is actually fixed, the way by a role.
1. Basis lead optimizes the MDS_load_cockpit parameters, setting the block size to 1,000 records to prevent memory overflow. 2. MDM lead utilizes the parallel processing feature in the CVI cockpit to distribute the load across multiple application servers. 3. The team executes an emergency data purge for contact persons, KNVK, that are not linked to any active sales documents to reduce the volume. 4. Functional leads perform a spot check after the sync to ensure that the customer to BP link table, CVI_cust_link, is correctly populated.
What not to do, common wrong fixes.
1. Killing the MDS_load_cockpit job while it is active. This can leave the system in a half-sync state that is nearly impossible to recover from. 2. Attempting to manually update the BUT000 table via SQL to bypass a CVI error. This violates the application logic and will lead to system dumps. 3. Ignoring the PPO2 errors and releasing the system to the business. This will result in users being unable to save any sales documents. 4. Reducing the validation level of the BP engine during the cutover to save time. Shortcuts during the technical conversion window will result in an immediate rollback of the entire project.
Follow-up 1. Why does CVI take so much longer during the actual conversion than it did in the sandbox?
Answer: in the sandbox, you often use a subset of data or a single application server. In the production conversion, the volume is 100%, and the system is often performing other intensive tasks like HANA index rebuilding and universal journal transformation simultaneously. This resource contention slows down the CVI sync exponentially.
Follow-up 2. Can I skip the CVI sync during the downtime and run it after go live?
Answer: absolutely not. In S/4HANA, the customer transactions are technically redirected to the BP engine. If the BP does not exist, the transaction will error out. CVI is a hard prerequisite for any SD activity in S/4HANA.
Follow-up 3. Curveball. What is the most effective way to speed up the CVI sync during the weekend?
Answer: the most effective way is parallelization. You must configure the MDS cockpit to use as many background work processes as the server can handle. Additionally, ensuring that the database statistics for tables KNA1 and BUT000 are updated immediately before the sync will help the HANA optimizer choose the fastest path.
Exclusive pro tip.
During your final mock migration, use transaction SDAD to measure the exact CPU and memory consumption of the CVI synchronization process. Use this data to negotiate a dedicated system lockout for the basis team during the final go-live weekend, ensuring CVI has 100% of the system resources.
Scenario 125. Pricing condition table conversion errors.
During the technical conversion window of an ECC to S/4HANA migration, the Software Update Manager, SUM, performs a physical transformation of the pricing data. Legacy condition data stored in the compressed cluster table KONV is moved to the transparent table PRCD_elements. If the database logs are insufficiently sized, or if there is underlying corruption in the cluster records, the conversion will fail during the XPRA phase, halting the entire migration and risking a full system rollback.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high technical execution and data integrity risk. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems with large KONV volumes exceeding 100 million rows. 4. Primary ownership, basis lead. 5. Supporting SD functional lead and ABAP custom code remediation lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note. SAP note 2267308. S/4HANA pricing data model.
Diagnostic dashboard, symptoms and evidence.
How pricing conversion errors manifest during the downtime window. 1. Symptom. The SUM tool displays a red status in the XPRA_CONV phase with the error short dump during table conversion. 2. Red flag, massive growth in the database undo logs or transaction logs during the KONV to PRCD_elements transformation. 3. Business impact. The conversion downtime window is exceeded by 12 to 24 hours while basis teams attempt to restart the failed table conversion. 4. Detection. Error logs in transaction SD22 show the dump DBIF_RSQL_SQL_ error referencing table PRCD_elements. 5. Technical proof. SQL traces indicate that the database has run out of temporary table space or log segments during the mass insert operation. Insight. Pricing conversion is a one-way physical move. If it fails halfway, the pricing subledger is in an inconsistent state.
Why this happens, scenario analysis and root cause.
1. The sheer volume of pricing data was not adequately modeled during the sizing phase of the project. 2. The HANA database was not configured with enough log file capacity to handle the commit of millions of transparent pricing records in a single block. 3. Legacy data corruption in the ECC cluster table KONV, such as orphan records or invalid internal compression, triggers a crash when the transformer tries to read them. 4. Insufficient parallel work processes assigned to the SUM tool, causing a single-threaded conversion to time out at the database level. The failure is a result of technical resource exhaustion during the most intensive data transformation in the SD module.
Why this is a migration exclusive failure?
1. ECC upgrades never touch the KONV table. The compressed cluster remains static regardless of the version. 2. S/4HANA migration physically deletes the KONV table and recreates the data in a transparent format to enable HANA native pricing calculations. 3. The XBRA conversion reports for pricing are specialized tools that only execute during a brownfield system conversion. 4. This failure only surfaces when the system is in the middle of the physical table restructuring phase of the S/4HANA upgrade. S/4HANA is the first time in SAP history that the pricing cluster has been physically uncompressed into transparent tables.
Financial and customer impact.
1. A failed conversion results in an immediate rollback, meaning the company loses the entire weekend and fails to go live. 2. Inconsistent pricing data post-conversion leads to invoices being generated with $0 values, causing massive revenue leakage. 3. Customer disputes increase as historical discounts are lost or incorrectly recalculated during the migration. 4. High cost of emergency consulting support to manually repair database tables during the high-pressure go-live window. Pricing conversion errors are the most frequent cause of go-live aborts in large-scale SD migrations.
Governance and accountability, RACI model.
Surviving the pricing conversion requires a tight technical and functional link. 1. Accountable basis lead owns the technical execution of the SUM tool and the database log capacity. 2. Responsible technical architect configures the parallelization parameters and monitors the XBRA conversion jobs. 3. Consulted SD functional lead provides the baseline totals to verify that the transformed data matches the legacy values. 4. Informed IT transformation director manages the rollback decision if the pricing conversion cannot be fixed within the downtime window. Accountability ensures that basis is not working in a vacuum. They must have functional sign-off on the data result.
Ownership, who actually fixes it.
Resolving this requires database-level tuning and functional validation. 1. Basis lead expands the HANA log file segments and monitors the I and O throughput during the transformation. 2. Technical architect adjusts the XBRA parallelization settings in the SUM tool to distribute the load across more CPU cores. 3. SD functional lead runs report PRC_MIG_check_ tools to identify the specific sales documents that caused the transformation crash. 4. ABAP lead implements emergency SAP notes if the crash is caused by a known bug in the conversion engine.
Who gets blamed versus who owns it.
1. Blamed basis team the business assumes they crashed the server. 2. Blamed SAP the project team claims the SUM tool is unstable. 3. Actual owner basis lead and technical architect responsible for the failure to size the system and test the conversion speed during mocks. 4. Root cause underestimating the database overhead of uncompressing and inserting billions of rows into a transparent table. Conversion crashes are planning failures, not software bugs.
How this is actually fixed, the way by a role.
1. Basis lead mandates a database health check before the cutover to ensure zero corruption in the cluster tables. 2. Technical architect utilizes HANA table partitioning for PRCD_elements to allow parallel writes during the conversion. 3. The team implements optimized XBRA settings, bypassing non-essential index creation until after the data is moved. 4. SD lead executes a reconciliation script immediately after the conversion to verify the SUM of pricing conditions in PRCD_elements equals the original cluster SUM.
What not to do, common wrong fixes.
1. killing the conversion job and manually deleting records in PRCD_elements. This will leave the pricing subledger permanently corrupted. 2. Increasing the timeout parameter without increasing the log capacity. The system will simply crash later and waste more time. 3. Ignoring errors in the dry run mocks, assuming they are just data issues that will not happen in production. 4. Failing to run the pricing consistency reports in the legacy ECC system prior to the final technical conversion. Shortcuts during the pricing conversion will lead to a financial audit disaster post-go-live.
Follow-up 1. Why does KONV need to be transparent in S/4HANA?
Answer: HANA is a columnar database that performs best when it can read data directly from memory. KONV was a cluster, meaning the data was zipped or compressed. To calculate a price, the system had to unzip the data first, which was too slow for the real-time analytics and mass processing goals of S/4HANA.
Follow-up 2. What is the risk of the XBRA phase in the SUM tool?
Answer: the XBRA phase is the execution of reports after upgrade. This is when the system runs specialized ABAP code to move and transform data. If an XBRA fails, it usually means the system is technically upgraded but functionally empty or inconsistent. It is the most common point of failure for large data transformations.
Follow-up 3. Curveball. Can I use SAP Note 22673008 to estimate my downtime?
Answer: yes. SAP Note 22673008 provides detailed information on the pricing data model shift. Combined with the readiness check, it gives you the tools to analyze your KONV record count and estimate how many hours the database will need for the physical transformation.
Exclusive pro tip.
During your last mock migration, ask your basis team to provide the SUM phase logs for the PRCD_elements conversion. Calculate the records per minute throughput and use this to justify the exact start time for your final production downtime window. Never guess the duration of a pricing conversion.
Scenario 126. Document flow inconsistencies during SUM.
In the deploy phase of an ECC to S/4HANA migration, the technical conversion tool, SUM, must adapt the document flow table VBFA to the new data model. S/4HANA optimizes the way document links and statuses are managed to improve the speed of the sales process. If the technical conversion is interrupted, or if there are legacy locked documents during the downtime window, the links between sales orders, deliveries, and invoices can become corrupted, leading to subsequent document failures post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high process integrity and audit trail risk. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems with high transactional concurrent locking. 4. Primary ownership basis lead. 5. Supporting SD functional lead and technical architect. 6. Business ownership sales operations manager. 7. Relevant SAP note, not applicable basis and technical upgrade. This is a technical execution and system lock management failure.
Diagnostic dashboard, symptoms and evidence.
How document flow corruption manifests after the technical conversion. 1. Symptom: users open the document flow button in transaction VA03 and see that the delivery or invoice link is missing entirely. 2. Red flag: the SUM logs show ignored errors or table conversion warnings for table VBFA during the downtime. 3. Business impact: inability to process returns, cancellations, or credit memos for documents that existed before the migration. 4. Detection: comparing the number of entries in table VBFA ECC versus S/4HANA reveals a missing percentage of document links. 5. Technical proof: errors in the document flow integrity check stating that a child document VBRK exists without a valid parent link in VBFA. Insight: document flow is the central nervous system of SD. If a link is severed, the business process is paralyzed.
Why this happens, scenario analysis and root cause.
1. The system conversion tool, SUM, encountered database locks from background jobs that were not properly stopped before the downtime began. 2. S/4HANA introduces new document categories and link types in VBFA that require a remapping of legacy ECC links during the upgrade. 3. A lack of database log space during the physical conversion of the massive VBFA table, often the largest table in SD, caused a partial commit. 4. The project team failed to perform a document cleanup in ECC, leaving millions of incomplete flows that crashed the conversion engine. The failure is a result of technical collision during the high-speed data transformation window.
Why this is a migration, exclusive failure.
1. ECC upgrades, EHP upgrades, never modified the structure of the document flow, ensuring perfect continuity of links. 2. S/4HANA migration involves a metadata transformation of document links to support the new embedded analytics and simplified status model. 3. The technical step of adapting VBFA is a mandatory part of the S/4HANA upgrade path that did not exist in any previous SAP version. 4. This failure only surfaces when the system is in the middle of the software update downtime window. S/4HANA requires the document flow to be relinked for the new architecture to function.
Financial and customer impact.
1. Revenue leakage occurs when return orders cannot find the original sale, forcing the company to issue manual, unvalidated credits. 2. Inaccurate financial audits as the lineage of an invoice cannot be traced back to the delivery and sales order. 3. Customer service delays increase as reps cannot answer status questions about documents created prior to the migration. 4. Loss of ROI as the Fiori sales order fulfillment apps show incorrect data due to broken document flow links. Broken document flows directly destroy the single version of truth for the sales cycle.
Governance and accountability, RACI model.
Ensuring document flow integrity requires basis and functional synchronization. 1. Accountable basis lead owns the successful execution of the SUM tool and the technical locks management. 2. Responsible technical architect monitors the table transformation logs and resolves any database-level errors. 3. Consulted SD functional lead provides the critical flow scenarios for post-conversion validation. 4. Informed sales operations manager approves the data continuity sign-off after the conversion window. Accountability ensures that technical success is validated by functional accuracy.
Ownership, who actually fixes it.
Resolving this requires technical log analysis and database reconciliation. 1. Basis lead ensures that transaction SM12 and Q locks is 100% empty before the downtime phase begins. 2. Technical architect reviews the SUM conversion logs for table VBFA and reruns any failed transformation segments. 3. SD functional lead executes transaction V.02 in S/4HANA to find any inconsistent document links created during the migration. 4. Data migration team performs a VBFA row count comparison between the ECC source and the S/4HANA target.
Who gets blamed versus who owns it.
1. Blamed basis team. The business assumes they lost some data during the upgrade. 2. Blamed SAP users claim the document flow button is buggy in S/4HANA. 3. Actual owner basis lead responsible for failing to manage system locks and technical job scheduling during the cutover. 4. Root cause running a high-volume table transformation while active database locks were still present in the system. A missing document link is a technical execution error, not a data entry mistake.
How this is actually fixed, the way by a role.
1. Basis lead mandates a hard system shutdown of all non-SAP background jobs 4 hours before the downtime window. 2. The team implements post-conversion integrity reports, like report SD_VBFA_integrity_check, to find and fix broken links. 3. Technical architect configures the SUM tool to perform a high-integrity table check during the data transfer phase. 4. Functional leads perform chain validation, navigating from a historical invoice back to the sales order for 50 strategic accounts.
What not to do, common wrong fixes.
1. Assuming that if the sales order VBFA is there, the flow VBFA must be there too. They are separate technical events. 2. Manually inserting records into table VBFA using SQL hacks to fix a missing link. This will bypass status logic and corrupt the system. 3. Ignoring warnings about orphan item data during the SUM process. These are the links that will fail post-go live. 4. Leaving the ECC production system open for users during the final data extraction for S/4HANA. Shortcuts in document flow conversion will lead to a permanently fragmented audit trail.
Follow-up 1. Does S4HANA change the technical structure of the VBFA table?
Answer: yes. While the primary fields like VBELV and VBELN remain, S4HANA adds new indices and changes how the document category, VBTYP, is used to support the new AATP and EWM integration. The migration tool must adapt every legacy link to these new rules.
Follow-up 2. What is a dangling link in the document flow?
Answer: a dangling link occurs when the document flow table, VBFA, says a delivery exists for an order, but the physical delivery record, LIPS, was either deleted or failed to migrate. This causes object not found errors when users try to navigate the history.
Follow-up 3. Curveball. Can I rebuild my document flow after go live?
Answer: only partially. You can run specialized correction reports provided by SAP support, but they are designed to fix inconsistencies between existing records. They cannot recreate data that was lost during a failed technical conversion. Prevention during the SUM downtime is the only safe strategy.
Exclusive pro tip.
Before the cutover, use transaction DB02 to find the exact row count of table VBFA. Document this number in your cutover runbook. After the technical conversion, verify that the S/4HANA row count is identical or slightly higher due to new indices. Any drop in record count is an immediate stop work signal for the basis team.
Scenario 127. Output migration NAST to BRF plus failures.
In the technical conversion window of an ECC to S/4HANA migration, the transition from legacy output determination, NAST, to the new S/4HANA output management, BRF+, often triggers systemic communication failures. While S/4HANA supports a compatibility mode for legacy forms, the new architecture defaults to BRF+ for billing documents. If the conversion of condition records into BRF+ decision tables is incomplete, or if the Adobe Document Services ADS connection is not established during the downtime, the system will fail to generate customer-facing documents like invoices and order confirmations.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high customer communication and process impact. 2. Phase, deploy technical conversion window. 3. Frequency, common in organizations adopting Fiori first output management. 4. Primary ownership, SD and output lead. 5. Supporting a ABAP development team and basis lead. 6. Business ownership, customer service director. 7. Relevant SAP note. SAP note 2228611. Output management in S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How output migration failures manifest during the conversion weekend. 1. Symptom billing documents are created successfully, but the output status remains in errors or to be defined. 2. Red flag, the technical log in transaction SP01 shows zero spool generation for documents that use smart forms or SAP scripts in ECC. 3. Business impact, inability to send invoices to customers via email or EDI, leading to immediate revenue collection delays. 4. Detection, checking transaction OPD output parameter determination, reveals that the decision tables are empty or the rules are inactive. 5. Technical proof, background job logs for report APOC underscore or underscore data underscore KONV show mapping error between legacy and ST condition types and BRF plus output types. Insight, NAST is condition-based. BRF plus is rule-based. If the rules aren't activated during downtime, the printer stays silent.
Why this happens, scenario analysis and root cause.
1. S/4HANA output management requires a separate technical setup for Adobe Document Services, which is often not fully tested in the sandbox. 2. Legacy condition records in table NACH are not automatically compatible with the BRF plus XML-based decision engine. 3. The project team fails to choose between classic NAST and new BRF plus during the design phase, leading to a conflicting configuration in the target system. 4. Custom print programs in ECC often use direct table reads on NAST, which do not return any data for documents processed via the new engine. The failure is a result of an architectural mismatch between legacy procedural output and modern rule-based output.
Why this is a migration, exclusive failure.
1. ECC upgrades never change the output engine, so condition records and print programs always remained 100% compatible. 2. S4 HANA migration introduces an entirely new output framework, BRF+, as the strategic direction for the digital core. 3. The technical step of migrating NAST data to the APOC_D_ or underscore item table is a one-time event unique to the S4 HANA conversion path. 4. This failure only surfaces when the organization attempts to execute the output generation for the first time in the converted system. Migration turns a stable printing process into a cross-framework transformation.
Financial and customer impact.
1. Operational paralysis, as thousands of invoices are trapped in the system and cannot be sent to customers for payment. 2. Customer frustration peaks when order confirmations contain unformatted or incorrect pricing data due to failed form logic. 3. Legal noncompliance if mandatory tax fields are missing from the output because the new Adobe form was not correctly mapped. 4. Increased IT support costs to manually re-trigger and repair output records for every document created on day 1. Output failures are the most visible sign to a customer that an S4 HANA migration has gone wrong.
Governance and accountability, RACI model.
Ensuring output continuity requires synchronization between SD and development teams. 1. Accountable. SD and output lead owns the output determination logic and signs off on the accuracy of the printed forms. 2. Responsible. Output and form developer configures the BRF+ decision tables and remediates legacy print programs. 3. Consulted. Basis lead ensures that Adobe document services and printer spoolers are active and connected. 4. Informed. IT transformation director monitors the output success rate during the final conversion window. Accountability ensures that system success translates into customer communication success.
Ownership, who actually fixes it.
Resolving this requires a technical activation and decision table validation. 1. SD functional lead identifies which document types will move to BRF+ and which will stay on Classic and ST. 2. ABAP development team refactors legacy print programs to use the new S4 HANA output API, CL_APOC_output_API. 3. Basis lead configures the HTTP connections for the Adobe XML form processing engine. 4. Technical architect utilizes report APOC_ or _data_KONV to technically migrate legacy condition records where required.
Who gets blamed versus who owns it.
1. Blamed. ABAP developers. The business assumes the print form is broken or incorrectly coded. 2. Blamed. Basis team users claim the printer connection is down. 3. Actual owner. SD and output lead responsible for the failure to define the output strategy and activate the BRF+ rules. 4. Root cause. Treating the move to S4 HANA output management as an optional setting rather than a mandatory redesign. If a form does not print, the logic usually failed before the printer was even called.
How this is actually fixed, the right way by a role.
1. SD and output lead mandates a classic to modern form audit during the realize phase. 2. The team implements the mandatory S4 HANA output configuration via transaction OPD for all billing and sales objects. 3. Technical architect ensures that any legacy and ST-based smart forms are wrapped in the output compatibility layer if not fully migrated. 4. Basis team executes a mass printer test during the downtime window, using a dummy sales order to verify end-to-end spool generation.
What not to do, common wrong fixes.
1. Manually re-entering thousands of condition records in the target system post-go-live. This is prone to error and incredibly slow. 2. Assuming that smart forms will work perfectly in a BRF+ environment without technical adjustments, they require a different interface wrapper. 3. Ignoring output testing during the mock cycles, thinking it is just a minor UI task. 4. Disabling the new S4 HANA output management simply because the legacy in a ST was easier. This creates technical debt that will be harder to fix later. Shortcuts in output migration result in a manual mailing nightmare for the sales team on day 1.
Follow-up 1. Do I have to move all SD output to BRF Plus in S/4HANA?
Answer: no. Classic NIST is still supported for most objects, but the strategic direction is BRF+. For billing documents specifically, S/4HANA is designed to use the new engine by default. You must consciously decide which engine each document type will use during the explore phase to avoid logic conflicts.
Follow-up 2. What is the biggest advantage of the new BRF Plus output framework?
Answer: the biggest advantage is the business user control. Instead of needing an ABAPer to change a condition record, a business user can go into transaction OPD and modify output rules. Like if sales org equals 1000, email the invoice, using a simple decision table interface that looks like Excel.
Follow-up 3. Curveball. Can I use my old smart forms with the new BRF Plus engine?
Answer: yes, but with limitations. You have to configure the form type in S/4HANA to recognize smart forms. However, to get the full benefit of S/4HANA, like cloud-ready XML output, you should eventually migrate those forms to Adobe Forms, Adobe Document Services.
Exclusive pro tip.
Before the final cutover, use Transaction OPD to perform an export of your decision tables to Excel. After the technical conversion, perform an import into the production system. This is the only way to ensure your complex output rules are 100% identical to your tested quality assurance environment.
Scenario 128. Credit migration errors.
In the technical conversion window of an ECC to S/4HANA migration, the physical transfer of credit exposure often fails. S/4HANA replaces legacy SD credit management, tables S066 and S067, with SAP FSCM credit management, table UKM_item. If the conversion report FIN_MIG_credit_MGMT encounters technical timeouts, or if business partner credit segments are not activated during the downtime, the new system will show zero exposure or blocked status for all customers, halting the entire shipping pipeline.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial risk and supply chain impact. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems migrating to FSCM credit management. 4. Primary ownership, credit manager. 5. Supporting basis lead and SD and FICO lead. 6. Business ownership, global credit director. 7. Relevant SAP note, not applicable cutover and basis execution. Reference SAP note 2270544 for FSCM transition context.
Diagnostic dashboard, symptoms and evidence.
How credit technical failures manifest during the downtime window. 1. Symptom, the credit exposure migration monitor in S/4HANA, transaction FINS_MIG_monitor, shows thousands of documents in pending or error status. 2. Red flag, massive ABAP short dumps, TSV_TNU_page_alloc_failed during the execution of the FSCM data transfer reports. 3. Business impact, all sales orders are automatically blocked for credit on day 1 because the credit limit used value is missing or incorrect. 4. Detection, checking table UKM_item in S/4HANA reveals that the total liability for major customers is $0.00 despite millions in open ECC orders. 5. Technical proof. Errors in the conversion log stating that the credit segment does not exist for the business partner record. Insight. If credit exposure does not move correctly during downtime, the warehouse will be unable to ship a single box on Monday morning.
Why this happens, scenario analysis and root cause.
1. The migration engine for credit, FSCM, requires that all business partner records be credit active, roll UKM000, before exposure can be assigned. 2. Technical timeouts occur during the processing of table S067 because the HANA database is performing massive index updates for the Universal Journal simultaneously. 3. Failure to execute the credit reorganization reports in the legacy ECC system, RVKRED 77, immediately before the final downtime window. 4. The project team underestimates the impact of multi-currency credit exposures, which require a currency conversion step during the migration. The failure is a result of technical resource contention and mandatory master data prerequisites not being met.
Why this is a migration exclusive failure?
1. ECC upgrades never change the location of credit data. The S066 and S067 tables remain the only source of truth. 2. S4 HANA migration involves a physical movement of value from the SD module to the FSCM component, which is a standalone engine. 3. The credit migration report FINS_MIG_credit_MGMT is a specialized tool that only runs during a brownfield system conversion. 4. This failure only surfaces when the system is in the post-processing phase of the technical conversion window. S4 HANA forces a mandatory credit engine swap that no standard upgrade ever required.
Financial and customer impact.
1. Blocked shipments result in missed month-end revenue targets and significant logistics backlog costs. 2. Customer disputes arise when long-term strategic partners are credit blocked incorrectly in the new system. 3. Inaccurate financial reporting of credit risk if the migration underreports the total exposure of the customer base. 4. High operational cost to manually force release thousands of orders, while basis teams attempt to fix the credit tables. Credit migration errors directly paralyze the order-to-cash pipeline and damage customer trust.
Governance and accountability, RACI model.
Successful credit migration requires a triple sync between basis, SD, and FI Company 1. Accountable, credit manager owns the final credit limit used values and the decision to release orders on day 1. 2. Responsible, basis lead executes the technical conversion reports and monitors the database performance. 3. Consulted, SD and FICO lead validates that the legacy credit control areas are correctly mapped to the new FSCM credit segments. 4. Informed, IT Transformation Director manages the go or no-go decision based on the completion of the credit load. Accountability ensures that technical success is validated against real-world customer exposure.
Ownership, who actually fixes it.
Resolving this requires technical log analysis and credit subledger reconciliation. 1. Basis lead monitors the credit migration monitor and reruns any failed jobs with increased parallel work processes. 2. MDM lead ensures that the business partner role UKM000 is correctly assigned to all customers before the exposure load. 3. SD functional lead runs transaction FCV_order_check to identify documents that failed to update the FSCM tables. 4. Credit manager performs a baseline reconciliation, comparing the SUM of exposure in ECC to the SUM of exposure in S4 HANA.
Who gets blamed versus who owns it.
1. Blamed, SD lead the sales team assumes the credit config was messed up during the upgrade. 2. Blamed, basis team the project board assumes the data load failed to finish on time. 3. Actual owner, credit manager and SD and FICO lead responsible for the failure to cleanse the credit data and test the FSCM migration logic. 4. Root cause, treating credit migration as a technical job instead of a critical financial data transformation. A credit error is usually a data synchronization problem, not a system bug.
How this is actually fixed, the right way by a role.
1. Credit manager mandates a hard credit freeze 24 hours before the downtime begins to ensure a clean source snapshot. 2. The team implements HANA parallel processing for report FINS_MIG_credit_MGMT to reduce execution time by 80%. 3. Technical architect executes report UKM_recon_rebuild immediately after go live to force a fresh recalculation of all exposure from open orders. 4. Basis team applies SAP Note 2270544 and all prerequisite patches to the FSCM component before the conversion starts.
What not to do, common wrong fixes.
1. Manually overriding credit exposures in table UKM_item using SQL. This will be immediately overwritten by the system the next time an order is saved. 2. Increasing credit limits for everyone by 100% to bypass blocks. This creates a massive unmanaged financial risk for the company. 3. Ignoring errors in the credit migration monitor and releasing the system to users. Every error is a guaranteed blocked order. 4. Failing to run the ECC credit reorg reports, RVKRED 77, because they take too long. This is the primary cause of ghost exposure in S/4HANA. Shortcuts in credit migration result in a total supply chain halt and financial audit failure.
Follow-up 1. Why is FSCM credit management mandatory in S/4HANA?
Answer: legacy SD credit management relied on LIS tables, S066/S067, which were technically obsolete and could not handle real-time global risk management. FSCM is a centralized, integrated framework that allows for automated credit scoring, external credit agency integration, and better financial auditing, which is core to the S/4HANA vision.
Follow-up 2. What is the single most important technical step in credit migration?
Answer: the most important step is running report RVKRED 77 in the legacy ECC system immediately before the final data snapshot. This ensures that the legacy LIS tables, which are the source for the S/4HANA migration, are perfectly synchronized with the actual open sales orders.
Follow-up 3. Curveball. Can I use S/4HANA credit management without moving to FSCM?
Answer: technically, no. In S/4HANA, the credit management functions have been physically moved into the FSCM component. While it is still called S/4HANA credit management, the underlying technical engine is FSCM. You must perform the migration and configuration for the new engine to work.
Exclusive pro tip.
Before the final cutover, create a credit exposure snapshot of your top 50 customers in ECC. After the technical conversion, verify these 50 balances in S/4HANA before allowing the first delivery wave to start. If the top 50 are correct, your migration logic is sound. If not, stop and rebuild the credit exposure immediately.
Scenario 129. Open delivery conversion conflicts.
In the technical conversion window of an ECC to S/4HANA migration, the transition of open deliveries often triggers synchronization conflicts. S/4HANA simplifies how delivery statuses are stored by moving them from the obsolete VBUK and VBUP tables directly into the LIKP and LIPS tables. If deliveries are in a partially processed state, such as picked but not packed, or packed but not goods issued, during the downtime, the conversion engine may fail to map the status correctly, leading to locked deliveries that cannot be goods issued post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logistics execution and inventory impact. 2. Phase, deploy technical conversion window. 3. Frequency, common in high-volume distribution centers. 4. Primary ownership, SD and logistics functional lead. 5. Supporting basis lead and technical architect. 6. Business ownership, warehouse operations manager. 7. Relevant SAP note, not applicable cutover and basis execution. Refer to SAP note 2227014 for delivery simplification context.
Diagnostic dashboard, symptoms and evidence.
How delivery conversion conflicts manifest during the cutover window. 1. Symptom: users attempt to perform a post-goods issue (PGI) in S/4HANA but receive an error stating delivery is already fully processed despite it being open. 2. Red flag: the SUM conversion logs show warnings for table LIPS regarding status inconsistency during the XPRA phase. 3. Business impact: inability to ship goods on day 1, leading to a warehouse backlog and missed customer delivery windows. 4. Detection: comparing the overall delivery status GBSDK in ECC table VBUK with the new LIKP status field in S/4HANA reveals a mismatch. 5. Technical proof: errors in the S/4HANA delivery monitor transaction VL060 showing documents stuck in a technical lock due to inconsistent internal status flags. Insight: an open delivery is a living object. If you freeze it in the middle of process, the S/4HANA conversion engine may not know how to wake it up.
Why this happens, scenario analysis and root cause.
1. The Software Update Manager, SUM, transforms delivery data into the new data model, but it cannot resolve in-process warehouse activities like open EWM picking tasks. 2. Status fields that were previously distributed across multiple tables are now consolidated, and the conversion logic fails to reconcile split statuses, for example, partial picking. 3. Failure to clear the update queues, transaction SM13, before the downtime began, leaving pending delivery updates in a technical limbo. 4. Underestimating the complexity of serial number or batch assignments that were halfway through processing when the system was shut down. The failure is a result of technical state inconsistency during the physical table restructuring.
Why this is a migration, exclusive failure.
1. ECC upgrades never move the status data. VBUK and VBUP remain the source of truth regardless of the EHP version. 2. S4 HANA migration involves a physical deletion of status tables, forcing a one-time data movement that is sensitive to record locks. 3. The technical reports that move delivery data into the new L, IKP, and L, IPS fields are specialized migration scripts that only run during a brownfield conversion. 4. This failure only surfaces when the system transition tool encounters a delivery in motion during the conversion phase. Migration forces a status data consolidation that standard upgrades never performed.
Financial and customer impact.
1. Revenue recognition is delayed because goods cannot be technically issued from the system, preventing the generation of invoices. 2. Inaccurate inventory levels as the system thinks goods are still in the bin while they are physically on a truck. 3. Severe customer dissatisfaction as promised next-day deliveries are delayed due to technical system locks. 4. Operational cost increases as warehouse staff must manually reverse and recreate hundreds of deliveries to clear the errors. Open delivery conflicts directly paralyze the ship-to-bill pipeline on the first day of operations.
Governance and accountability, RACI model.
Ensuring delivery continuity requires warehouse and IT coordination. 1. Accountable, warehouse operations manager owns the physical inventory and the cleanliness of open deliveries before the cutover. 2. Responsible, SD and logistics functional lead defines the cleardown procedures and validates the delivery status post-conversion. 3. Consulted, basis lead ensures that all background update tasks and system locks are cleared before the conversion window starts. 4. Informed, customer service lead monitors potential shipment delays and manages customer expectations during the first 24 hours live. Accountability ensures that the warehouse is quiet before the technical conversion begins.
Ownership, who actually fixes it.
Resolving this requires a zero open task logistics strategy. 1. Warehouse manager mandates that all picking and packing tasks must be confirmed or canceled 4 hours before the system shutdown. 2. SD functional lead runs transaction VL060 to identify any deliveries with incomplete or in-process status and forces their completion. 3. Basis lead checks transaction SM12 for any lingering locks on tables LIKP or LIPS before allowing the SUM tool to enter the downtime phase. 4. Technical architect performs a status reconciliation, comparing document statuses in S4 HANA against the final ECC snapshot.
Who gets blamed versus who owns it.
1. Blamed, warehouse team. The project team assumes the warehouse did not follow the plan. 2. Blamed, SAP. The business claims the conversion tool corrupted their deliveries. 3. Actual owner, SD and logistics functional lead responsible for the failure to define a strict cutover logistics protocol. 4. Root cause, allowing complex warehouse processes to remain active during the final technical data transformation. Logistics conversion errors are usually procedural failures, not technical bugs.
How this is actually fixed, the way by a role.
1. Warehouse manager executes a ship it or quit it policy 24 hours before cutover, ensuring 100% goods issue for all loaded trucks. 2. SD functional lead utilizes report WS_CORR_VBUK_VBUP, if applicable, to fix any legacy status inconsistencies in ECC before the migration starts. 3. The team implements a technical post-processing step in S4 HANA to re-trigger the status update for documents identified as inconsistent. 4. Logistics lead executes a day 1 warehouse walkthrough, verifying that the first 10 deliveries can be picked and goods issued without error.
What not to do, common wrong fixes.
1. Attempting to goods issue an inconsistent delivery in S4 HANA using direct table updates to fix the status. This will break inventory reconciliation. 2. Ignoring open deliveries that have been inactive for months. These should be deleted in ECC before the migration to avoid conversion noise. 3. Performing a force goods issue via Z program to clear the backlog without checking the EWM or TM integration status. 4. Failing to notify the warehouse team of the exact minute they must stop scanning items in the legacy system. Shortcuts in delivery conversion result in a physical and digital inventory mismatch.
Follow-up 1. Why did SAP move the delivery status from VBUK to LIKP?
Answer: to improve database performance. In ECC, every time you checked a delivery status, the system had to join LIKP and VBUK. In S4 HANA, the status is a field within the main table. This reduces the number of database reads and allows for faster parallel processing, which is critical for high-volume logistics.
Follow-up 2. What happens if a delivery is goods issued in ECC, but the update task fails during conversion?
Answer: this is a split-state error. The inventory is reduced, but the delivery status says it is still open. You must resolve this using the inventory and delivery reconciliation reports in S4 HANA. If you do not, you will end up with a permanent variance in your general ledger.
Follow-up 3. Curveball. Can I use S4 HANA Advanced ATP to fix my delivery conflicts?
Answer: no. ATP is for future availability. For existing deliveries that are stuck, ATP cannot help. You must fix the underlying status data in the document header and item tables first before any ATP check can be reliably executed.
Exclusive pro tip.
Establish a logistics cleanup milestone 2 weeks before go live. Every delivery older than 30 days must be either goods issued, deleted, or formally justified for migration. A clean delivery table is the best insurance policy for a smooth cutover weekend.
Scenario 130. Billing migration inconsistencies.
In the technical conversion window of an ECC to S4 HANA migration, the transition of billing data into the Universal Journal often surfaces critical inconsistencies. S4 HANA integrates SD billing, tables VBRK and VBRP, more tightly with finance, table ACDOCA. If billing documents are billed but not posted, or if there are variances between the SD condition values and the FIGL accounts during the downtime, the conversion will trigger reconciliation errors, preventing the final financial sign-off.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial accuracy and month-end impact. 2. Phase deploy technical conversion window. 3. Frequency common in systems with high volume, complex tax or rebate logic. 4. Primary ownership SD functional lead and FICO lead. 5. Supporting data migration lead and basis lead. 6. Business ownership corporate controller. 7. Relevant SAP note, not applicable cutover and basis execution. Refer to SAP note 2349298 for Universal Journal ACDOCA context.
Diagnostic dashboard, symptoms and evidence.
How billing conversion errors manifest during the cutover window. 1. Symptom. The financial data conversion step in the SUM tool shows a mismatch between the SD billing subledger and the general ledger. 2. Red flag. Invoices that were created in ECC just before the shutdown appear in S4 HANA but show a status of not posted to accounting. 3. Business impact. Inability to close the legacy period and open the new system period for financial reporting, delaying the entire go-live. 4. Detection. Checking transaction VFX3 blocked billing documents. In S4 HANA reveals thousands of legacy documents with error in account determination. 5. Technical proof. Mismatches between the net value in table VBRK and the corresponding balance for the revenue account in table ACDOCA. Insight in S4 HANA. The wall between SD and FI is removed. Any existing crack in that wall becomes a project-stopping failure.
Why this happens, scenario analysis and root cause.
1. Billing documents were created in ECC, but the accounting interface, task RV underscore message underscore update, was not completed before the system was locked. 2. The S/4HANA conversion engine enforces stricter zero-variance rules between SD and FI that were not fully checked in the legacy environment. 3. Legacy custom pricing routines performed rounding in SD that differed by 1 cent from the FI currency rounding logic, causing a balancing error in the Universal Journal. 4. Failure to perform a financial reconciliation, transaction FSR1, in ECC immediately before the final data snapshot was taken. The failure is a result of moving to a single source of truth model where SD and FI data must be perfectly aligned.
Why this is a migration, exclusive failure.
1. ECC upgrades kept SD and FI in separate data silos, meaning a subledger mismatch rarely blocked a technical upgrade. 2. S/4HANA migration physically merges SD and FI data into the ACDOCA table, requiring every billing row to be validated against an accounting row. 3. The reconciliation step in the SUM tool, data consistency check, is a mandatory S/4HANA conversion gate that did not exist in ECC. 4. This failure only surfaces when the system transition tool attempts to build the Universal Journal entries from legacy billing history. S/4HANA enforces a financial integrity check that standard ECC upgrades simply ignored.
Financial and customer impact.
1. Delayed go-live results in a complete billing blackout, damaging the company's working capital and DSO, days sales outstanding. 2. Inaccurate revenue reporting if historical invoices are not correctly mapped to the new S/4HANA account structure. 3. Customer disputes increase if invoices are reposted in S/4HANA with different tax or rounding values than the original ECC invoice. 4. External auditors may qualify the migration results if the SD to FI reconciliation variances cannot be explained down to the cent. Billing inconsistencies directly compromise the legal and financial integrity of the enterprise.
Governance and accountability, RACI model.
Reconciling billing data requires a tight link between SD and finance teams. 1. Accountable, corporate controller owns the final financial balance and the audit trail from billing to the balance sheet. 2. Responsible, SD functional lead and FICO lead jointly responsible for resolving account determination and rounding errors during the cutover. 3. Consulted, data migration lead ensures that the migration reconciliation reports provide the detail needed to find the root cause of variances. 4. Informed, CFO monitors the risk to the financial close timeline and sign-off. Accountability ensures that the numbers are correct, not just the system.
Ownership, who actually fixes it.
Resolving this requires a reconcile freeze post methodology. 1. SD functional lead runs transaction VFX3 in ECC and ensures 100% of billing documents are released to accounting before the cutover. 2. FICO lead executes a trial balance in ECC and compares the revenue and deferred revenue totals against the SD billing reports. 3. Data migration team runs the financial reconciliation pre-checks in the S/4HANA conversion cockpit to find variances early. 4. Technical architect utilizes report FINS_recon_SD_FI to identify the specific document IDs that are causing the reconciliation failure.
Who gets blamed versus who owns it.
1. Blamed, SD functional lead, the finance team assumes billing configuration is calculating wrong numbers. 2. Blamed, SAP the business assumes the Universal Journal model is losing data. 3. Actual owner, SD functional lead and FICO lead jointly responsible for the failure to perform a subledger reconciliation in the legacy system. 4. Root cause, decades of acceptable variances in ECC being exposed by the strict S/4HANA financial validation engine. A billing variance in S/4HANA is usually a historical error that ECC allowed you to ignore.
How this is actually fixed, the way by a role.
1. FICO lead mandates a hard close of the billing period 24 hours before the technical downtime to ensure no new variances are created. 2. The team implements automatic rounding correction in the accounting interface to ensure SD and FI always match at the document level. 3. SD functional lead utilizes transaction VBOF to ensure all rebate accruals are correctly reflected in the billing documents before the migration. 4. Technical team executes a value match script that compares table VBRKN ETWR to table ACDOCHSL for every migrated document.
What not to do, common wrong fixes.
1. Migrating incomplete billing documents with a VFX3 status, and hoping to fix them in S4 HANA, they will likely never post. 2. Manually adjusting the universal journal using journal entries to force a balance. This destroys the link between sales and finance. 3. Ignoring 1-cent rounding variances, assuming they are immaterial. S4 HANA requires a perfect balance or the document will not save. 4. Allowing new invoices to be created in ECC while the data is being extracted for the S4 HANA load. Shortcuts in billing reconciliation will lead to an audit red flag that will haunt the CFO for months.
Follow-up 1. What is the most common cause of the SDFI mismatch during conversion?
Answer: the most common cause is foreign currency rounding. In ECC, SD and FI sometimes use different exchange rate types or rounding decimal places. Because S4 HANA stores both values in the same row in ACDOCA, these differences are now exposed as hard errors that prevent the document from migrating.
Follow-up 2. Should I post all my blocked billing documents, VFX3, before the migration?
Answer: yes, 100%. If a document is blocked in ECC, it means the system cannot find a valid accounting path. If you migrate it in that state, you are migrating a broken object into a strict system. It is much easier to fix the account determination in ECC than it is to debug it during the conversion window.
Follow-up 3. Curveball. Can the compatibility views for VBRK help with reconciliation?
Answer: no. Compatibility views help your Z reports read data, but they do nothing for financial reconciliation. The reconciliation happens at the database transformation layer, XBRA. If the raw data in the tables does not match, the conversion engine will fail, regardless of any views.
Exclusive pro tip.
Establish a financial cleanroom 24 hours before the cutover. Run transaction FSR1 in ECC to prove the system is in balance. If it is not, stop the migration and fix the variance in ECC. You should never start an S4 HANA migration with an existing financial subledger imbalance.
Scenario 131. Number range conflicts.
In the technical conversion window of an ECC to S4 HANA migration, number range overlaps frequently block the creation of master data and transactional documents. S4 HANA mandates that the business partner ID must be unique across the entire landscape. If the legacy customer number ranges overlap with existing vendor ranges, or if the new S4 HANA document number ranges for sales and billing conflict with legacy buffer settings, the system will trigger duplicate key errors, preventing users from saving any documents on day one.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high master data and transactional integrity impact. 2. Phase, deploy technical conversion window. 3. Frequency, very common in multi-entity brownfield conversions. 4. Primary ownership basis lead. 5. Supporting MDM lead and SD functional lead. 6. Business ownership IT transformation director. 7. Relevant SAP note, not applicable cutover and basis execution. Refer to SAP note 2265093 for business partner number range context.
Diagnostic dashboard, symptoms and evidence.
How number range conflicts manifest during the conversion weekend. 1. Symptom, creating a new sales order results in the error express document. Update was terminated due to a duplicate key in table VBAK. 2. Red flag, the business partner synchronization. CVI stalls because the target number range is already partially consumed by legacy vendors. 3. Business impact. Complete operational hard stop as the system refuses to generate IDs for customers, orders, deliveries, or invoices. 4. Detection, checking transaction SNRO for object RV_BELEG shows that the current number is lower than the actual highest VBELN in the database. 5. Technical proof, database error SQL code 301, unique constraint violation. on table NRIV during the cutover simulation. Insight: in S/4HANA, the number range is the nervous system of the database. A single overlap can paralyze the entire enterprise.
Why this happens, scenario analysis and root cause.
1. In ECC, customers and vendors had independent number ranges. S/4HANA forces them into a shared business partner number pool. 2. Failure to synchronize the number range level in table NRIV between the legacy ECC snapshot and the new S/4HANA environment. 3. Legacy system number buffering was active during the final data extract, leading to the S/4HANA system starting with an obsolete next number counter. 4. Custom Z tables for SD often use the same number range object as standard VBAK, causing collisions during high-volume migration loads. The failure is a result of technical numbering collision during the master data transformation.
Why this is a migration, exclusive failure.
1. ECC upgrades never change the fundamental numbering logic for customers or vendors. 2. S/4HANA migration is a global ID harmonization event where all entities must fit into a new unified business partner numbering scheme. 3. The technical step of level adjustment in transaction, SNUM, is a mandatory one-time cutover task unique to S/4HANA conversion. 4. This failure only surfaces when the system is opened for the first transaction after the conversion window has closed. S/4HANA forces a numbering big bang that ECC never required.
Financial and customer impact.
1. Revenue collection halts entirely if the system cannot generate an invoice number, blocking all cash inflows on day 1. 2. Shipment delays occur because deliveries, LIKP, cannot be saved, resulting in missed delivery windows and customer penalties. 3. Inaccurate financial reporting if technical gaps in number ranges are created due to failed update tasks. 4. High operational cost, as basis and functional teams must manually jump number ranges to find a free sequence during go-live. Number range failures directly halt the order-to-cash heartbeat of the company.
Governance and accountability, RACI model.
Managing number ranges requires a strict coordination between basis and master data. 1. Accountable, basis lead owns the technical integrity of table NRIV and the synchronization of number range levels. 2. Responsible, MDM lead defines the business partner numbering strategy and ensures no overlaps exist between customer and vendor groups. 3. Consulted, SD functional lead validates that the document number ranges for sales and billing match the legacy business requirements. 4. Informed, IT transformation director monitors the risk of ID collisions during the final cutover. Accountability ensures that the technical next number matches the business reality.
Ownership, who actually fixes it.
Resolving this requires a technical audit and manual level adjustment. 1. Basis lead identifies the highest used number in tables VBAK, LIKP, and VBRK using a SQL-max command. 2. Technical architect updates the number range level in transaction SNRO to be exactly one digit higher than the highest used number. 3. MDM lead configures the internal number assignment for the business partner groupings to avoid legacy vendor overlaps. 4. SD functional lead executes a first document test in every sales organization to verify that numbers are being generated correctly.
Who gets blamed versus who owns it.
1. Blamed, basis team the business assumes the system is broken. 2. Blamed, MDM team the sales team claims the customer was migrated wrong. 3. Actual owner, basis lead, and MDM lead jointly responsible for failing to perform a number range audit during the cutover simulation. 4. Root cause, failing to synchronize the technical pointer in NRIV with the physical data in the sales tables. A number range error is a technical coordination failure, not a master data error.
How this is actually fixed, the way by a role.
1. Basis lead mandates a number range level sync as a mandatory step in the cutover runbook immediately after the SUM technical conversion. 2. The team implements external number assignment for the BP to customer link to ensure the legacy customer ID is retained without conflict. 3. Technical architect disables mainframe-style number buffering during the conversion window to prevent the system from skipping IDs. 4. MDM lead executes a collision report that checks for identical IDs between the legacy LFA1 vendor and KNA1 customer tables.
What not to do, common wrong fixes.
1. Manually deleting document headers in VBAK to make room for number range. This will cause permanent database corruption. 2. Setting the number range level to a far future number, for example, jumping from 1000 to 9000 to avoid collisions. This creates audit gaps. 3. Assuming that internal numbering in S/4HANA will automatically know where the ECC external numbering ended. 4. Ignoring duplicate key warnings during the mock migration, assuming they are just test data issues. Shortcuts in number range management result in a permanently fragmented audit trail.
Follow-up 1. What is the same number principle in S/4HANA CVI?
Answer: the same number principle is the configuration where the business partner ID and the customer ID are identical. While highly recommended for user adoption, it requires that your legacy customer number range must not overlap with any existing legacy vendor or BP ranges. If they overlap, the same number principle is technically impossible to achieve.
Follow-up 2. How does number buffering impact the conversion downtime?
Answer: number buffering improves performance during normal operations by taking a block of numbers into memory. However, during a conversion, it can lead to skipped numbers if the system is restarted frequently. It is best practice to turn off buffering during the conversion window to ensure every ID is accounted for in the audit log.
Follow-up 3. Curveball. Can I change my sales order numbering from internal to external during the migration?
Answer: technically yes, but it is high risk. Changing the numbering type requires a total redesign of all inbound interfaces and EDI mappings. A brownfield conversion is already complex. You should aim to keep document numbering as consistent as possible to avoid interface shock for your customers and vendors.
Exclusive pro tip.
Add a number range audit task to your final production cutover checklist. Use a SQL script to compare the next free number in transaction SNR row with the highest used number in the database for all SD objects. This 5-minute check can prevent a total system failure on Monday morning.
Scenario 132. SPDD and SBAU removes SD enhancements.
During the technical conversion window of an ECC to S/4HANA migration, the Software Update Manager, or SUM, overwrites standard SAP objects. The project team must use transactions SPDD and SBAU to reconcile custom modifications and enhancements. If the basis or ABAP teams perform a reset to SAP standard without understanding the functional O2C logic, critical SD enhancements, such as custom fields in the billing interface or pricing routines in MV45FZZ, will be deleted, resulting in broken business processes post-conversion.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high technical integrity and custom logic risk. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems with heavy modifications in the SAP namespace. 4. Primary ownership, ABAP lead HANA. 5. Supporting basis lead and SD functional lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note. SAP note 2, 198647. Custom code adaptation for S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How SPDD and SBAU failures manifest during the conversion process. 1. Symptom: custom fields in the sales order header VBAK suddenly disappear or show as inactive after the technical upgrade. 2. Red flag: the SBAU_ENH monitor shows hundreds of enhancements in conflict status that have been marked as adjustment complete without testing. 3. Business impact: critical revenue recognition logic or third-party logistics interfaces stop functioning because the hooks in standard SAP code were removed. 4. Detection: comparing the modification browser, transaction SE95, in ECC against S/4HANA reveals missing Z objects in the standard SAP namespace. 5. Technical proof: the ABAP source code for include MV45FZZ shows only SAP standard comments, and the custom Z logic has been physically overwritten. Insight: SPDD and SBAU are the surgical phases of an upgrade. If the technical team cuts too much, the system loses its memory.
Why this happens, scenario analysis and root cause.
1. The technical team is under extreme pressure to finish the downtime window and chooses reset to standard for objects with complex conflicts. 2. Lack of coordination between basis, who execute SUM, and ABAP, who reconcile code, leading to a siloed adjustment process. 3. Failure to document legacy modifications in transaction SC95, making it impossible for the remediation team to know what is custom versus SAP standard. 4. Incomplete remediation during the realize phase, where developers assumed SBAU would automatically handle the merge of legacy code. The failure is a result of technical speed over quality during the high-pressure conversion window.
Why this is a migration, exclusive failure.
1. ECC upgrades, EHP upgrades, involved minor changes to standard code, making the SBAU adjustment process very predictable. 2. S4 HANA is a new product. SAP has physically deleted and refactored thousands of lines of code in the SD module, triggering massive conflicts. 3. The shift from procedural includes AFZZ to the enhancement framework, enhancement spots, makes legacy modifications highly unstable during the merge. 4. This failure only occurs when the SUM tool is physically replacing the ECC kernel and repository with the S4 HANA version. S4 HANA migration involves a level of code overwrite that ECC upgrades never approached.
Financial and customer impact.
1. A failed billing interface results in millions of dollars of unsent invoices, creating an immediate cash flow crisis. 2. Inaccurate tax calculation occurs if custom tax exits in the SAP namespace are accidentally reset to standard during SBAU. 3. Loss of ROI as the business is forced to redevelop legacy enhancements that should have been preserved during the migration. 4. Extreme hypercare costs as the ABAP team must work around the clock to reinsert logic into a live production system. Logic loss in SPDD and SBAU directly compromises the business rules of the enterprise.
Governance and accountability, RACI model.
Reconciling code requires a partnership between basis and the ABAP leads. 1. Accountable, ABAP lead HANA owns the successful reconciliation of all custom logic and signs off on the adjustment complete status. 2. Responsible basis lead executes the SUM tool and manages the SPDD and SBAU transport generation. 3. Consulted, SD functional lead provides the critical business rules list to verify that the core logic was preserved. 4. Informed, IT transformation director monitors the conflict resolution rate as a key indicator of cutover progress. Accountability ensures that technical speed never overrides functional survival.
Ownership, who actually fixes it.
Resolving this requires a double check of all modifications. 1. ABAP lead utilizes transaction SC95 to identify all modifications in the SAP namespace and ensures they are in the SBAU list. 2. Basis lead ensures that the SPDD and SBAU transports from the sandbox are correctly applied to the development and production systems. 3. SD functional lead performs a smoke test on critical O2C transactions, VA01, VF01, immediately after the technical upgrade. 4. Technical architect performs a code compare between the final ECC production and the newly converted S4 HANA sandbox.
Who gets blamed versus who owns it.
1. Blamed, basis team. The business assumes basis deleted the code during the upgrade. 2. Blamed, SAP. The developers claim the SUM tool is too aggressive. 3. Actual owner, ABAP lead HANA, responsible for the failure to manage the adjustment process and validate the final code state. 4. Root cause, treating SPDD and SBAU as a basis task rather than a high-level ABAP reconciliation task. Code loss is a management failure, not a software bug.
How this is actually fixed, the way by a role.
1. ABAP lead mandates a zero reset policy for all SD critical includes, unless a modern baddie replacement is proven to work. 2. The team implements a shadow code repository where the ECC version of critical exits is stored for quick reference during SBAU. 3. Technical architect utilizes the remote SBAU feature to allow developers to begin code adjustments before the downtime window even starts. 4. Functional leads execute functional unit testing on the first day of the conversion window to catch missing logic before UAT starts.
What not to do, common wrong fixes.
1. Performing SBAU adjustments directly in the production system without testing them in a sandbox first. This is a project death wish. 2. Accepting all standard SAP suggestions in SBAU without checking if a legacy Z modification was providing a required regulatory control. 3. Ignoring SPDD dictionary adjustments, assuming only SBAU logic matters. If the table fields aren't adjusted, the logic will fail anyway. 4. Allowing a basis administrator who is not an ABAP developer to perform the SBAU reconciliation. Shortcuts in SBAU result in an empty shell system that looks live but has lost its business soul.
Follow-up 1. What is the difference between SPDD and SBAU in an S/4HANA migration?
Answer: SPDD is for dictionary objects, tables, data elements, structures. You must run it during the downtime to ensure the database schema is correct. SBAU is for repository objects, programs, classes, function modules. You run it after the upgrade is technically complete to restore your business logic.
Follow-up 2. What is the remote SBAU tool and why is it a game changer?
Answer: the remote SBAU, available in newer SAP versions, allows you to compare and adjust your code in a sandbox system and then export those adjustments to the production migration. This drastically reduces the manual work required during the actual high-pressure downtime window.
Follow-up 3. Curveball. Can I use S/4HANA migration to delete all my old modifications in SBAU?
Answer: yes, and you should. Migration is the perfect time to clean the core. If you have a legacy modification in the SAP namespace that can now be handled by a standard S/4HANA baddie, you should choose Reset to Standard in SBAU and implement the baddie during the realize phase.
Exclusive pro tip.
Before the technical conversion, take a complete snapshot of your legacy SD user exits, includes like MV45FZZ and RV60FZZ. Copy the source code into a local text file. After the upgrade, perform a visual diff between your text file and the new S/4HANA code to ensure zero logic was lost during the SBAU reconciliation.
Scenario 133. Migration cockpit failures.
During the technical conversion window of an ECC to S/4HANA migration, the SAP S/4HANA Migration Cockpit, LTMC, or the Migrate Your Data app often becomes a technical bottleneck. Unlike standard data loads, the cockpit performs deep architectural validations in real time. If the staging tables are not indexed correctly, or if the XML template buffers overflow during the final production load, the cockpit will stall or crash, leaving the migration of critical SD objects like open sales orders or price conditions in a half-finished state.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high technical execution and critical path risk. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems with high-volume transactional data. 4. Primary ownership, data migration lead and architect. 5. Supporting basis lead and ABAP custom code remediation lead. 6. Business ownership, IT transformation director. 7. Relevant SAP note, not applicable cutover and basis execution. Refer to SAP note 2478095 and SAP note 2538700 for migration cockpit troubleshooting.
Diagnostic dashboard, symptoms and evidence.
How migration cockpit technical failures manifest during cutover. 1. Symptom: the transfer data step in the migration cockpit hangs at a specific percentage for several hours without any progress in the job logs. 2. Red flag: the background job DMC_MT_migration_service shows a status of killed or canceled in transaction SM37. 3. Business impact: crucial sales data is missing from the new system on day 1, preventing the warehouse from picking and shipping orders. 4. Detection: error logs in the migration cockpit indicate CX_SY_open_SQL_DB errors, suggesting database-level locks or timeout issues. 5. Technical proof: transaction SD04 reveals massive disk I&O contention on the migration staging tables, the /1 LT/namespace. Insight: The migration cockpit is a high-performance engine. If you starve it of system resources, it will stall during the most critical window.
Why this happens, scenario analysis and root cause.
1. The staging environment was not sized to handle the 100% volume of production data, leading to memory bottlenecks. 2. Using the file-based migration approach for more than 100,000 records, the XML parser in the cockpit cannot handle multi-gigabyte files efficiently. 3. A lack of database statistics for the staging tables causes the HANA optimizer to choose unoptimized full table scans during the validation step. 4. Concurrent execution of multiple migration projects on the same application server saturates the available background work processes. The failure is a result of technical architecture limitations being reached during the high-pressure production load.
Why this is a migration, exclusive failure.
1. ECC upgrades, EHP upgrades. Do not use the migration cockpit. Data remains in the physical tables throughout the process. 2. S/4HANA migration introduces the cockpit as the mandatory tool for new data insertion during a selective transition or brownfield shell conversion. 3. The technical validation engine of the cockpit is unique to the S/4HANA product and does not exist in the legacy ECC kernel. 4. This failure only occurs when the specialized migration cockpit API attempts to reconcile legacy data with the new S/4HANA data structures. Migration introduces a validation layer that acts as a technical hurdle ECC never had.
Financial and customer impact.
1. Delayed go-live results in a complete order management blackout, costing the company thousands of dollars in lost productivity every hour. 2. Incomplete migration of pricing conditions leads to wrong invoice values, damaging customer trust and creating a massive credit memo backlog. 3. Operational chaos as the data team is forced to manually upload records into the production system while users are already logged in. 4. Audit failures if the incomplete load results in a mismatch between the legacy sales subledger and the new S/4HANA trial balance. Migration cockpit failures directly threaten the first day of business in the new system.
Governance and accountability, RACI model.
Surviving a cockpit failure requires a rapid response technical team. 1. Accountable data migration lead and architect owns the successful load of all SD objects and the technical health of the cockpit. 2. Responsible data migration team executes the loads, monitors the status, and resolves mapping errors in real time. 3. Consulted basis lead provides the system resources, memory, and work processes required for the bulk load. 4. Informed cutover manager tracks the % complete against the hourly cutover milestone chart. Accountability ensures that technical errors in the cockpit do not become project-stopping blockers.
Ownership, who actually fixes it.
Resolving this requires database tuning and migration object optimization. 1. Data migration lead mandates a shift from file-based to staging table-based migration for all high-volume SD objects. 2. Basis lead increases the ABAP and heap area total memory parameters to prevent XML parsing dumps during the load. 3. Technical architect implements parallel processing in the migration cockpit settings, transaction MWB, to distribute the load across 20 or more jobs. 4. ABAP lead refactors any custom migration objects to remove inefficient nested selects that are slowing down the validation loop.
Who gets blamed versus who owns it.
1. Blamed data migration team. The business assumes the spreadsheets were formatted incorrectly. 2. Blamed SAP. The project team claims the migration cockpit app is unstable and slow. 3. Actual owner, data migration lead and architect responsible for the failure to perform a 100% volume stress test in a mock environment. 4. Root cause, underestimating the system resources required to perform millions of S/4HANA validations in a compressed 48-hour window. The failure is rarely in the data itself. It is usually in the technical pipe that carries the data.
How this is actually fixed, the way by a role.
1. Data migration lead mandates the use of direct transfer, SAP Note 2538700, instead of XML files to bypass the application server file limits. 2. The team implements Delta mocks to test the performance of the cockpit under simulated production network latency. 3. Basis Lead ensures that HANA DB statistics are refreshed for the staging tables immediately after the data is extracted from ECC. 4. Technical Team execute a load and block strategy, migrating 50,000 sales orders at a time to prevent the cockpit buffer from saturating.
What not to do, common wrong fixes.
1. Attempting to bypass the migration cockpit and using SQL insert to put data into VBAK. This is a violation of SAP support and will corrupt the system. 2. Increasing the number of parallel jobs without checking the available HANA memory. This will cause a global system crash. 3. Ignoring warning messages in the cockpit log. A warning in the validation step often becomes a hard dump in the transfer step. 4. Retrying a failed load without identifying the root cause. This just creates duplicate record errors in the target system. Shortcuts in migration cockpit execution will lead to an inconsistent and unauditable database.
Follow-up 1. When should I choose staging tables over XML files for SD migration?
Answer: you should use staging tables for any object with more than 50,000 records. XML files are great for master data like sales groups, but for sales orders or price conditions, the overhead of parsing the XML file will slow down your cutover significantly and likely cause timeout errors.
Follow-up 2. What is the risk of custom migration objects in S/4HANA?
Answer: custom objects, built via the Migration Object Modeler, or LTMOM, often lack the performance optimizations of SAP standard objects. If your custom object performs direct table lookups without using the HANA-optimized APIs, it can be 10 times slower than the standard object, blocking your cutover window.
Follow-up 3. Curveball. Can I use the migration cockpit to update existing data in S/4HANA?
Answer: standard migration cockpit objects are designed for creation, not update. If you try to load a record that already exists, the cockpit will error out with a duplicate key. To update data, you must use standard BAPIs, OData APIs, or custom-built migration objects that support the update method.
Exclusive pro tip.
Before the technical conversion, go to transaction LTMOM and check the parallelization settings for each migration object. Ensure that high-volume SD objects are set to use at least 5 to 10 work processes. This technical prep can reduce your data load time from 12 hours to 2 hours during the go-live weekend.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 134. Data freeze mismanagement.
In the technical conversion window of an ECC to S/4HANA migration, the organization enters a blackout period where data is frozen in the legacy system. Failure to strictly enforce this data freeze results in users or background interfaces creating new sales orders, deliveries, or payments in ECC after the final data snapshot has been taken. This results in orphan transactions that exist in the legacy system, but are missing from S/4HANA, creating a reconciliation nightmare and financial imbalances on day one.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial integrity and operational risk. 2. Phase, deploy technical conversion window. 3. Frequency, common in multinational programs with 24/7 operations. 4. Primary ownership, project manager and cutover lead. 5. Supporting SD functional lead and basis lead. 6. Business ownership, global operations director. 7. Relevant SAP note, not applicable cutover and basis execution. This is a project governance and process discipline failure.
Diagnostic dashboard, symptoms and evidence.
How data freeze failures manifest during the go-live phase. 1. Symptom, a customer calls about a sales order they placed yesterday, but the order cannot be found in the new S/4HANA system. 2. Red flag, transaction SM21 in the legacy ECC system shows successful login and document create events during the scheduled blackout period. 3. Business impact, inability to ship orders created during the freeze, leading to a loss of revenue and damaged customer service reputation. 4. Detection, comparing the highest sales order number in ECC against the source data snapshot reveals that new numbers were generated after the freeze. 5. Technical proof, interface logs in the middleware PI and PO show success status for postings to the legacy system during the downtime window. Insight. A data freeze is only as strong as the technical locks you put on the system. Relying on user policy is a recipe for failure.
Why this happens, scenario analysis and root cause.
1. Lack of a centralized system shutdown procedure, allowing specific background jobs or RFC connections to remain active in ECC. 2. Failure to communicate the exact stop work timestamp across global time zones, leading to regional teams working past the deadline. 3. External e-commerce or 3PL interfaces were not pointed to a holding queue and continued to feed data into the legacy production client. 4. Emergency users or support teams used their high-level authorization to bypass the transaction locks in ECC to fix a perceived issue. The failure is a result of treating the data freeze as a suggestion rather than a hard system state.
Why this is a migration, exclusive failure.
1. Standard ECC upgrades, EHP upgrades, typically happen in place, so there is no legacy versus new system discrepancy to manage. 2. S/4HANA brownfield conversion involves taking a snapshot of the database and transforming it. Any delta created after that snapshot is physically lost to the process. 3. The delta catch-up process for SD is notoriously complex and involves manual re-entry if the automated migration has already passed the transaction phase. 4. This failure only surfaces when the organization attempts to reconcile the final balance of the two systems on day one. Migration creates a point-in-time vulnerability that standard maintenance never encounters.
Financial and customer impact.
1. Revenue leakage occurs when missing invoices from ECC are never recreated in S/4HANA, resulting in services provided but not billed. 2. Inaccurate financial reporting, as the general ledger in S/4HANA is out of sync with the physical reality of the legacy system snapshot. 3. High operational cost, as a war room of consultants must manually identify and re-enter all leaked transactions into the live system. 4. Loss of customer trust when in-flight orders are lost, forcing the customer to place their order again or move to a competitor. Freeze mismanagement directly compromises the financial integrity sign-off of the migration project.
Governance and accountability, RACI model.
Managing the data freeze requires authority over both business and IT operations. 1. Accountable, Cutover manager owns the freeze protocol and has the authority to lock the systems and interfaces. 2. Responsible basis lead executes the technical locking of users' transaction SU10 and background jobs in the legacy system. 3. Consulted, integration architect ensures that all inbound middleware queues are paused and verified as empty. 4. Informed, Global Operations Director confirms that the business has finished all must-do activities before the freeze begins. Accountability ensures that the system lock is absolute and verified.
Ownership, who actually fixes it.
Resolving this requires a delta identification and manual reconciliation task. 1. Cutover Manager performs a post-freeze audit in ECC, checking for any document creation timestamps after the snapshot time. 2. SD Functional Lead creates a delta transaction list for all orders, deliveries, and invoices created during the leak period. 3. Data Migration Team utilizes the S/4HANA Migration Cockpit to perform a one-time delta load for the missing document IDs. 4. FICO Lead executes a reconciliation baseline to ensure the general ledger balances are manually adjusted for the missing value.
Who gets blamed versus who owns it.
1. Blamed Basis Team. The business assumes Basis did not lock the system correctly. 2. Blamed Business Users. IT assumes the users ignored the instructions. 3. Actual Owner Cutover Manager responsible for the failure to verify the system state before allowing the migration to proceed. 4. Root Cause treating the data freeze as a communication task rather than a technical enforcement task. If a user can log in during a freeze, the project plan is fundamentally flawed.
How this is actually fixed, the way by a role.
1. Basis Lead mandates a hard kill of all user sessions and changes the system status to not modifiable in transaction SCC 4. 2. Integration Architect implements queue blocking at the middleware layer to prevent external systems from pushing data into the SAP kernel. 3. The team implements a shadow client approach, where a read-only copy of ECC is available for inquiry while the conversion proceeds. 4. Functional Leads execute a zero delta check, comparing the row count of table VBAK at the snapshot time versus the cutover time.
What not to do, common wrong fixes.
1. Relying on an email instructions to keep users out. There will always be one user who just needs to finish one order. 2. Ignoring background job auto-restarts that might create new documents during the migration window. 3. Failing to check inbound IDOC queues. If the IDOC arrives during the freeze, it will process as soon as a basis admin unlocks a task. 4. Attempting to delete the leaked data in ECC after it was created. This makes the audit trail even more complex to reconcile. Shortcuts in freeze enforcement result in a dirty go-live that takes weeks to clean up.
Follow-up 1. What is the most effective way to technically enforce a data freeze in ECC?
Answer: the most effective way is to lock all users via transaction SU10, excluding basis and the migration user. Deactivate all RFC destinations, and set the client to no changes allowed in SCC4. Additionally, you should suspend the background job scheduler via transaction BTCTRNS1.
Follow-up 2. How do I handle urgent sales orders that must be processed during the 48-hour downtime?
Answer: you must establish a manual process for these orders. The business captures them on paper or in Excel. Once S/4HANA is live on Monday morning, these blackout orders are the very first documents entered into the new system. This ensures they follow the S/4HANA rules and are correctly captured in the new subledger.
Follow-up 3. Curveball. Can I use near zero downtime or NZDM to avoid the data freeze issue?
Answer: yes. SAP NZDM technology allows users to continue working in ECC while the conversion is running in the background. It uses Delta Replay technology to move the changes to S/4HANA. However, this is significantly more expensive and complex to set up, requiring specialized expertise.
Exclusive pro tip.
Include a snapshot audit step in your cutover runbook. 10 minutes after the freeze begins, run a query to find any record created in the last 10 minutes. If the result is not zero, stop the migration and identify the leaking interface immediately. It is much easier to fix a leak before you start the conversion than after.
Scenario 135. ATP category mapping issues.
In the technical conversion window of an ECC to S/4HANA migration, discrepancies in available to promise or ATP category mappings frequently disrupt supply chain visibility. S/4HANA introduces advanced ATP or AATP, which uses a different requirement handling logic compared to the legacy availability check. If the mapping of ECC requirement types and stock categories to the new S/4HANA ABAP business categories is inconsistent during the downtime, sales orders will fail to confirm stock, leading to incorrect delivery dates and missed shipments on day 1.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high supply chain and inventory impact. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems migrating from classic ATP to advanced ATP. 4. Primary ownership, SD functional lead and supply chain lead. 5. Supporting basis lead and technical architect. 6. Business ownership, supply chain planning director. 7. Relevant SAP note. SAP note 2321191. Advanced ATP simplifications.
Diagnostic dashboard, symptoms and evidence.
How ATP mapping failures manifest during the technical cutover. 1. Symptom, creating a sales order in S/4HANA results in 0 confirmed quantity despite the warehouse having physical stock on hand. 2. Red flag, transaction CO09, availability overview, shows stock in a not relevant for ATP category that was previously available in ECC. 3. Business impact, backorder processing or BOP jobs fail to run, leaving hundreds of high-priority orders without any stock allocation. 4. Detection, the availability check log in the sales order shows that specific requirement types are being ignored by the checking rule. 5. Technical proof, mismatches in table MDBS, MRP stock or requirements, where legacy ECC entries fail to be picked up by the S/4HANA ATP engine. Insight, ATP is more precise than classic ATP. If your mapping is vague, the system will default to no stock available as a safety measure.
Why this happens, scenario analysis and root cause.
1. Legacy ATP configuration in ECC often used custom requirement classes that do not have a direct one-to-one equivalent in the new S/4HANA business categories. 2. The project team fails to update the scope of check transaction OPJJ to include new S/4HANA stock types like stock in transit or quality inspection. 3. Migration tools move the sales order but do not re-trigger the availability check during the transformation, leaving documents with obsolete confirmation data. 4. Technical timeouts during the ATP index rebuild report SDRQCR21 result in a corrupted availability buffer during the downtime window. The failure is a result of treating ATP as a static setting rather than a dynamic execution engine.
Why this is a migration, exclusive failure.
1. ECC upgrades never change the fundamental ATP checking rules or the underlying requirement tables like VBBE. 2. S/4HANA migration involves a physical index transformation where the system moves from table-based checks to HANA-native memory-based checks. 3. The activation of a TP is a specific, one-time project event that completely replaces the classic checking logic for specific materials. 4. This failure only surfaces when the newly converted S/4HANA system attempts to calculate stock availability for the first time. Migration forces a reindex of the entire enterprise inventory that ECC never required.
Financial and customer impact.
1. Revenue loss occurs as sales reps are unable to promise delivery dates to customers, leading to canceled orders. 2. Operational inefficiency results in a warehouse backlog, as delivery documents cannot be created for confirmable orders. 3. Damaged customer relationships when the system incorrectly reports out of stock for items that are physically available. 4. Increased logistics costs, as the company is forced to ship via air freight to make up for system-driven delivery delays. ATP failures directly break the promise to the customer and disrupt the revenue forecast.
Governance and accountability, RACI model.
Managing availability requires a synchronization between SD and production planning. 1. Accountable supply chain planning director owns the customer fulfillment target and the accuracy of the stock confirmation. 2. Responsible SD functional lead configures the ATP checking rules and manages the mapping of requirement categories. 3. Consulted MM and PP functional lead validates that the supply sources, purchase orders and production orders are correctly considered. 4. Informed IT transformation director monitors the stock confirmation rate during the final cutover simulation, Accountability ensures that its settings do not override the physical ability to fulfill orders.
Ownership, who actually fixes it.
Resolving this requires an availability logic audit and index regeneration. 1. SD functional lead extracts the ECC scope of check and maps every category to the new ABAP business categories. 2. Technical architect utilizes report SDRQCR21 to rebuild the sales requirements index immediately after the technical conversion. 3. Supply chain lead performs a confirmed quantity reconciliation, comparing the confirmed totals in ECC against the S/4HANA results. 4. Basis lead monitors the ATP buffer performance in the HANA database to ensure zero latency during high-volume check requests.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead, the sales team assumes the availability config was messed up during the upgrade. 2. Blamed. Master data team, the business assumes the stock levels were not migrated correctly. 3. Actual owner, SD functional lead and supply chain lead jointly responsible for the failure to define the ATP category logic. 4. Root cause, treating the transition to ATP as a technical upgrade rather than a functional logic redesign. An ATP error is a logic mapping problem, not a data entry mistake.
How this is actually fixed, the way by a role.
1. SD functional lead mandates a backorder processing test run 24 hours before go live to verify stock allocation across all regions. 2. The team implements category mapping in the S/4HANA IMG, ensuring that ECC requirement types, like AR, are correctly recognized. 3. Technical architect executes the ATP snapshot verification, ensuring that the total confirmed quantity in S/4HANA matches the legacy ECC subledger. 4. Basis team applies SAP Note 2321191 to ensure the latest ATP performance patches are active in the system.
What not to do, common wrong fixes.
1. Manually overriding confirmed quantities in VA02 to bypass an ATP block. This will result in duplicate stock allocation and shipping errors. 2. Ignoring ATP warnings during the mock migration, assuming the system will heal itself once all documents are loaded. 3. Disabling the availability check for specific materials simply to get the orders through. This creates a warehouse logistics crisis. 4. Failing to run report SDRQCR21 because it takes too long. An outdated index is the primary cause of phantom stock errors. Shortcuts in availability logic will lead to a stock-out crisis in the first week of go-live.
Follow-up 1. What is the biggest difference between classic ATP and advanced ATP in S/4HANA?
Answer: Classic ATP was based on a simple cumulative calculation of stock and requirements. Advanced ATP or AATP is a HANA native engine that allows for characteristic-based allocation, backorder processing with priority strategies, and alternative plant substitution in real time, providing much more flexibility for complex supply chains.
Follow-up 2. Why do I need to run SDRQCR21 during the cutover window?
Answer: SDRQCR21 is the sales requirements recovery report. During a migration, the technical transformation of documents can leave the confirmed quantity in table VBBE out of sync with the physical document status. This report cleans the index and ensures that every order is correctly represented in the availability check.
Follow-up 3. Curveball. Can I use AATP for third-party or dropship orders?
Answer: yes. AATP can perform a third-party order availability check by communicating with the vendor's system or checking the purchase requisition status. This provides a unified fulfillment view that was previously difficult to achieve in classic ECC.
Exclusive pro tip.
Establish an ATP baseline 48 hours before go live. Record the total confirmed units for your top 10 materials in ECC. Immediately after the S/4HANA conversion, compare this to the total confirmed units in transaction CO09. If they do not match, your mapping logic is broken and you must stop the cutover.
Scenario 136. Background job conflicts.
In the technical conversion window of an ECC to S/4HANA migration, uncoordinated background jobs often derail the cutover timeline. While the system is in the middle of a physical table transformation, such as the KONV to PRCD underscore elements move, legacy background jobs for billing, credit reorg, or interface processing might automatically restart. This leads to massive database deadlocks, table locks, and the corruption of in-flight document data, forcing an immediate rollback of the conversion.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium system stability and cutover window impact. 2. Phase, deploy technical conversion window. 3. Frequency, extremely common in large global systems with complex job schedules. 4. Primary ownership basis lead. 5. Supporting SD functional lead and cutover lead. 6. Business ownership IT transformation director. 7. Relevant SAP note, not applicable cutover and basis execution. This is an IT operational and job scheduling failure.
Diagnostic dashboard, symptoms and evidence.
How job conflicts manifest during the conversion downtime. 1. Symptom: the SUM technical conversion tool hangs or displays the error unable to acquire exclusive lock on table PRCD underscore elements. 2. Red flag: transaction SM37 in the legacy ECC client or the shadow instance shows active jobs for billing or IDOC processing during the blackout period. 3. Business impact: the conversion downtime window is exceeded as basis teams are forced to manually identify and kill zombie background jobs. 4. Detection: checking transaction SM12 reveals hundreds of technical locks held by the background user WF batch or a system interface user. 5. Technical proof: system logs SM21 show database deadlock detected during the execution of a critical S4 HANA data transformation report. Insight: a single active job during the conversion window can turn a 48-hour migration into a 72-hour disaster.
Why this happens, scenario analysis and root cause.
1. The project team failed to execute transaction BTCTRNS1 to suspend the background job scheduler before starting the technical conversion. 2. Implicit background tasks triggered by the post-processing office or workflow were not factored into the system shutdown plan. 3. Interface jobs from external systems, middleware, were not stopped at the source, allowing them to re-trigger the SAP kernel during the downtime. 4. The system copy used for the conversion inherited the job schedule from the production ECC system without disabling the periodic flag. The failure is a result of technical collision, where legacy automation disrupts the migration engine.
Why this is a migration, exclusive failure.
1. ECC upgrades, EHP upgrades, typically happen in place and are less sensitive to data transformation locks. 2. S4 HANA migration involves a physical restructuring of tables. You cannot have a job reading KONV while the system is deleting it. 3. The use of the SUM shadow instance creates a unique risk where jobs might accidentally start in the shadow system during the uptime phase. 4. This failure only surfaces during the technical conversion phase of the S4 HANA brownfield path. Migration requires an absolute system silence that standard ECC maintenance never approach.
Financial and customer impact.
1. A failed conversion results in an immediate rollback, costing the company hundreds of thousands of dollars in lost project effort. 2. Risk of data corruption if a background job partially processes a document while the transformation engine is moving the same record. 3. Business disruption on Monday morning as users find that nightly billing jobs were interrupted and must be manually restarted. 4. Loss of management trust when the technical team cannot explain why the system crashed during the go-live window. Job conflicts are the silent killers of a successful cutover weekend.
Governance and accountability, RACI model.
Managing background jobs requires an integrated IT operations view. 1. Accountable basis lead owns the technical integrity of the job scheduler and the system lockdown protocol. 2. Responsible cutover manager defines the stop and start sequence for all business-critical background jobs. 3. Consulted SD functional lead provides the inventory of O2C jobs, billing, ABAP IDOCs that must be verified as finished. 4. Informed IT transformation director manages the downtime schedule and communicates delays to the executive board. Accountability ensures that the technical conversion engine has 100% of the system resources.
Ownership, who actually fixes it.
Resolving this requires a full job inventory and a technical shutdown. 1. Basis lead executes transaction BTC-TRNS-1 to suspend all periodic jobs and verifies the suspended status in table TBT company. 2. SD functional lead uses transaction SM37 to find in-process sales jobs and confirms with the business that they are safe to kill. 3. Technical architect ensures that all RFC destinations in transaction SM59 are locked to prevent external systems from triggering jobs. 4. The team performs a post-downtime cleanse, identifying any jobs that were interrupted during the conversion and manually rescheduling them.
Who gets blamed versus who owns it.
1. Blamed, basis team. The business assumes basis forgot to stop the jobs. 2. Blamed, SAP. The project team claims the SUM tool is not handling locks correctly. 3. Actual owner, basis lead and cutover manager, jointly responsible for the failure to define a hard system shutdown procedure. 4. Root cause, treating the conversion as a background process while ignoring the existing legacy automation layer. A job conflict is an operational planning failure, not a software bug.
How this is actually fixed, the way by a role.
1. Basis lead mandates a hard system lock post snapshot, where transaction SCC4 is used to prevent any logical data changes. 2. The team implements a job blackout list, identifying every periodic O2C job and assigning a specific cutover owner to each. 3. Technical architect utilizes kernel-level locks to prevent the background scheduler from starting any new tasks during the SUM execution. 4. Functional leads execute a job audit immediately after go-live, verifying that the first 50 background jobs started on schedule and without error.
What not to do, common wrong fixes.
1. Leaving inbound IDOC queues active. A single incoming EDI order will trigger a background task and block the table conversion. 2. Assuming that transaction BTC-TRNS-1 handles Z jobs and custom schedulers, you must manually verify custom job management tools. 3. Trying to restart a failed conversion step without checking SM12 for lingering locks first. 4. Failing to notify external partners to stop their data transmissions during the go-live weekend. Shortcuts in job management result in a dirty downtime that risks the integrity of your new S/4HANA system.
Follow-up 1. What is transaction BTC-TRNS-1, and why is it so important during cutover?
Answer: BTC-TRNS-1 is the job suspension transaction. It takes all scheduled periodic jobs and marks them as suspended in the system. This prevents the scheduler from starting any jobs while the technical conversion is running. After the cutover, you use BTC-TRNS-2 to release the jobs back into the schedule.
Follow-up 2. What happens if a job is killed by the technical conversion engine?
Answer: if a job is killed mid-process, you must perform a functional recovery. For example, if a billing job was killed, you must check the database to see which invoices were created and which were missed. You then manually reschedule the job for the missing subset to avoid duplicate or missing records.
Follow-up 3. Curveball. Can I use SAP Central Job Scheduling to manage my S/4HANA migration?
Answer: yes. Tools like SAP Redwood or SAP IBP can provide a unified view of the cutover. By integrating the technical conversion steps with the business job schedule in a central tool, you can automatically prevent conflicts and ensure that no business job starts until the basis team gives a technical completion signal.
Exclusive pro tip.
Establish a silent night protocol 4 hours before the downtime begins. All background jobs must be finished, and all RFC gateways must be closed. If transaction SM37 shows even one active job at the start of the SUM phase, stop the migration and identify the root cause immediately.
Scenario 137. SDFI integration mapping inconsistencies.
In the technical conversion window of an ECC to S/4HANA migration, the integration between SD billing and the financial general ledger frequently breaks during the universal journal transformation. While ECC allowed for slight discrepancies between SD condition values and FI postings, S/4HANA enforces a zero variance balance in the ACDOCA table. If the account determination mapping in transaction VKOA or the rounding rules in the pricing procedure are inconsistent with the new FICO ledger settings, the conversion engine will block the migration of billing documents, resulting in a failed financial reconciliation.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial integrity and cutover impact. 2. Phase, deploy technical conversion window. 3. Frequency, common in multi-currency and multi-ledger environments. 4. Primary ownership, SD and FICO lead. 5. Supporting basis lead and data migration lead. 6. Business ownership, corporate controller. 7. Relevant SAP note, not applicable cutover and basis execution. Refer to SAP Note 2349298 for Universal Journal ACDOCA context.
Diagnostic dashboard, symptoms and evidence.
How SDFI mapping errors manifest during the conversion weekend. 1. Symptom, the software update manager. SUM fails in the FINS_MIG_ledger_config phase with error balancing field profit center not filled. 2. Red flag billing documents created in ECC appear in S/4HANA but show a status of no accounting document with error FF709. 3. Business impact, inability to close the migration weekend on time due to unreconciled revenue balances between the SD subledger and the general ledger. 4. Detection, checking transaction VFX3 in the newly converted system reveals thousands of legacy invoices with account determination errors. 5. Technical proof, mismatches in Table BSEG versus Table VBRK for tax condition values that were previously tolerated in ECC. Insight, S/4HANA does not allow dirty postings. The integration must be mathematically perfect at the moment of conversion.
Why this happens, scenario analysis and root cause.
1. Legacy ECC account determination, VKOA, was mapped to accounts that have been converted to secondary cost elements or deleted in S/4HANA. 2. The move to the Universal Journal ACDOCA requires every SD line item to be assigned to a valid profit center and segment, which was often missing in legacy billing history. 3. Currency rounding differences between the SD pricing engine and the FI posting engine, which previously resulted in small penny variances, are now hard errors in S/4HANA. 4. Failure to align the tax account key mapping between SD and FI for new tax jurisdictions added during the migration project. The failure is a result of the S/4HANA Financial Core enforcing strict data integrity rules on legacy sales data.
Why this is a migration, exclusive failure.
In ECC upgrades, the SD and FI tables remained separate. An error in VKOA only blocked new invoices, not existing ones. 2. S/4HANA conversion physically transforms legacy SD billing rows into ACDOCA rows, requiring every historical record to pass a 100% validation check. 3. The technical step of document splitting and ledger alignment is a unique feature of the S/4HANA migration path. 4. This failure only surfaces when the conversion tool attempts to balance the legacy subledgers into the unified Universal Journal. Migration forces a reconciliation of 10 years of history in 10 minutes.
Financial and customer impact.
1. Revenue recognition is blocked for migrated orders, leading to massive variances in the first month-end financial statement. 2. Delayed cash application, as the system cannot link incoming payments to invoices that failed to post to accounting during migration. 3. Auditors may qualify the financial results if the company cannot prove the integrity of the SD to FI value transfer. 4. Increased IT costs, as FICO and SD consultants must manually repair VKOA mapping and reprocess thousands of documents in VFX3. Integration mapping errors directly compromise the enterprise single source of truth.
Governance and accountability, RACI model.
Closing the SDFI gap requires an integrated functional leadership. 1. Accountable corporate controller owns the financial accuracy of the revenue accounts and the audit sign-off. 2. Responsible SD and FICO lead jointly responsible for the VKOA mapping accuracy and the resolution of rounding variances. 3. Consulted Data migration lead ensures that the conversion logs provide the detail needed to identify the root cause of the mismatch. 4. Informed, IT Transformation Director monitors the financial reconciliation status during the cutover simulation. Accountability ensures that sales and finance are working toward the same number.
Ownership, who actually fixes it.
Resolving this requires a cross-module configuration sync. 1. FICO lead identifies all legacy GL accounts that are no longer valid for direct posting in S4 HANA. 2. SD functional lead updates the VKOA table with the new S4 HANA general ledger account numbers. 3. Technical architect utilizes report FIN S_recon_SD_FI to identify the specific document IDs that failed to transform. 4. Basis lead monitors the financial migration monitor and reruns the transformation jobs after the mapping is fixed.
Who gets blamed versus who owns it.
1. Blamed, SD lead the finance team assumes billing is sending the wrong data. 2. Blamed, SAP the business assumes the universal journal model is losing records. 3. Actual owner, SD and FICO lead jointly responsible for the failure to perform a subledger reconciliation in the legacy ECC system. 4. Root cause, maintaining unsynchronized account mappings in the legacy system for years. If the mapping was wrong in ECC, the error will be fatal in S4 HANA.
How this is actually fixed, the way by a role.
1. SD and FICO lead mandate a global account mapping workshop during the explore phase to align VKOA with the new chart of accounts. 2. The team implements substitution rules in FIGL to automatically assign profit centers to legacy SD documents during the migration. 3. Technical architect executes report FIN S_MIG_recon_core to find and fix rounding variances before the system is open to users. 4. Functional teams execute negative testing to ensure that if an account is missing, the system correctly blocks the document and provides a clear error message.
What not to do, common wrong fixes.
1. Manually forcing a balance in ACDOCA using SQL to bypass a migration error. This destroys the link between SD and FI. 2. Changing the field status of GL accounts to optional during the migration weekend to bypass profit center errors. This creates audit gaps. 3. Ignoring 1-cent rounding variances, assuming they are immaterial. S4 HANA will not allow the ledger to balance if these exist. 4. Failing to run the financial post-processing steps. Transaction FIN S_MIG_monitor before releasing the system. Shortcuts in SDFI integration result in a financial audit failure that will haunt the CFO for months.
Follow-up 1. Why is the balancing field profit center such a common error in S4 HANA migration?
Answer: S4 HANA requires every line item in the Universal Journal to be balanced by profit center and segment to support real-time financial reporting. In legacy ECC, profit center was often optional at the line item level. The conversion tool must derive this data for every historical billing document, and if the derivation fails, the document cannot migrate.
Follow-up 2. Can I use the rounding settings in the currency configuration to fix SDFI mismatches?
Answer: only partially. While you can adjust the decimal places and rounding rules, the underlying issue is usually a logic mismatch between the pricing procedure, SD, and the tax procedure, FI. You must ensure that both procedures use identical rounding algorithms to avoid the 1-cent variance error during migration.
Follow-up 3. Curveball. What happens if I have historical billing documents in ECC that were never posted to accounting?
Answer: you should either post them or delete them before the migration. S4 HANA conversion tools will attempt to reconcile every record in the VBRK table. If a document is in build status but has no accounting record, the system will flag it as a reconciliation error and may block the entire financial transformation.
Exclusive pro tip.
Establish a financial cleanroom 24 hours before the cutover. Run transaction FSR1 in ECC to prove the system is in balance. If it is not, stop the migration and fix the variance in ECC. You should never start an S4 HANA migration with an existing financial subledger imbalance.
Scenario 138. Differentiation category, dependent FS dataset errors.
In the technical conversion window of an ECC to S/4HANA migration, the customer-vendor integration synchronization often fails due to differentiation category conflicts. The S/4HANA business partner model uses differentiation categories for data that varies by organizational levels, such as sales org or company code. If the legacy customer master, KNA1, contains inconsistent attributes across different sales areas that the BP model cannot reconcile in a single financial services or FS dataset, the MDS_load_cockpit will trigger a dataset error, blocking the creation of the business partner.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high master data and technical integrity risk. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems with high-volume multi-org customer data. 4. Primary ownership, master data management lead. 5. Supporting SD functional lead and technical architect. 6. Business ownership, master data governance council. 7. Relevant SAP note. SAP note 2265093 and SAP note 2713963. Business partner approach and CVI master data sync.
Diagnostic dashboard, symptoms and evidence.
How differentiation category errors manifest during the cutover window. 1. Symptom. The CVI synchronization run in transaction MDS_load_cockpit stalls with the error data for differentiation category missing. 2. Red flag. Master data teams encounter errors in table BUT000 suggesting that the FS dataset cannot be initialized for a specific BP role. 3. Business impact. Inability to save customer master data in the new system, leading to a complete halt in order entry for specific global accounts. 4. Detection. Checking transaction MDS_PPO2 reveals objects stuck with the error inconsistent FS data found for partner. 5. Technical proof. Errors in table MDS_control_OBJ_HYS indicating that the business partner attributes for specific sales areas, table KNVV, are in conflict. Insight. The BP model is stricter than the customer model. If your sales area data is messy, the BP engine will reject it.
Why this happens, scenario analysis and root cause.
1. Legacy ECC allowed customer attributes like payment terms or Incoterms to be wildly different across sales areas without any centralized validation. 2. S/4HANA business partner roles, like FLCU01, use differentiation categories to manage these variances, and the FS dataset financial services requires a clean mapping. 3. Failure to initialize the BP-specific fields, like BP 1012 or BP 1013, for all relevant sales organizations during the CVI preparation phase. 4. Complex customer hierarchies in ECC where grandparent nodes have conflicting data compared to child nodes, confusing the BP grouping logic. The failure is a result of technical collision, where unreconciled legacy attributes fail the new BP model's integrity rules.
Why this is a migration, exclusive failure.
1. ECC upgrades never required a synchronization into a business partner model, so dataset inconsistencies remained hidden for decades. 2. S/4HANA migration involves a mandatory object transformation where every customer must pass through the CVI validation engine. 3. The concept of differentiation categories and FS datasets is unique to the S/4HANA BP architecture and did not exist in classic SD. 4. This failure only surfaces when the physical synchronization logic attempts to commit the BP record to the HANA database. Migration forces a level of master data standardization that ECC never approaching.
Financial and customer impact.
1. Inability to create sales orders for high-volume global customers, leading to a massive revenue deferral during the first week post-go-live. 2. Operational paralysis as master data teams must manually scrub and resync thousands of records in the live production system. 3. Incorrect credit limits or payment terms applied to customers if the BP record is partially created without the required FS data. 4. Severe loss of user trust in the business partner transaction as users find they cannot maintain customer data without error. Master data dataset failures directly compromise the reliability of the order-to-cash automation.
Governance and accountability, RACI model.
Resolving dataset errors requires a partnership between MDM and technical teams. 1. Accountable, master data management lead owns the final state of the business partner data and the sign-off on data consistency. 2. Responsible, data migration lead executes the CVI synchronization and manages the MDS_PPO2 error resolution queue. 3. Consulted, SD functional lead provides the business rules for resolving conflicting attributes across different sales areas. 4. Informed, IT transformation director monitors the master data load percentage as a key go-live readiness indicator. Accountability ensures that data errors are resolved at the source rather than through technical hacks.
Ownership, who actually fixes it.
Resolving this requires technical BP tuning and data normalization. 1. MDM lead identifies the specific differentiation categories that are causing the sync error, for example, sales area versus company code. 2. Technical architect utilizes transaction BUSP to ensure the BP views and datasets are correctly configured for the target S4 HANA release. 3. SD functional lead executes a data normalization exercise to ensure consistent payment and tax terms for global customers. 4. Basis lead applies SAP Note 2713963 to update the CVI engine with the latest technical dataset fix reports.
Who gets blamed versus who owns it.
1. Blamed data migration team. The business assumes the load tool is corrupting the master data. 2. Blamed SAP. The users claim S4 HANA is too complex because it rejects valid ECC data. 3. Actual owner, master data management lead responsible for the historic failure to enforce cross-org data consistency in the legacy system. 4. Root cause, decades of acceptable inconsistency in ECC being exposed by the strict S4 HANA BP validation framework. A dataset error is a master data governance failure, not a software bug.
How this is actually fixed, the way by a role.
1. MDM lead mandates a data scrub in the legacy ECC system using report CVI_upgrade_check_resolve to find dataset conflicts. 2. The team implements cross-field validations in the CVI mapping, transaction CVI_customizing, to ensure consistent data flow. 3. Technical architect utilizes report MDS_load_cockpit with the force initialization flag to reset the BP dataset for failed partners. 4. Functional leads perform high-volume synchronization tests during the mock migration to identify regional dataset bottlenecks early.
What not to do, common wrong fixes.
1. Disabling mandatory field checks in the BP configuration just to pass the CVI check. This will break billing and tax later. 2. Attempting to manually update the BUT000 table via SQL to fix a dataset error. This will leave the BP record in a permanently corrupted state. 3. Ignoring errors in the PPO2 queue, assuming they will self-heal after the next system restart. 4. Allowing multiple users to manually maintain the same customer record during the final CVI synchronization weekend. Shortcuts in BP dataset management will lead to a permanently fragmented master data environment.
Follow-up 1. What is a differentiation category in the S4 HANA business partner model?
Answer: in S4 HANA, a business partner can have many roles. Data that is common across all roles is general data. Data that changes based on sales org or company code, like currency or payment terms, is differentiated. The system uses differentiation categories to keep these data sets separate but linked to one central partner.
Follow-up 2. Why do FS dataset errors only appear during the actual conversion downtime?
Answer: during development and unit testing, you typically migrate a few records. Dataset errors are often volume-sensitive or triggered by specific regional data patterns. In the final conversion downtime, the system processes 100% of the production data, exposing every obscure dirty data scenario that the sandbox never encountered.
Follow-up 3. Curveball. Can I use S/4HANA Master Data Governance, or MDG, to fix these errors?
Answer: yes. SAP MDG is the ideal solution for this. MDG can enforce data quality rules that prevent inconsistent datasets from being created in the first place. If you have MDG, you can fix the errors in the MDG staging area before they ever reach the physical business partner tables in S/4HANA.
Exclusive pro tip.
Before starting the realize phase, run report CVI_check_data_consistency in your ECC production system. This report identifies records where the sales area data contradicts the company code data. Fixing these logical conflicts in ECC will reduce your CVI error rate by 80% during the go-live weekend.
Scenario 139. Revenue Contract Migration Runtime Failures.
In the technical conversion window of an ECC to S/4HANA migration, the transition of legacy revenue schedules often triggers critical runtime failures. S/4HANA deprecates classical SD revenue recognition and moves data into SAP Revenue Accounting and Reporting, or RER. During the physical data transformation phase, the conversion reports must reconcile every historical revenue posting in table VBREV with the new subledger. If the volume of open contracts is massive, or if there are circular references in historical contract modifications, the conversion engine will suffer from memory overflows and job cancellations.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial compliance and technical runtime risk. 2. Phase, deploy technical conversion window. 3. Frequency, common in industries with long-term contracts or complex billing plans. 4. Primary ownership, FICO and SD functional lead. 5. Supporting basis lead and data migration lead. 6. Business ownership, corporate controller. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue recognition transition.
Diagnostic dashboard, symptoms and evidence.
How revenue migration runtime failures manifest during the downtime window. 1. Symptom, the software update manager, or SUM conversion step for revenue recognition, remains in running status for 24 hours without progress. 2. Red flag, technical logs in transaction ST22 show the dump TSV_TNU_page_alloc_ failed during the revenue subledger migration. 3. Business impact. The conversion weekend window is exceeded, forcing a high-stakes decision to either skip revenue history or roll back the entire migration. 4. Detection. Error logs in the Revenue Accounting Item or RI monitor show thousands of records stuck in processing with no commitment to the database. 5. Technical proof. Database monitors show a massive bottleneck on table FRR_D_ contract during the inception-to-date calculation logic. Insight. Revenue migration is the most memory-intensive financial transformation in S/4HANA. It requires a performance-tuned database.
Why this happens, scenario analysis and root cause.
1. Legacy ECC systems often contain 20 years of revenue history that was never archived, creating a massive data load for the conversion engine. 2. The S/4HANA transformation logic attempts to recalculate the entire lifecycle of a contract to ensure IFRS 15 compliance, which is CPU-intensive. 3. Basis teams often use standard background work process settings that are insufficient for the parallelization requirements of SAP RER migration. 4. Legacy data inconsistencies in ECC table VBREV, such as duplicate posting periods for the same item, cause the transformation logic to enter an infinite loop. The failure is a result of technical resource exhaustion, combined with legacy data complexity.
Why this is a migration, exclusive failure.
1. ECC upgrades never touch the revenue recognition data. The VBREV schedules remain static regardless of the version upgrade. 2. S/4HANA migration involves a mandatory physical data reevaluation, where legacy schedules are decommissioned and replaced by RER contracts. 3. The Specialized Migration Report, FIN_S_MIG_revenue_REC, is a one-time technical tool used only during a brownfield system conversion. 4. This failure only surfaces when the conversion tool attempts to build the new revenue subledger from historical SD events. S/4HANA forces a recalculation of the company's financial history that no other upgrade ever attempted.
Financial and customer impact.
1. Material financial risk, as the company may be unable to prove the accuracy of its revenue recognition to external auditors post-go-live. 2. Delayed go-live results in a total loss of sales order processing capability, leading to immediate cash flow disruption. 3. Inaccurate deferred revenue balances on the balance sheet can trigger a restatement of earnings and a loss of investor confidence. 4. Operational cost increases, as the revenue accounting team must work 80-hour weeks to manually reconstruct contracts that failed to migrate. Revenue runtime failures directly jeopardize the financial certification of the migration project.
Governance and accountability, RACI model.
Surviving the revenue migration requires absolute coordination between finance and basis. 1. Accountable, corporate controller owns the final revenue values and the decision to proceed with the financial cutover. 2. Responsible, SD and FICO lead jointly responsible for the accuracy of the revenue mapping and the resolution of logic errors. 3. Consulted, basis lead optimizes the server resources and monitors the runtime performance of the conversion jobs. 4. Informed, CFO manages the risk communication to the board regarding potential go-live delays. Accountability ensures that technical bottlenecks are treated as financial risks.
Ownership, who actually fixes it.
Resolving this requires technical system optimization and financial data pruning. 1. Basis lead increases the ABAP and shared objects size MB parameters to provide enough memory for the RAR conversion engine. 2. SD functional lead executes report VBREV cleanup in ECC to remove duplicate or inconsistent revenue records before the final snapshot. 3. Technical architect configures blockwise processing for the revenue migration to prevent the engine from attempting to load all data at once. 4. FICO lead performs a financial dry run in a production copy environment to verify the runtime duration for the full data volume.
Who gets blamed versus who owns it.
1. Blamed, basis team. The project board assumes the server is not powerful enough to handle the migration. 2. Blamed, SAP. The business assumes the migration tooling is defective. 3. Actual owner, SD and FICO lead responsible for the failure to analyze and archive historical revenue data prior to the migration. 4. Root cause, underestimating the technical complexity of transforming 10 years of account-based revenue into contract-based revenue. A runtime dump in revenue is usually a data volume management failure.
How this is actually fixed, the way by a role.
1. FICO lead mandates a hard date cutoff for revenue history, only migrating data from the last 2 audited years to reduce volume. 2. The team implements parallel processing groups for the revenue accounting items, distributing the load across multiple application servers. 3. Technical architect applies SAP Note 26555093 and SAP Note 27714883 to ensure the latest RAR migration performance patches are active. 4. Basis lead monitors the HANA memory peak during the conversion and provides a dedicated high-memory work process for the revenue job.
What not to do, common wrong fixes.
1. Killing the conversion job and attempting to skip the revenue transformation to save time. This will result in a permanently corrupted general ledger. 2. Assuming that a success status in the technical logs means the financial values are correct, you must perform a value reconciliation. 3. Increasing the timeout parameter without addressing the memory bottleneck. The system will simply dump later and waste hours of downtime. 4. Failing to run the inception-to-date reconciliation reports provided in SAP Note 2225170. Shortcuts in revenue migration will lead to a financial restatement that can cost the company millions.
Follow-up 1. Why does S/4HANA move revenue from account-based to contract-based?
Answer: account-based recognition in ECC was limited. It could not easily handle multi-element arrangements or contract modifications. S/4HANA uses the Performance Obligation or POB model, which is the international standard for revenue accounting. This allows for real-time compliance with IFRS 15 and ASC 606 regulations.
Follow-up 2. What is a technical commit error in revenue migration?
Answer: a technical commit error happens when the system has transformed the data, but cannot save it to the database because of a lock conflict or a log file overflow. This is common during the final cutover, when multiple modules are pushing data into the universal journal at the same time.
Follow-up 3. Curveball. Can I use S/4HANA event-based revenue recognition for my open ECC contracts?
Answer: only if you perform a complete redesign. Event-based recognition is not a direct migration path for legacy SD revenue recognition. You must choose between migrating to RER, the standard path, or closing your legacy contracts in ECC and starting fresh with event-based recognition in S/4HANA.
Exclusive pro tip.
Perform a volume stress test specifically for revenue recognition in your last mock migration. Use the exact number of open contracts from production and measure the downtime consumption. If the runtime exceeds 20% of your total window, you must mandate additional data pruning or server parallelization immediately.
Scenario 140. Flexible workflow activation sequencing errors.
In the deploy phase of an ECC to S/4HANA migration, the activation of the new flexible workflow engine often triggers operational blockers. S/4HANA replaces legacy O2C approval logic with a modern, Fiori-based workflow framework. If the technical activation of these scenarios via transaction SWF_flex_activate is performed out of sequence, or if the team and responsibility management links are not established before users log in, sales orders and billing documents will be deadlocked with no visible approval path, paralyzing the order fulfillment process.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium to high process automation and cash flow impact. 2. Phase, deploy technical conversion window. 3. Frequency, common in systems with decentralized sales approval structures. 4. Primary ownership, SD functional lead and workflow developer. 5. Supporting basis lead and SAP Fiori lead. 6. Business ownership, sales operations manager. 7. Relevant SAP note. SAP note 2, 198647. Custom code adaptation context for workflow.
Diagnostic dashboard, symptoms and evidence.
How workflow sequencing errors manifest during the final go-live. 1. Symptom. Users create high-value sales orders, but the documents go into an in-process status with no approval task appearing in any manager's inbox. 2. Red flag. The Manage Workflows Fiori app shows a status of inactive for O2C scenarios that were supposed to be live. 3. Business impact. Urgent customer orders are blocked from delivery on day 1 because the approvers cannot see or release the documents. 4. Detection. Checking transaction SWF_process_. Admin shows workflow instances in error status due to no agent found for the initial step. 5. Technical proof. Errors in the workflow trace indicating that the runtime environment was not initialized before the first transaction was saved. Insight. Flexible workflow is a system-wide switch. If you turn it on without defining the recipients, you effectively block the entire sales pipeline.
Why this happens, scenario analysis and root cause.
1. The project team treats workflow activation as a configuration transport task rather than a cutover execution task. 2. Failure to synchronize the workflow scenario activation with the team and responsibility data load. One requires IMG settings, the other requires Fiori master data. 3. Background RFC users, like WF Batch, were not properly authorized in the new S/4HANA production system before the workflow was triggered. 4. The task gateway used by the Fiori My Inbox app was not fully configured during the downtime, preventing managers from seeing pending approvals. The failure is a result of technical sequencing gaps during the high-pressure cutover weekend.
Why this is a migration, exclusive failure.
1. ECC Business Workflow SWDD was triggered by stable events, BOR objects, that rarely required post-upgrade activation. 2. S/4HANA Flexible Workflow is a new metadata-driven architecture that requires explicit activation of scenarios in every target system. 3. The move from hard-coded agents to responsibility management is a fundamental architectural shift unique to the S/4HANA migration path. 4. This failure only surfaces when the newly converted S/4HANA system encounters its first approval-relevant document. Migration turns a technical background task into a mandatory cutover milestone.
Financial and customer impact.
1. Operational paralysis on day 1 leads to missed shipment windows and potential late delivery penalties. 2. Revenue is frozen in the system because billing documents cannot be released by managers who are unaware of the pending tasks. 3. Customer frustration peaks when urgent orders are delayed for 48 hours due to a missing system notification. 4. Loss of management trust in the new Fiori UI, as approvers are forced back into the legacy SAP Office inbox as a workaround. Workflow sequencing errors directly block the physical and financial movement of goods.
Governance and accountability, RACI model.
Managing the workflow cutover requires a triple sync between SD, workflow, and UX teams. 1. Accountable, SD functional lead owns the final O2C approval process and the release of orders on day 1. 2. Responsible, workflow developer executes the technical activation of scenarios and ensures the agent logic is active. 3. Consulted, SAP Fiori and UX lead ensures that the My Inbox app is 100% functional for all manager roles. 4. Informed, IT Transformation Director monitors the workflow error queue during the first 24 hours of live operation. Accountability ensures that system readiness includes user notification readiness.
Ownership, who actually fixes it.
Resolving this requires a config data user activation sequence. 1. Workflow developer executes transaction SWF_flex_activate to ensure all O2C scenarios, for example, WS00800299, are technically active. 2. SD functional lead utilizes the Manage Teams and Responsibilities Fiori app to load the final list of approval agents for each region. 3. Basis lead ensures that the workflow background user, WF batch, has full authorization for sales and billing document processing. 4. Fiori lead performs a day 1 notification test, triggering a dummy approval and verifying the alert appears on a manager's mobile device.
Who gets blamed versus who owns it.
1. Blamed, workflow developer. The business assumes the logic for the approval was not migrated correctly. 2. Blamed, training team users claim they were never shown how to use the My Inbox app. 3. Actual owner, SD functional lead and workflow developer jointly responsible for the failure to define the activation sequence in the cutover plan. 4. Root cause, treating workflow as a technical transport rather than a live functional event that requires master data links. Workflow success is 10% code and 90% configuration and agent mapping.
How this is actually fixed, the way by a role.
1. SD functional lead mandates a workflow readiness audit 4 hours before the system is open to users. 2. The team implements manual fallback agents in the workflow configuration to ensure orders are routed to a super user if the regional manager is not found. 3. Workflow developer utilizes transaction SWF_process_admin to perform a mass restart for any documents that errored out during the first hour of go live. 4. Fiori lead execute a launchpad health check, verifying that the My Inbox tile shows the correct count of pending documents for 10 test personas.
What not to do, common wrong fixes.
1. Manually releasing orders in the database using SQL to bypass a workflow block. This destroys the audit trail and violates financial controls. 2. Ignoring workflow error logs during the mock migrations, assuming they are just test data issues that will go away in production. 3. Attempting to use legacy ECC agent groups in a S/4HANA flexible workflow scenario. They are technically incompatible. 4. Opening the system to sales users before the team and responsibility data load is confirmed as 100% complete. Shortcuts in workflow activation will lead to an immediate margin and compliance crisis.
Follow-up 1. What is the mandatory activation sequence for flexible workflow in S/4HANA?
Answer: the sequence is 1. Technical activation of the scenario SWF_flex_activate. 2. Configuration of the workflow steps and conditions, Fiori app. 3. Loading of the team and responsibility master data, Fiori app. And 4. Initialization of the task gateway basis. If you do not follow this order, the workflow will fail to find agents.
Follow-up 2. Can I use email notifications for flexible workflow approvals?
Answer: yes. SAP provides standard email templates that can be triggered when a work item is created. However, the manager must still log into the Fiori My Inbox or use SAP Mobile Start to physically perform the approve or reject action. The email is just the alert. The action happens in the S/4HANA Digital Core.
Follow-up 3. Curveball. What happens if a sales order triggers multiple workflows simultaneously?
Answer: in S/4HANA, workflows are processed sequentially based on priority. You must configure your scenarios so that they do not collide. For example, the credit approval should happen first, and once released, the price approval is triggered. This ensures a clean and auditable approval chain.
Exclusive pro tip.
Add a workflow smoke test to your Cutover runbook. 1 hour before go live, create one approval-relevant order for every region. Verify that the work item lands in the correct manager's inbox. If it does not, you have a mapping error that must be fixed before the sales team starts their day.
Scenario 141. HANA 2.0 index. Rebuild conflicts during SD table conversion.
In the final hours of the technical conversion window, the HANA database performs an automatic index rebuild for massive SD tables like VBFA and PRCD_elements. Because S/4HANA utilizes HANA 2.0 column store features, these indexes are critical for system performance. If the basis team initiates the post-conversion release to users, while these background index threads are still active, the system will suffer from catastrophic lock contention, causing sales transactions to hang and potentially corrupting the database metadata.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high database integrity and performance risk. 2. Phase deploy technical conversion window. 3. Frequency common in VLDB very large database environments. 4. Primary ownership basis lead. 5. Supporting SAP technical architect. 6. Business ownership IT transformation director. 7. Relevant SAP note 1813245, HANA index rebuild.
Diagnostic dashboard, symptoms and evidence.
How index rebuild conflicts manifest immediately after conversion. 1. Symptom: the first users to log and report that transaction VA01 hangs indefinitely at the saving spinner. 2. Red flag: HANA Studio or Cockpit shows hundreds of threads in object lock wait status targeting the main SD tables. 3. Business impact: a false start go live where the system is technically up but functionally unusable, forcing a temporary relock of all users. 4. Detection: checking the HANA index server alerts reveals high CPU usage for background merging and delta merge tasks. 5. Technical proof: statistics in table sys.m_table_statistics show that loaded status for large SD tables is set to false while the index is being built. Insight: HANA speed is dependent on its indexes. If the index is under construction, the database is effectively paralyzed.
Why this happens, scenario analysis and root cause.
1. The Software Update Manager, or SUM, completes the technical move of data, but the HANA database requires a secondary post-processing phase to optimize the column store compression. 2. Basis teams are often under extreme pressure to return the system to the business and skip the database stability verification step. 3. Massive tables like VBFA document flow can take several hours to reindex after a physical transformation like the S/4HANA migration. 4. Failure to disable parallel delta merges, which can collide with the primary index rebuild during the high-pressure cutover window. The failure is a result of technical impatience overriding database physics.
Why this is a migration, exclusive failure.
1. ECC upgrades on traditional databases, Oracle or SQL Server, used B-tree indexes that were updated row by row during the upgrade. 2. S/4HANA migration involves a columnar transformation where the entire table structure is flattened and then recompressed. 3. This specific delta merge and index rebuild process is a unique requirement of the SAP HANA database architecture. 4. This failure only occurs during the first few hours after a full S/4HANA brownfield conversion. HANA 2.0 introduces a level of database layer complexity that legacy ECC DBAs are often unprepared for.
Financial and customer impact.
1. Delayed first morning operations lead to a backlog of customer orders that can take days to clear. 2. Potential data corruption if the system is hard restarted while an index rebuild is in a critical commit phase. 3. Reputational damage to the IT organization when the fast new system performs worse than ECC in the first hour of go-live. 4. Loss of revenue if e-commerce interfaces time out because the S/4HANA database cannot acknowledge the order save fast enough. Database contention on day 1 is the fastest way to lose business confidence in the S/4HANA investment.
Governance and accountability, RACI model.
Ensuring database readiness requires a technical gatekeeper. 1. Accountable basis lead owns the database health and the final technical release of the system to the functional teams. 2. Responsible database administrator monitors the index rebuild threads and performs the manual delta merges if required. 3. Consulted technical architect validates that the system performance meets the go-live baseline before opening ports. 4. Informed IT transformation director manages the communication to the business regarding the exact handover time. Accountability ensures that system up actually means system ready.
Ownership, who actually fixes it.
Resolving this requires database-level orchestration and monitoring. 1. Basis lead monitors the HANA cockpit to verify that all background delta merges have been completed for the SD table set. 2. Database administrator utilizes SQL commands to manually trigger and optimize run on the PRCD_elements table if the automatic process stalls. 3. Technical architect performs a technical smoke test, executing one VA01 and one VF01 transaction to verify database response times. 4. IT director refuses to open the system to the full user population until the HANA CPU idle time reaches a stable baseline.
Who gets blamed versus who owns it.
1. Blamed basis team the business assumes the server is underpowered. 2. Blamed SAP the users claim HANA is a myth because the system is slow. 3. Actual owner basis lead responsible for the failure to include database stabilization time in the cutover schedule. 4. Root cause underestimating the post-conversion overhead of the HANA 2.0 columnar engine. A slow system on day 1 is usually a database tuning failure, not a configuration bug.
How this is actually fixed, the right way by a role.
1. Basis lead mandates a 4-hour system soak period after the SUM conversion is finished to allow for index stabilization. 2. The team implements preemptive delta merging for the 50 largest tables immediately after the data load. 3. Technical architect applies SAP Note 1813245 to optimize the HANA parameter settings for load-based merging. 4. Functional leads execute volume tests using automated scripts in the final hour of downtime to warm up the HANA database buffer.
What not to do, common wrong fixes.
1. Opening the system to 1,000 users while the index rebuild log shows 90% CPU usage. This will trigger a system crash. 2. Restarting the HANA database to clear the locks. This actually deletes the indexes currently in memory and restarts the rebuild from 0. 3. Assuming that a technical success message from the SUM tool means the database is optimized for user traffic. 4. Ignoring high disk I/O alerts in the first hour, assuming it is just post-go-live noise. Shortcuts in database stabilization result in an immediate and public system failure.
Follow-up 1. What is a delta merge, and why does it impact SD performance?
Answer: HANA stores data in 2 parts, a main read-optimized section and a delta write-optimized section. When you migrate millions of sales orders, the data lands in the delta section. A delta merge moves that data to the main section and builds the indexes. If this happens while a user is trying to save an order, they will experience a lock-weight error.
Follow-up 2. How long does an index rebuild typically take for a 1 terabyte SD table?
Answer: it depends on the CPU power of your HANA appliance, but for a massive table like VBFA, it can take anywhere from 30 minutes to 3 hours. This quiet time must be built into your Cutover runbook to avoid day 1 performance spikes.
Follow-up 3. Curveball. Can I warm up the HANA database to prevent this?
Answer: yes. SAP provides HANA table preload settings. However, a better way is to run your most frequent read transactions, like VA05 or VL060, using a background user immediately after conversion. This forces the system to load the tables and indexes into memory before the real users arrive.
Exclusive pro tip.
Add a database readiness checkpoint to your go-no-go meeting. Do not allow the project manager to announce system live until the basis lead confirms that the HANA Delta merge queue is empty for all tables in the SD and FI schemas.
Section 4. Wrap-up. Data migration strategy and governance.
Section 4 has demonstrated that data is the fuel for your S/4HANA engine. We analyzed how mismanaged data scopes, poor archiving decisions, and incomplete master data cleansing lead to technical roadblocks. The lesson is clear. Data governance is not a one-time activity during migration. It is a prerequisite that determines whether your business partner synchronization and financial reconciliation will succeed or fail.
Part 2. Wrap-up. The IT Crucible.
We have successfully completed Part 2 of our Masterclass. We have navigated the technical challenges of custom code remediation, solved the high-stakes data migration strategy errors, and analyzed the high-pressure incidents that occur during the conversion window itself. Your S/4HANA system is now technically live, and the database is stable. But the real test is just beginning.
Masterclass Series Navigation.
This concludes Part 2, the IT Crucible. To build a complete 360-degree understanding of the S/4HANA migration landscape, ensure you watch the other segments of this series. Part 1, the Blueprint and Data Model Shock, covering strategic scope and architectural design risks. Part 3, Transition to Live, focused on testing gaps, cutover sequencing, and day 1 logistics execution. Part 4, the Revenue Engine, analyzing billing, revenue accounting, HANA performance, and post-go-live ghost issues. Did you miss the other parts? Check the video description for direct links to the full 4-part series.
Transition to Part 3, Day 1 Operational Failures.
The system is open, and users are logging in. In Part 3, we move from the technical backend to the operational frontline. We will cover 85 incidents focused on testing gaps, cutover sequencing, and the functional behavioral shifts that happen when real business transactions hit the new S/4HANA digital core. We will see why orders stop flowing, why deliveries fail to split, and how cross-module integrations break under real-world pressure.
Complete your architecture training.
A true solution architect understands the entire lifecycle from blueprint to stabilization. If you are joining us mid-series, go back and watch Part 1 to understand the foundational risks. If you are ready to see how the system behaves once the doors are open to users, move on to Part 3 and Part 4 now. All links are available in the description below.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers. Required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.